సెట్ అయిపోయింది ఆన్ అవుతుంది ఆన్లో అప్డేట్ అయ్యింది చేశాను ఆల్రెడీ కెమెరా వీడియో
Yeah, good morning. Good morning, Dr. Celia. I'm Dr. Anita Shila. Hi.
Good morning, Dr. Anita. Nice to see you.
Same with you. I believe you all need to join. Dr. Lalita has joined, I believe. Dr. Lalita, good morning. After a long time.
Yeah. Hi, Dr. Anita. Hi, Dr.
Hi,
Celia.
ma'am.
Hi, Dr. Padmasai garu.
Are you able to hear my voice, ma'am?
Yes.
Yeah, ready.
Good morning to all of you, ma'am. Very happy
Good
to
morning.
see all of you. Antashila ma'am, Celia ma'am, Lalita ma'am, Anil sir. Welcome to all of you for panel discussion. I welcome our faculty, Senior Assistant Professor of ECE, Archana Bange. She will introduce all the speakers present here. Good morning to all the participants joining online and offline. Thank you, ma'am, for accepting our invitation.
No, it's a great effort. Thank you.
Good morning, one and all. So, I welcome you all to the third day of IEEE SPS event on latest trends in machine learning for signal processing. So today we have a galaxy of stalwarts who are stalwarts in this area, and they have joined for a interesting event of panel discussion titled Challenges and Open Discussion for Machine Learning in Signal Processing. So let me have the privilege of introducing all the members. So let's start with a very vibrant personality, Dr. Celia Shahnaz ma'am. She is an IEEE member, fellow IEB, received her PhD degree from Concordia University, Canada, and is currently a professor at the Department of Electrical and Electronic Engineering, Bangladesh University of Engineering and Technology. Ma'am has published more than 150 international journals, conference papers. She is a recipient of Canadian Commonwealth Scholarship Fellowship and Bangladesh Academy of Science Gold Medal for her contribution in science and technology. Her research interests include the areas of signal processing for speech analysis and speech enhancement, audio-visual recognition for biometric security, control system, robotics, pattern recognition, machine learning, and deep learning for audio-video biomedical power signals, multimodal emotion recognition, and humanitarian technology. She has received a number of awards, including IEEE Benethon 2019, the Biomedical Engineering track at 10Con 2017. So, ma'am has a very elaborate profile. I would just cut down short for the time we have. She has served as an editorial board IET signal processing from 2018 to date and 2018-20 member. She has more than 20 years of experience in leading impactful technical, professional, educational, industrial, women empowerment and humanitarian technology, power and energy related projects at national, international levels. We welcome you, ma'am. Next, we have an active personality, Dr. Anil Kumar Gopala from IIIT Hyderabad. Sir has received his BTech in Electronics and Communication Engineering from JNTU, Hyderabad, India in 2005. MTech in Electronics and Communication Engineering from NIT Kurukshetra in 2007 and PhD in Signal Processing from IIT Kharagpur 2012. From March 2012 to June 2019, he has worked as Assistant Professor at IIIT Hyderabad. From July 2009, from July 2019 onwards, he is working as Associate Professor at IIIT Hyderabad. His research interests lie primarily in speech processing in mobile and practical environments. He has published more than 100 papers in reputed journals and conferences. He is currently handling 2 sponsored projects and completed 9 funded projects. He is guiding 4 full-time PhD students and 7 MS students. He successfully guided 4 PhD students and he has given more than 100 invited talks in workshops and conferences. I welcome you, sir.
Thank you.
Next we have Mr. Yel Satish, sir, and he has completed his PhD from University of Hanover, Germany in 2005 in domain of computer and multimedia architectures. Since then, he has been with semiconductor industry for more than 17 years and currently he is driving graphics and ML/AI architectures for next generation products. We welcome you, sir.
Thank you.
Next, we have Dr. Ramji Pelela, sir. He is placed as Chief Operating Officer at Incubation Center of CCMB Hyderabad 2018. Prior to this, sir has worked as Chief Manager, Grants Management Division of IKP Knowledge Park from 14 to 2018, primarily to work for Big of Bairak. Earlier, he has been a research scientist and project manager at DBT ICGEB Center for Advanced Bioenergy Research, ICGEB, New Delhi. And sir has done his PhD from Osmania University, Hyderabad, and completed his postdoctoral studies at South Korea, spanning from 2009 to 12. He has also done his PG diploma in patents law from National Academy of Legal Studies and Research, University, Hyderabad. Sir has completed MBA from Pondicherry University 2014. So he has received accolades for his scientific excellence and he is marked with more than 40 research publications in varied national and international journals and books. So we welcome you, sir. Next, we have Dr. Lalita Vadlamani, Professor IIIT and also Chair SPS IEEE Hyderabad. Ma'am has completed PhD in Electrical Communication Engineering in 2015 from Indian Institute of Science, Bangalore. Her thesis was coding schemes for distributed subspace computation, distributed storage, and local correctability. She has guided many PhDs and is also having a lot of experience in terms of carrying out many projects. So last but not the least, we have Dr. Anita Sheila ma'am as moderator, who is professor and head of EC, Department of Electronics and Communication, JNTH College of Engineering, Hyderabad. We welcome you, ma'am. So Anita Sheila ma'am, you can take over.
Yeah. Thank you. A small correction. Recently, I was relieved as HOD by successfully completing 3.5 years as head of the department.
Sure.
Yeah, thank you. Thank you for the introduction. And first of all, let me thank the organizers for giving me this opportunity to discuss some aspects related to machine learning and signal processing with experts in the field like Dr. Celia, Dr. Lalita, Dr. Anil, and also we do have Mr. Satish and Dr. Ramji also on board. We welcome from the SPS Society also, welcome you all for this panel discussion, which I believe will try to make it as comfortable as possible and more learning. So to start with, as all of us, a brief thing, what I felt is like, we have been working in the field of machine learning for long, where we were trying to make out the features features in such a manner that they are more robustic, translation, rotation, invariant, and all. And the concerned engineers, I have been in that field for more than 15 years, where we were trying for speech signal processing, biomedical, feature extraction, and then trying for the regular classifiers, SVMs, GMMs, and all. Suddenly, for the last 10 years, I believe deep learning has come into picture, and convolution neural networks have taken over. And people started telling, you don't have to be there on board. CNN will take care of the feature extraction. So directly give the data, whatever data it is, whether it is spatial, temporal, or spatio-temporal data. So CNN will take care. So we can replace you, sort of. Do you feel that can we be replaced? Like, is the first question that even I am feeling now. Are we become obsolete, like the concerned signal processing engineers who are good at extracting the features from making the brain? So over to Celia, Dr. Celia, do you feel that we became obsolete in terms of feature extraction?
Thank you, Dr. Anita, for giving me the floor. And first of all, I like to thank Signal Processing Chapter and Signal Processing Student Run Chapter at Hyderabad for organizing this vendor school. And that's a very good initiative to bring together virtually all people to train the next generation. Actually, for signal processing, it is really very important to know the interpretation of the data. Signal processing really taught us what is the characteristics, what is the feature, and in which direction we are going. And it's also showing us the unique feature for a particular application. So there are a lot of applications like speech enhancement where the signal processing has been used for noise reduction and better spectrum estimation of the enhanced speech. This is one example. But after this reinforcement learning and deep learning is now taking over the market and are encouraging us to send the data directly to a blind box. But many of the cases, we really do not know the interpretation and why the result is coming good. So that's why there is a need of bringing the explainable AI and explainable machine learning. So if somebody says that the pure signal processing or conventional signal processing, which is supervised, unsupervised, this machine learning and use of signal processing in machine learning and becoming obsolete, I really do not agree. Because I really do not want people or encourage our mentees to send data blindly to a deep neural network without really knowing what is happening inside the black box. So there are a lot of research going on. If people ask that what is the motivation of using LSTM, what is the motivation of using Inception V3, what is the motivation of using capsule network, if you are not able to explain that why this using this particular deep architectures are giving you a good results, good intra-class separability or inter-class intra-class compactness or inter-class separability, I think we should know in a better way the data, the pre-processing, the feature selection, the feature vector, and the regression and classification schemes. What is happening in the support vector machine? What is happening in the k-nearest neighborhood? So there is a lot of mathematical terms that can really explain that why the the result should come good, why the accuracy, sensitivity, precision, and recall will be better. So to realize this data and what's happening inside, and why it is so important to use machine learning to have a better result, faster operation, and reliability, we still need to know. However, since GPU are available, people are so much encouraged to use the deep learning. I myself use deep learning for any data, but I always try to people that explain it. If you are not able to explain it, in many cases, machine learning based signal processing gives you the best result. So we cannot just throw it. Rather, in one of my IEEE journal, I have shown for tuberculosis detection that when you are getting the pre-processing data in parallel, you may consider the conventional machine learning features and ensemble it. In parallel path, you can also take the deep learning features and ensemble it. Individually, they have good results. Of course, by combining it, we can reach to the better results. So no way we can think it is absolute. In many cases, depending on data, it is really helpful to reach to a better result. Thank you very much. Hello, Dr. Anita. We lost her. Dr. Padmasai, we may have lost Dr. Anita.
Yes, ma'am. Hello. Yes, ma'am. We'll wait for a minute. Yes.
Ah,
Yes, sorry.
Dr. Anita.
Yeah, sorry, I got disconnected actually.
I want to give you the summary.
Okay.
You know, I told that
Right. Yeah.
in one of my recent research, what I did, that since students have the tendency to send the data to the deep neural network black box, but I really motivated them to know the boxes, to design the boxes which is appropriate for particular application. So in the recent journal paper, what I did, I have sent the pre-processed data to the conventional machine learning feature extraction approaches and do the ensemble of them. Okay. And at the same time, in a parallel path, we have sent the data to couple of machine deep learning based architectures and to do the ensemble. Individually, everybody has a special power, special attribute. Yes, when we combine it, we get a better result. It really explains the reason that why we still in many applications need to know the features, need to know the uniqueness, and need to know why they are providing better better geometric separability index or Bhattacharya distance. It's not that it's coming good. We really need to know, and in many of the cases, for conventional machine learning in signal processing gives a very insightful information, and many cases it aids and gives a better knowledge even to the deep learning architecture. So in no way we can say that that feature
Domain
selection
expert
machine learning is not obsolete.
Yes,
That's
domain expert and deep learning should go parallelly. Like,
yes,
they should coexist for
yes.
our efficiencies. Yeah, I do agree with you.
Yes, to give a better knowledge to the blind box.
Yes.
And if we want to design the blind box according to the particular application, that's a very novel approach. Even to design that box without using the box directly, that is, we really need to have some knowledge of the feature selection, feature reduction, and uniqueness. This
Yes.
will be a very great information or knowledge to the black box. Thank you.
Yeah, thank you. Dr. Anil, actually, once Madam Dr. Celia has given a very good understanding of the feature part. Later is the classifier. We have been using SVM and other clustering and classification algorithms, traditional methods. Do they still really exist in future also, with a lot of forward layers coming in, deep layer neural networks coming in? Do traditional methods still exist?
Yeah. So I'll take a couple of minutes
Yeah.
to convey my understanding. So I completely agree with Dr. Celia. So yes, explainability is an issue. So we are hearing a lot of positive stories about AI and ML, AI, but there are failure stories also for AI. Okay, so especially in the medical domain or the defense domain or the critical domain, right? We also seen how softwares fail, in case of recent airplane crashes, right? They designed automatic software, but it is not listening to the pilot. There are many failure stories as well. Okay, but at the same time, we have to agree the power of AI. We can't deny that. So along with that explainable AI, what Madam highlighted, I also want to emphasize on green AI. So do we really need to use GPU or everywhere this deep learning? So it may be not required. Okay, for some cases, there are two issues right now. What is happening is some architecture of neural network will come, and people like computer vision, NLP, and speech, all people will use that architecture and get paper. But that really that problem need that architecture or not is a big question. Okay. Now, I think going forward, the good part should be that how much data I should use for training. Do I blindly dump? I have 1,000 hours of data, ASR data. Let's say I have 1 lakh hour of data. Did I blindly dump that? We are inspired neural network by human being, right? So if you give a lot of information to human being also will confuse, right? So we have to give right information to the model to train. So always it is important to select the data, ours, select the data, for how much amount of data we need deep learning, for how much we need classical ML. Yeah, compared to classical ML, definitely this deep learning has advantages provided the amount of data is more. Even amount of data is less, people are using transfer learning, that is a different matter. But there are some applications which still need classical ML and even our signal processing. This is the same question which 2015 or so, our director also asked us that, what next, Anil, because your contributions, your lab contributions is mainly on signal processing, like single frequency filtering, zero time windowing, and all our stuff in the speech. Then, we thought, okay, the speech recognition, speaker recognition, those are not only the problem. There are so many other problems where we can apply our knowledge and solve. Okay, so then we shifted our interest towards speech pathology, where data can't solve everything, and data also not there, and the signal analysis is very important there. So we moved our interest towards pathological speech processing, where dysarthria, autism, dementia, hypernasality. So there are so many problems where machine blindly the data and AI may not be the solution. So that's where we can still apply AI and still apply signal processing and classical ML, right? So yeah, right now I say deep learning is a powerful tool, but it has its own limitations. So we should not blindly use deep learning. We should not be a data operators. As engineers, we have many things to play. But right now it's a hangover of deep learning, so it will continue for some time, but not for long. And definitely, deep learning is not the solution for everything.
Yeah.
We strongly believe in that. Okay, thank you.
Along with the signal processing people, I believe we don't get hazardous sort of errors. Few of the errors, as rightly pointed out by Dr. Anil, during simulation of flight and all, there is every chance that you may end up with hazardous errors once if we directly depend on deep learning or machine learning algorithms.
No, many critical application won't get clearance to apply.
Only machine deep learning.
I think
Yes.
all of you know the failure story of nuclear plant in US.
Yes.
US don't have nuclear plant. They will deploy their plants in other countries, but US don't have their own nuclear plant in their entire country because their feedback system failed. They don't want to take risk.
Thank you. Dr. Lalita, can you just throw some light on what are the aspects of train the trainer in this sort of advanced topics? You being from the SPS society, how to train because there is a lot of need definitely for the resources in terms of machine learning and also the signal processing aspects.
Yeah. Thank you, Dr. Anita. And yeah, so with respect to signal processing society helping in terms of training the trainers, so means in the sense I'm assuming teachers who are going to teach the undergraduate students or graduate students about various advanced topics in machine learning and signal processing, for example. I mean, of course, one model that we have been generally following across, at least in Hyderabad section or the other sections, is like, let's say there are FDPs, workshops, distinguished lectures, and several things like this with enough hands-on components. And so that is one way to reach out to a lot of teachers who are in turn training the students. But one thing which again I have to say is that I'm not really sure if most of the advances right now are part of undergraduate curriculum. So this is something which other panelists can comment, right? Because definitely, I mean, I kind of see that it's still conventional signal processing, which is part of undergraduate curriculum, and anything advanced topics of ML and signal processing, they might be in a postgraduate curriculum, but not undergraduate. So that is my understanding. Dr. Celia, you have something to add?
Yeah, Dr. Lalita, thank you. Majority, so the basic DSP and DSP2, digital signal processing and digital signal 2 as part of undergraduate. But in the university where I'm serving, Bangladesh University of Engineering and Technology, that is the highest ranked one. So we have been changing our curriculum every five years. In our current curriculum, we have some advanced topic related to image processing, speech communication, and medical images as optional courses. In those courses, our teachers, highlight some knowledge about artificial intelligence and shallow neural network, how it will be useful in their graduate study. Of course, in graduate study, we have really well-defined course like machine learning, deep learning in image processing, like especially in title contains the deep learning, okay? And deep learning for biometric security. But in undergraduate, it's recently we really are giving people some idea of AI and deep learning through those image processing, speech processing courses, apart from our signal processing and signal processing too, but which is not the case in overall, in general. It cannot be taken as an example. It may be an exception, and over the years with the demand of applications and industry, other universities, and depending on the choice of the availability of the student for those optional courses and availability of expert in the department, maybe it will come forward. Other universities also come forward. It depends on the particular school and the need. Thank you.
Thank you, Dr. Celia, for that information. I think now I kind of remember more examples. So there is so in Hyderabad, so there is IIT Hyderabad as well. And Dr. Anil, you can comment. There is a BTech program in AI, right? In IIT Hyderabad, I guess so.
No, now this BTech in AI is everywhere.
It's everywhere. Yeah. So then, which makes it even more relevant, whatever question Dr. Anita asked, because there will be courses as part of this whole program, which we as teachers would never have done. I mean, we would not have taken any courses which are related, but we will be offering, right? And there is some amount of training and some amount of convergence which is needed for even deciding what topics should be taught. Okay, and for that, of course, technical level, the trainers will be trained. So that, I mean, that is possible through workshops and various things. But how does whatever they have learned fit in a program itself? So that is a bigger vision to have in mind. And if they're able to design a very nice comprehensive curriculum, then of course they have done their job. So it is in addition to technically what they are learning, they should also have a vision for a program as a whole and how they are training the next generation, right? So for that, a lot of discussions and interaction has to go on between the trainers themselves. It's not like one person is doing it on his or her own, right? So yeah, and that kind of interaction, networking and so on, plus a lot of workshops and all, so that kind of mostly serves the purpose. That is my, I'm just thinking into the future, that's all. Yeah.
Yeah, Dr. Lalita, maybe I'll add one point. Like, we have started adding electives and also minors in that field to our regular ECE curriculum or computer science, where we are adding BTech IoT, BTech ECE with IoT, or BTech ECE with AML minor. Such, those are the places where I believe we can incorporate these new emerging fields. And as rightly pointed out by Dr. Lalita, most of us were not totally trained in those areas. And first of all, the trainers need to be trained properly and to have a comprehensive outlook and then prepare the syllabus accordingly. Actually, for the last few weeks, I'm trying my level best to make a curriculum for minor in IoT. It's I may be having a broad understanding, but the syllabus and the textbooks that I need to have, because now we don't have a predefined textbook. If I take EDC, if I say, all of us know the textbook needed, but that is not the case with all these emerging areas, and we need to struggle a lot in this transition period.
And also, one thing I would believe is that maybe industry has some role to play in this as well. So we have to keep industry very well in the loop.
Yeah, right place actually. I'm going to Dr. Ramji for this. I believe Dr. Ramji is on board. He's offline.
No, I'm here, ma'am.
Yeah, sir. Good morning. Welcome to the board. I could not see you, but now I could see you.
I'm sorry. I'm at the Delhi DST Mahotsav, so I'm just managing to be here. Please, ma'am.
Welcome, sir.
Good morning to all of you.
Good morning. We have Dr. Celia, Dr. Lalita, Dr. Anil on board.
Hi, Celia.
I believe you have been following one of the questions where we as all of us, we have been discussing as academicians, and they are the first person for us to help us in terms of industry. The question for us is like machine learning will work for huge amount of data, but can you throw some light on what is the authority who will validate these data sets on related to the signal processing aspects? And which data need to be finalized, sort of?
Thank you, ma'am. So,
I lost connection.
well, thanks for this.
I think your voice is breaking.
Yeah, I think you have some bandwidth issue, so you can switch off your video, sir, and continue with the audio.
I just turned. Okay, now.
Yes. Yeah, you are audible now. Dr. Ramji, are you speaking?
Is it okay now? I'm just asking,
Yes, Dr. Ramji, you are audible.
my voice clear now?
Yes, it's clear and you are audible.
We are
I think there is
trying to.
Dr. Ramji, are we audible?
I'm extremely sorry.
Yeah.
Yeah, I am outside the venue as well, but some issues here with the signal, I guess.
Dr. Ramji, I believe we can't hear you. Only few words, lot of packet loss is there.
Maybe what I'll do, I'll just join back. Okay? Sorry.
I think now it looks.
Extremely sorry for this. Maybe, yeah. I'm, I'm sorry. Is it okay now?
Yeah. Now you are audible. Please go ahead. Yeah.
I'm sorry, extremely. Uh, if it is audible, maybe I can quickly tell about certain things, especially in the industrial sector. Hello?
Yeah. It
Hello,
is
sir.
coming and
Maybe I think,
going actually.
I'm sorry, you please carry on. Maybe after 5 minutes, I'll try to see where the proper signal is there. I'm very sorry, ma'am, for this inconvenience caused. Um,
To you, it's little noisy, sir.
Dr. Anita,
Yeah.
if
I have.
you don't mind, Dr. Ramji can express his opinions in the chat box, in the worst case,
Yeah.
and then you
Yeah.
can really
Yeah.
share it among us. Then Dr. Lalita, Dr. Anil can shed light on it, or I can tell something if we have some comments. That should be a
Sure.
better solution. What do you think, Dr. Lalita and Dr.
yes,
Anil?
yes.
Sure.
Yeah.
Please. I'll chart my opinion.
Yes.
I'll
Thank you. Thank you, Dr. Ramji.
put my things in the
Hope it
chat
is
box. Thank you.
acceptable, Dr. Anita. Otherwise,
Yeah.
our flow is
Yeah.
interrupted, right?
Yeah, Dr. Ramji.
Yeah, absolutely. I mean, I'm very sorry.
No
Yes, ma'am.
problem,
I'm
sir, no
sorry.
problem.
Uh,
We can understand. Even for me,
yeah,
I'm also in another board, so even my internet is.
I find this corner now. I find this corner now. Maybe some signals are good. Is it okay
Yeah, you are
now?
audible. I think if it is comfortable, you can continue.
If other speakers also could be able to hear, maybe quickly I can wind it up.
Yes. Go ahead, please.
Yeah. So, I mean, as a startup incubator in the healthcare and also addressing some of the data-oriented uh, uh, problems that we have, be it genome sequencing data, how that can be actually implemented for healthcare perspectives, identifying some of the rare diseases, or maybe any other devices that may be ICT dependent, in the sense, be it as a robotic based IoT sensors or AIML, and big data analytics kind. So the major problem that we face or our startups are facing in India is about the data, mostly that is available from the Western areas, and even the Asian population data may not be sufficient enough to target a specific case that we want to address. So that's where we have to build our own data, and we have to depend on these particular data-oriented inferences to come up with a very come up in healthcare instances. As you asked, the regulatory or maybe who is going to kind of certify or monitoring these kind of issues, especially for the healthcare. I think as we have several other updates that we have seen in India for the devices and diagnostics, or maybe any other healthcare related things or pharmaceuticals, even specifically in this particular healthcare based regulation or maybe protecting of them. So, we have some kind of updates in the books from the government of India. So, secondly, coming to the data usage or maybe implying these kind of machine learning tools and the accuracy issues that we have. So I think some of the startups or some of the companies, what they're doing, they're trying to augment the data to meet at least, kind of 95 to 96 or 97% accuracy. I still actually kind of skeptical of how this is really correlate with the real data that we have or we are going to procure. So I think even our startups, as we talk about the ML interventions today, but otherwise also a lot of things that we need to import from outside, be it data or any physical things, physical devices or chips or components. So the costing is one factor that all these startups or companies that they are actually facing a lot of issues. So if we are able to make our own things here to sustain, to make our own components, to fabricate the devices and integrate these kind of things so that we can able to provide affordable solutions, be it in healthcare sector or any other sectors, including agri or textile or whichever the things. Because see, coding as well as coding in the sense, when I can tell as a biologist, DNA barcoding also, for example, if you are selling a textile or any kind of device, yes, you can actually have those barcoding systems to separate different goods and commodities. So similar way, we need to have these kind of improvements in our data monitoring systems and data analytical systems and regulatory, especially. I think some way forward scenario is certainly planned by the government of India. Maybe another 2 to 3 years we'll be having certain specific guidelines exclusively in this line. That's what I can comment quickly.
Yeah. Thank you, Dr. Ramji. Yeah, I would like to add few things also here, like as far as data is concerned, I believe even Dr. Anil has got a DST project for creating volumes of data. And we have also started creating some amount of data related to ISL, Indian Sign Language. This is one of the projects that we are doing. We have created 1 TB of data, standard data, working for the machine learning algorithms. And we could get around 85%. We are working on improving the accuracies of it. Indian Sign Language need to be converted into Telugu speech is the idea. And again, the other way around is like if we speak out, need to be converted into ISL. Like this volume of data requirement particularly related to, as rightly pointed out by Dr. Ramji, we do have data from Western countries and all, but our localized database do have some different accent. Once if I talk about the speech, different accent. Once we talk about the facial recognition, our features are different from the foreign features. So definitely requirement of data is the huge task as far as machine learning algorithms are concerned. I believe Mr. Satish is on board. Yeah. Mr. Satish?
Yes, madam.
Yeah, you are audible. Thank you. As far as an industry person, our question or our understanding is like how machine learning finds an edge over the existing methods. Like previously, I believe we have been using the regular machine learning algorithms. Uh, does industry really planning to enter into the deep learning for their products, or do you feel a threat sort of?
Yes, madam. So first of all, thank you very much for inviting me to this forum, and thanks to the SPS forum as well as the Dr. Padmasai madam to involve me in these discussions. So I think my understanding the question, I mean, is that I want to repeat it. So how industry is well receiving the machine learning and the deep learning in terms of the product launching and whatever it is, right?
Yes.
So as far as my knowledge and my experience, basically, like if you see, yes, I agree. Industry is also looking for launching the products and targeting the machine learning applications. That is one part. And coming back to the basic fundamental question, right? Like the machine learning, not just machine learning. I completely agree with Dr. Sheila, and Dr. Anil. The machine learning is just an application only. Okay, so but the fundamentals or the theory behind the machine learning, the signal processing still remains same. Its impact and its research in signal processing is not changing because of the machine learning applications. Okay, right? So what I'm trying to say here is that for any deep learning applications or machine learning applications, training is the basic fundamental component. So in this basic fundamental component, if you see, there are three major components are there. Obviously, like the convolutions in forward path and the backward path, the convolutions, as well as the how on what rate the weights are converging so fast, so that it can detect the system, it can detect the classify or regressions, whatever it is. And the third major component is the data set. Okay, the data set, or I mean training set, or whatever that what do you call that, the test set, whatever it is called, that should be more and more very accurate. Okay, that means that, what does it mean by accurate? Accurate in the sense like what type of algorithms or what type of signal processing techniques we used to extract the features of a given application or given system, okay, to build the appropriate training set. Okay, that is a point number one. So obviously people can say that that more, yeah, I have like 1 millions of data sets, I have millions of thousand million, something like that. Yes, the millions of, yes, the data set growth, obviously the processing power, that means like as an industry, I'm more worried about how my chip power, basically, right? I'm more concerned about how much power I'm going to consume when I design a power, when I design a chip. Okay, right? So obviously, like as the millions of data sets increases, obviously the power going to consume, because the training is to go through so many iterations and so many iterations, and it also depends on the what type of algorithm I choose, in the sense like the convergence rate, basically, right? Like the convergence rate, in the sense like how fast the bytes are converging, so that my error is as minimum as possible. Okay, right? So what I'm trying to say here is that when we design a GPUs or when we design a systems, okay, we also need to we also need to see how much data sets we need to project it, and how much how much data sets we need to project, and how many data sets we need to go through, and how many iterations, or how is going through. I mean, how many iterations we are going through that GPU system, so that like the error becomes zero. So these are all power consumptions. What I'm trying to say here is, it is not just GPU power designing. I mean, it is not a chip designing I'm talking about. What I'm trying to say here is that it depends on the what type of algorithms, what type of signal processing techniques we choose to come up with a training set as well as the test set, and what type of convergence algorithms we choose so that like the weight factors are converging so fast. So this is where it depends on the this is where industry is also depending on the what type of algorithms to minimize the power and to minimize the chip power, so that like we can have and we can apply in the deep learning. I agree with Dr. Anil sir. So yes, sometimes machine learning is positive results and negative results, but as an industry, we are more worried about the how much power we are consuming for a given applications. Yes, application perspective is a value add or not. That is, I think, that is where the convolutions, number of layers, and the techniques what we choose, that is algorithm domain. So this is, I agree with Dr. Anil sir as well, and Dr. Sheila. So this is my opinion on the trend, or as an industry, what we are looking for. From a research perspective, as an industry person, what we are looking for is what type of algorithms we choose, what type of techniques we choose to minimize the power. That is what my opinion here. Thanks.
Dr. Anita,
Yeah.
can I ask a clarification from Satish?
Yeah.
Sure.
Usually from the industry, do you approach to the colleges or universities, solve your problems and share your industry requirements so that our academicians can really think how to fit their knowledge for solving the industry problem? And then there will be coming the question of training, mentor-mentee training or capacity building, who will be eventually will be the employee and contributor of your industry. So what is your approach? Because we academicians are deeply involved in paper publishing, but how to make a bridge of signal processing industry and signal processing academicians? What is your company or your organizational approach to address this issue and to make this bridge? Thank you.
Sure, madam. Sure. I think we are also like we are also reaching to some research organizations, especially like for example, there are recently, if you see, I think NVIDIA along with some of the universities in US, they are like they identified. Like AMD also. So they have published one very good article on SIMD2. What is that like? They're trying to come up with a different technique to simplify the machine learning, like the GEM applications and then the GEM workloads, something like that. Instead, the compute power perspective, they are like they are working with industries. They are working with research organizations to come up with a different algorithms to simplify the to save the chip power. Okay, there is some collaborations are happening in AMD. Yes.
So actually, what I'm telling, we need to know the industry problems, and industry is requested to give problems to the academicians so that they can solve with their students. It will be a research topic and there will be a good industry academia collaboration. Otherwise, we will keep on telling about industry academia collaboration. I will tell something, you will tell something, and there will be a minimum bridge. So this is a campaign. It's not just directed to your organization, it is a campaign in our signal processing community and for any technical community to address this issue, to minimize this gap. Sorry, Dr. Anita.
Agreed, madam. No problem. Welcome. You are welcome, madam.
Always there that industry, the main problem that we could see is the timelines. So what they believe is like academicians, they'll take their own time. So they do have time to market issues. As rightly pointed out by you, Dr. Celia, actually, they can give us research problems where there is no time constraint, sort of, where we can do such sort of research and give the outcomes for them.
Yeah, Intel is not doing current research. Intel is doing what will happen after 20 years?
Future,
20
yeah.
years.
Those aspects can be covered by researchers. Again, I come back to Dr. Celia. Actually, once we talk about, because now people are talking more about e-healthcare, then the next aspect that comes into picture is the security. Yeah, even IoT, if we talk about the main aspect now people are worried about is the privacy and security aspects of the IoT. And so how secure and what are the security issues that we are going to face and how to solve them, particularly in the case of healthcare. We don't want our data to be known to all, right? So can you throw some light on that?
Thank you for raising this very timely issue. You know, when it's coming to healthcare apps, there are two types of apps. One app is giving and storing data.
Yeah.
People from different parts of the, say, we have hilly region in Bangladesh, you know, and it's very difficult from this hilly region, but we have also islands. So in the Bay of Bengal, okay. So it is idea is to store the data so that doctors from any part of the country can access the data, only the doctors. This is one thing. And there is a majority of the health apps are like that storing data and making it available to the doctors to make a comment and then do the diagnosis or send the diagnosis via SMS or something. Second part of kind of app is giving data and calculating and applying machine learning, deep learning, signal processing, and give the result, analytics, statistics, like that. That is also a very infant, I should say, the very infant stage, the second part, that analyzing the data, and within the app, the AI machine learning will give you a solution, give you a statistics, give you a demography, give you a cost analysis, give you a comparative study. So forget about it. We have still a long way to go. But the first thing about the storing data is most important is the security breaches. It's not at all robust. And I should say it is very sensitive because it is people's data. It should be accessed by the concerned people only. The major reason that these apps developer or organizations, they're using the data in the shared preferences.
Yes.
And their encryption is very, very weak. So it is very important to make sure and monitor, and there should be some legal procedure also. Legal procedure and policy should be involved while giving permission for an apps and using people's health data. So it is very important to see what type of encryption method they're using, because if the encryption method is very weak and the softwares are very vulnerable, then development of software and encryption should be more restricted through the legal procedure so that the data is not accessible by the hackers. It is accessible, should be the registered people like doctors and policymakers. So this is one concern and one recommendation about that how to make these healthcare apps more secure. Or there is in many cases there is only one level security, but there should be several level of security so that the attackers are unable to bridge those gaps. So this is the most important suggestion, most important campaign, that the apps development, it should be user friendly, it should be protected, it should be, the software should be specially licensed, and we should have a great implementation of watermarking, so that those watermarking are very strong and can able to handle the severe attack. So recently, so this is very, very important to create this. And most important thing, we don't have that awareness. We're developing app and we are giving permission, but we are not at all have a strong awareness about creating 5-level security. So this is a kind of negligence or lack of awareness. So it is very important to create this awareness, because very long back, maybe 40 years back, people did not used to boil water. They used to drink water directly from the pond. Then we started campaigning about arsenic and those things. Many years back, there were people who were not aware about the breast cancer, but we have started campaigning. And then many years back, people were not aware about the birth control. We started campaigning. So this is a kind of campaigning. It is a kind of maintenance cost. It's not just applying or developing the apps. It is really important to keep this budget in a project, so that we can employ a legal expert, we can employ a software expert, we can also employ an encryption expert. Majority cases, this maintenance is not in our head, not in our minds. That's why we just launch it, and it has been mishandled in majority of the reported case. So as an expert, as an academician, as an industry collaborator, we should tell everyone whenever we will come in contact, and we can also offer our help, that how we can help them to develop a better encryption system and better watermarking system. And that much we can do. We have to always keep in mind that this is important. This is a very important thing, privacy and accuracy. Otherwise, there will be a lot of apps, but people will lost our faith on them, and we will be depriving ourselves from receiving the benefits of using apps by all people in the whole Andhra Pradesh. Is so big, so diverse, right? So it is really important for connecting the unconnected people. So this is very important. Thank you very much. However, it is not robust, and it is really very sensitive, because it is handling people's health data.
Yeah,
Thank you.
yeah, Dr. Celia. The other angle is, I believe people know that there are technologies available where we can make the data as robust as possible, but it is because they are interested in selling or letting out the data for sake of ads, and the moral ethics the
Yeah.
app designer is supposed to have.
That's why I
Yeah.
told the legal.
Yeah,
The
legal. It should be
we
legal.
we can give training
Yes,
about
exactly.
ethics, but whether a person will be ethical or not, that we cannot really
Need to be
control. But
legalized.
if
Yeah,
there is a legal procedure, every
exactly.
person will be careful. Thank you.
Yeah, thank you. Again, I come back to Dr. Anil. As far as, again, coming back, because we are academicians, curriculum aspects. What are the curriculum aspects that we need to carry out? Like, is the curriculum that we do have right now is job ready? Or in terms of the latest emerging technologies, not only machine learning for that matter, IoT, 6G, and all are coming in. So, what is that we can add? Or
Yeah, actually, I'm in few board of studies of few colleges. I think Dr. Lalita also is a board of study member in few colleges. So, as you rightly pointed out, in the now current choice-based curriculum system, we have 5 to 6 electives, professional electives. In that, we are giving it different streams rather than everybody in the same stream. So we have signal processing stream, VLSI stream, AI stream, IoT stream, or embedded system stream like that. So wherever we are revising the curriculum right now, so we are keeping at least 4 streams, 4 streams, VLSI, signal, communication, and AI. We can also add fifth stream as an IoT, something like that. But here the main thing is right now we are putting in the curriculum whether they are really offered or whether really students motivated to take those courses. We have to see, because right now only we are changing the curriculum changes. So now we need to introspect and see after a few years that what is the students pattern, how they are selecting the electives, how to encourage them to select the different electives, and getting departments ready to offer all the courses available in the electives. Even the number of students is around 25-30, also we should be able to offer. There are some logistic issues that the department has to handle, because some good colleges have some 200-300 students. It is not a good idea to train all of them in the same domain or the same set of skills for all of them. So we can encourage them to after minimal skills they should go and pursue interest in a particular domain more deeper, depending on their interest. So we should encourage students from second year onwards that how to choose electives properly, and offering all the electives which we are in the curriculum. And next an important step what others earlier also talked is like making our faculty ready for it. One of the, along with these workshops etc., which are mostly research oriented, there are some workshops maybe basics related also, but I think it is good idea to do NPTEL course. If anybody offering a course without studying that, let's say I'm offering AI, ML, or machine learning or pattern recognition course, I should do similar, more close by NPTEL course and get grade. It's not auditing NPTEL, just really, doing the course. If department ensure that the faculty do that, and we also can encourage all. I think few good colleges are already doing that. Encourage faculty to really get the course certificate from the NPTEL on advanced courses. I think that will help actually. Anita madam?
Yeah, I definitely do agree. Workshops and hands-on sessions are very much needed, not just the classes.
Yeah, and more importantly, this we can make use of NPTEL lectures. NPTEL not only for faculty, it should be for students also. Professor Jayanti used to say this word, by listening the music, we can't be a musician. In workshop, we are listening, but unless faculty have the hands-on or really make their hands dirty, then only they can tell to their students.
Yes, exactly. Dr. Lalita, do we feel there are enough publications as far as publication in these fields of machine learning, signal processing is concerned? Can you throw some light on that? How the publications are? What I understand is machine learning for signal processing applications are very few. That is what I could see. Even the ISL that I'm talking about now, sign language conversion, using deep learning algorithms. Very few publications I'm seeing in that area.
Okay, but I would assume that the publications are growing like exponentially crazy. So,
Particular application.
I think that is it is like yeah. So I mean, forget about let's say core machine learning conferences like ICML or NeurIPS, where the number of public papers submitted and those who are accepted and all are growing exponentially. So that is like understood. But then even in other areas of signal processing, including biomedical or radar signal processing, or conventional areas like direction of arrival estimation, so estimation theory. So all these areas, I'm sure, like everywhere there is machine learning and deep learning. Even I'm sure Anil will know about speech, and so those areas are also. If you see a typical conference, right, even in, let's say, communication, so let's say there is a ComSoc conference called Globecom, I guess, And if there is a particular track on machine learning in communications, so initially I thought it was a simple track, so maybe the some number of papers will be there, but then it is like it had some 8-9 sessions in the conference just for machine learning for communications. Okay, so it is a major chunk of any conference now. So the number of applications is just too huge for uh, but one thing I still have to say is maybe the reason, okay, is that suppose if an algorithm, let's say a machine learning algorithm, is already doing quite well, let's say, right, for a particular task at hand, right? So what is the next logical publication in the area? You want to improve the accuracy or do something, right? And if only another architecture of an ML can beat it, of course the number of publications will be high, right? Because
Yeah.
so that, I mean, that is my take. So it is like I think they are growing really fast.
Yeah.
And the way I want to look at it is that, I mean, all the ML boiled down either in signal processing or any other area is doing optimization. Okay, so basically it is doing optimization in whatever way it is, like the possibly one of the most general possible ways. Architecture is so general that it will fit any optimization problem, let's say. So there are two aspects which I think I have heard over time, which make ML quite interesting to the research problems. So this the two words which are coined actually are known as model deficit and algorithm deficit. Okay, so if a situation or a problem has a model deficit, so which means that we are not able to model the
Problem.
so even so when I say a communication system and I'm modeling it, AWGN or whatever is one particular model. Okay, so, and it can more or less replicate what is happening in physical situation, when some physical situations it may not be able to model. So this is called model deficit. Okay, so in such situations ML algorithms are useful. And then there is something called algorithm deficit, where it might be really hard to solve the optimization problem because it is not convex, or it doesn't have some nice structure or whatever. So in that case it is algorithm deficit, because we are not able to find a good algorithm to solve that problem. There also ML is useful. So it kind of covers a broad spectrum in these two things, and that's why the research and publications are growing quite heavily, and there is enough value addition too that people see.
Yeah. Thank you, Dr. Lalita. I believe Dr. Satish is there. Satish, Mr. Satish is there on board.
Yes, madam, I'm sure.
Yeah. Mr. Satish, our thing is, we would like to know what is the future of signal processing engineers. What are the avenues that a signal processing engineer is going to have?
Yes, madam. So the signal processing is always an hot topic, and even though machine learning is dominating, so basically what I'm trying to say here is that, like, machine learning and signal processing are two different aspects. Machine learning is that something like for a given application, what type of techniques or what type of how many layers we need to choose, and what type of depth of the layers, and those things we need to choose. Whereas the signal processing is more focusing on the data sets and what type of algorithms, especially like, for example, LSTM and RNN, they are all like time dependent techniques. We need to adopt it there to identify the to extract the features. So basically, like so we need to the signal processing should be always a primary domain, even though machine learning is dominating. Machine learning is an application, whereas signal processing is something like the techniques we are being applied to come up with an appropriate algorithm or right algorithm to identify the best features, okay, right? To extract the best features of a given system. Okay, for this the signal processing still remains same. So signal processing is still, I mean we need to give an equal amount of priority to the signal processing to come up with different algorithms, or like high-speed algorithms or high-speed FFT or DFT techniques to identify to feature extractions for the LSTM and RNN time domain applications, as well as the frequency domain applications like image segmentation, etc. So nowadays, if you see, the ML application is not just image processing and even not just like audio processing, or the voice recognition, right? It is also like some of the broader applications like like, even for example, even if you see there are not just applications like embedded applications, I mean to say, even today VLSI, let's say the place and route. So even place and route also they're applying the machine learning. What I'm trying to say here is that wherever you go, so the database is the one which is important thing, how to choose the database. So how to choose the database is completely depending on what type of signal processing techniques we are applying to come up with an optimization features to extract the optimal features of a given data set. So this is what my take on this. So yeah, I mean, machine learning and signal processing should be independent. I mean, even though they are directly related, but they should be independent and go in parallel in terms of the research as well as the industry.
Okay. Thank you, Satish. I think Dr. Ramji is there. Is it comfortable, Dr. Ramji? Are we audible, and you could take our question? Dr. Ramji? I don't think...
Ramji sir is not there at present.
Not there. Okay. Okay, Padmasai madam. I believe we can come to the last round where we can have a concluding remark. Maybe I request Dr. Celia again to have your concluding remarks on this total discussion related to machine learning for signal processing.
Yeah, thank you very much. Actually, I'm a passionate researcher and also volunteer. I'm chairing Global Signal Processing Society Women in Signal Processing in the SPS Membership Board. In both the aspect, I am a strong advocate of signal processing in whichever tool. Machine learning and deep learning is a tool. And for me, since it is a tool, anyone can know it, but we have to have hands-on training. So we have huge future, and it's an ever-ending task to do. Say, recently I'm offering DSP, Digital Signal Processing for undergraduate, and in the lab, I have given some projects targeting smart VNRVJIET, how to use signal processing to enter secured hall entrance, how to use signal processing to enter their local bank to pay their student fees, how to use signal processing to use library, even by the disabled people, how to use signal processing for entering to their, I should say, canteen. So these are different. I told them, look into the society and the activities in your classroom and signal processing for class attendance recording. So I told them, just look around you, that how you can use signal processing for solving the problems around you. Because we are not automated and we are not living North America. Even in North America, these are not automated always, right? So these are the important problems where we can usually directly use signal processing, machine learning, and deep learning to automate the process and to create accuracy, to create security. So these are some examples what I'm currently handling. What I handled before is the sign language alphabet recognition for Bengali language, because I felt that I'm belong to an only nation that has fought and that has sacrificed their lives for speaking Bangla in 1952, 21st February. And it is the International Mother Language Day celebrated by many countries around the world. So that has given me an obligation. I was doing English Sign Language recognition, but that has given a cause to do Bangla Sign Language alphabet recognition. I have a dream that we can go for interface or create an interface along with the industry where a disabled student can come to VUET, can order a food in the canteen like a normal human being using this Bangla Sign Language, or can use our library and can order a book. So there are a lot of things to do for signal processing. And if we start doing in Telugu language, and if we start doing in Bangla language, then our reach out to the Bangladesh has 16 crore people, but not everybody know about the signal processing. So we have a huge scope in the STEM education to tell people about the beauty of signal processing and the future machine learning, AI and deep learning, so that in the long run, it can help them to inspire to come in engineering education and to remain and retain in the engineering industry. So it has a long vision, and we all can work together to do it, because unfortunately, we have a lot of problems, and that's a blessing. That's the scope of using technology and signal processing to solve them. And for that, we really do not need to finish our PhD. That is the perception in the subcontinent. To get value, we have to have a PhD. We have to have the social value. We can inspire, because as we are busy, we can inspire our younger student to help us to implement that vision. We do not need to start a fleshy project. Start with a very simple project that can solve the problem of our classroom. And if we think in that way, simple way, then we can see there are a lot of things, and signal processing and machine learning has a always bright future. Thank you very much.
Thank you, Dr. Celia. Yeah, it's quite interesting that you have started sign language also, which is related to the work that we have been doing. Actually, we are working on the video sign also. It's instead of static, we have started working on video data also. Thank you, Dr. Celia. Over to Dr. Anil. Actually, do we have, what is that we need to, in terms of concluding remarks, industry institute interaction, particularly in the field of signal processing, how to improve upon, and what are the industries through which we can go through, sort of?
Yeah. I think startups is a right forum to also to interact, rather than only waiting for industry. So there should be ecosystem in the college itself, in the near environment itself. So in that way, IEEE is very fortunate. We have a vibrant Center for Innovation and Entrepreneurship, and also we started something called Product Lab, which is unique. What is that? Is that how to take our lab technology to industry, or how to productize our algorithm. So which we are not comfortable. So we are, as other panel members mentioned, so we are in academia, so we are good in publishing, and our ball game is different. So let us say we have a potentially developed an algorithm, how to take it to the industry. So there should be an ecosystem within the institute, or maybe the nearby institute, so we can collaborate and make the proof of concept ready through your product lab, or some kind of in a startup. Then big companies are then take over, or they can do. So we can also encourage, along with the research, we can also encourage our young people to go towards a startup thing. I think that because initially startups may not yield much money, but if idea clicks, that will be much much higher actually. And also we need to motivate. Actually, we can also conduct this successful incubators or successful startups talks. And I see a lot of our CIE startups are also on medical data processing, and there are some gynecology related apps. The apps they developed, let us say, how to help the apps for the pregnant ladies or old people, or the medical scenarios, and augmented reality. So many issues. And also I echo with Dr. Celia that yeah, we should see the problems around us. So if we are not working for our problems, who will work for us, especially in the space of speech, etc. So we have so many languages in India, and always telling, I rightly, some of the panel member mentioned, right, we always work on English data sets or even Spanish data sets, because they are creating the data, and we are enriching their model actually. And also you see in the space of deep learning, I completely agree with Dr. Celia that yes, this is a tool, just like Java or C language. It's a mathematical tool. It's nothing to do with EC, nothing to do with civil. Everybody, wherever you want prediction, wherever you want classification, wherever you want regression, just use them, if they are useful. Okay, just project is as a tool, but it is not, some people are projecting is like a, very, the tool which can solve everything. No, it can't solve everything, because still, I remember recently the approach, like now words, AI or machine learning is good, but human being is much powerful than that. Okay, so we have much more to do. Okay, and as a tool they can learn, but they can come back and see what problem demands, and the local problems around us, especially in India now taken as speech to speech translation to reduce the language barrier. The beauty of speech is that it reaches to all. Speech is our natural mode of communication. Computer vision has some limitations. NLP has limitations, but speech don't have much limitations, because once the technology develops, it reaches to the huge public, just like Alexa or OK Google or Siri. Anybody can use such applications. So, and a country like India and Bangladesh and few countries like us, we have our own languages, our own heritage. So in our digital space, we are still lacking. So there's a lot to need to be done in that space actually.
Yes, Dr. Anil, I just want to add 1 minute. Our number of people are an asset, but we think is as a curse. We have to transform this power of people into power of knowledge dissemination. If we start developing data set for different problems, especially speech. I'm currently from 2018, I worked on speech enhancement in 2014-15 where I have used statistical modeling. Now I use speech enhancement, use GAN, generalized adversarial neural network. But it is last night at 9 p.m. I have invited 3 sections of my DSP students, 195 students, to come to Zoom and to start recording their data, their own data, for their 7 project in the DSP lab. So let us help each other. It's not I'm Bangla and you will do Telugu. We are doing the same thing. Let us do a common platform or create a digital platform and we create a guide that whoever there can contribute us in the database development. And India has so many states, so many languages. If we focus on Telugu, Tamil, Bangla, Oriya, and those things, and if we can create a combined platform, we can be the largest contributor of data resources in the world. But we have to come together.
Yeah, just to add that Indian government also has felt that need, and we started a platform called Bhashani. Okay, just go through that Bhashani platform. Now they are keeping all the ASR data, TTS data, MT data, a lot of data they are putting, and they're still not worked out how to release that data, but the idea is to release it freely. So yeah, they are trying to create a library where all the data sets sit there. So whoever collected, maybe whatever the project supported, just push all that data to there, so that it will be easy for the startups and academia to use that, consume the data, and develop. technology around that. Yes.
And for your kind information who are listening here, IEEE Global Signal Processing Society also has a entity called SIGPort, where you can collaborate with Global Signal Processing Society for your data. It's just information to all of you who really are not aware of it. Thank you, Dr. O'Neill. Would please share me that store or storage that Indian government has started through Padma Sai. I'll be happy to look into it. Thank you.
Sure.
Ramji sir joined. Antashila ma'am.
Ramji has joined.
Yes, ma'am.
No.
Yeah, I think he got the
Am I
signal
audible,
back.
ma'am?
Yeah, you are audible. Can you give some concluding remarks related to this machine learning signal
I was there.
processing?
I
Okay.
I could able to hear all of your.
Okay.
I could able to hear all of your concluding remarks, and very happy to know how. Able to hear, ma'am?
Yeah, you are audible, sir.
Able to hear?
Yeah, you are
Yeah.
audible.
So,
Dr. Ramji, yeah.
what I mean to say that programs that we have, programs that we have in various institutions, and even the initiatives by the government of India, and somehow we have to amalgamate with the industrial alignment. I think that is what government is also looking forward. And as Anil sir mentioned, how students can be directed or trained in such kind of signal processing or machine learning, all these, what kind of implications that can be benefited for the society. I think what we can do is that incubators like us can actually bridge between these academic institutions like yours and also the startups and industries, where internships and externships can be planned, so that they'll be knowing the real value of working with these kind of platforms, how best they can be helping for the society. I think that's what I'm just trying to address to all the students and faculty here, because if they are actually not joining the hands with the incubators and enabling agencies and other industries, I think we are not going to target our, what you can say, whatever the mandate and mission of our India, that is Atmanirbhar Bharat and all. So I think that is what my concluding remark quickly to say. Thank you very much for this opportunity, ma'am.
I think
Hello, Archana.
Anitashila madam is stuck, I think. But
Hello,
maybe.
Archana, are you there?
Yes, ma'am. I think Ramji sir has concluded, ma'am.
yeah, Ramji sir concluded, but Anitashila madam is stuck, it seems. I think we move on maybe to Lalita madam.
Yes, ma'am. Can you give your
Lalita, you can proceed. Anita ma'am is joining.
Yeah. So maybe she has joined back.
Yeah.
Okay.
Actually, I'm a university nominee for other interviews. So I'm in other college. I'm losing connection.
I see.
Yeah, Doctor. Over to Dr. Lalita. Actually, we need your conclusion in terms of the signal processing society, how we are going to go about in terms of machine learning signal processing aspects. Yeah.
Yeah. So in terms of signal processing society, so so what we are conducting right
Yes,
now.
yeah.
Hello, can you? Yeah.
You're audible, man.
Okay. All right. Yeah. So thanks to Anil for bringing this point about NPTEL, because I had that in mind always, and I was also searching before this panel discussion whether there were any MOOCs or anything which were offered by IEEE as such. Okay, so means whether there are any courses, and you know, I mean, I know that, you know, let's say Coursera offers courses and NPTEL offers courses and so on, but does IEEE facilitate any courses in any way? So that part was not clear to me. I was searching in case there was anything like
Can
that.
I add, Lalita?
Yes, please.
IEEE also conducts few courses. Global IEEE is offering courses. Actually, it is paid courses. Some of our faculty done embedded system with IoT.
Okay.
Recently also launched one more course.
Okay. So does this fall under the preview of educational activities of IEEE?
Exactly.
I'm guessing so, right?
Yeah,
so because
Skill Connect program.
Yeah. So
and Lalita, Signal Processing Society also has educational board, like membership board. Maybe they're also taking initiative for offering courses.
Right. Yeah. So that, I mean, those kind of things, of course, definitely will be extremely helpful, because I think with respect to students and of course with respect to the faculty, you know, workshops and these kind of things are like crash courses, in the sense that, you know, they already should have some expertise, or they should have known some material to be able to appreciate what's going on, let's say even in a workshop like this, for example, right? As opposed to someone who is entering the field, they have to have enough time to able to grasp the material, and if IEEE can facilitate, you know, long term things. So for till now, what I have seen in general is that there is enough networking which is possible through IEEE, and there are, you know, various advanced topics which can be covered through either distinguished lectures, workshops, and so on. But all of them are short, right? Because in the sense, maybe, you know, a week or 2 weeks maximum, and that much short time is in general insufficient for either students or faculty to grasp material at a slow pace, right? Because for us a course is like some 4 months or so, right? So some such long term so I would be, it would be nice to see if IEEE can also facilitate, like, you know, long term discussions and or, you know, exchange of knowledge that way, right? And that will, I think, in general benefit everyone as well. So that is the thing which I see is maybe missing, but the others, we know different ways in which SPS can help learn all these things. Thank you.
Mr. Satish, I believe we are there on board.
Yes, madam.
Yeah, one of the main problem is after doing all the simulations, porting it onto the hardware. Main problem comes once we start porting all the deep learning, machine learning, big circuits onto the hardware, all the problems start coming. So how we are going to solve them, and what are the main problems that you are facing as far as porting all these algorithms onto the hardware? I believe we are the right person because we are into the chip manufacturing aspects.
Yes, madam, I understand. And so I agree with you, like porting challenges is one important. Algorithm is not just algorithmic design. So we need to come up with an, there are two, the first point is we need to, once the algorithm is defined and whatever the results we have been, expected to be achieved for that algorithm for a given applications, once it is done, then we need to optimize that algorithm with respect to the hardware architects. I mean to say that, for example, if algorithm is parallel algorithms, or like maybe like, can we map it to SIMDs, or can we map it to the simple hardware accelerator? Is it a simple multiply accumulator? Do we need a divider? So what I'm trying to say is we need to see the math component behind it. The math component should be optimized in such a way that we should not use dividers and some of the like hard components like exponential, etc. Can we come up with an simple, I don't want a simple like the optimal hardware components, and that is one part, data per perspective. But we should also think of, we should also think of control path. In the sense, right, there are obviously, like if you see, most of the algorithms are like FFT or DFT based and time domain based, all those things, right? All of them requires a looping. Okay, right? Those loopings also we need to keep in mind. Is it an controllable loops or is it an directed loops? So how can we map that into the hardware architectures? So that is the next part. So these are the things which we need to, when we design an algorithm, we should also keep in mind that how simple we can map it to the hardware architecture, so that the power consumption and software development, compiler developments, everything will be very easy for that algorithm. So this is my thought, madam.
Yeah, thank you. Thank you, Mr. Satish. I believe I should definitely thank all the experts for sparing their time and giving a lot of light. Many of the missing links, I believe, must have been understood by the participants by this time, because few of the thoughts even I was having, like many of the thoughts got clarified once I started discussing with people like you. We broadly discussed about we have started with the feature extraction part and how we can make the data comfortable, and also how to go about signal processing to machine learning, and what are the issues that we are facing once we are going on to the hardware aspects. And these are the various aspects which we do have discussed today. And I believe the participants got benefited out of the knowledge that has been shared by the experts over here. Thank you again, the experts and also the society, for giving me this opportunity. I hand over the session to Dr. Padma Sai, madam. Thank you.
Thank you, ma'am. Even though all are very busy with their preoccupied schedules, so I know how difficult it is joining virtually. So for spending your valuable time with us. So thank you for sharing all your valuable advices, starting from startups and attending NPTEL courses. Even myself also attended. I have taken deep learning, machine learning, AI from NPTEL, Madras and Delhi. Ravindran from Professor Ravindran from IIT Madras, and I didn't remember his name, from IIT Delhi. Actually, it's good learning, as Anil rightly mentioned. So instead of seeing, if you physically practice how things are happening, we came to know that before teaching to the children, as a teacher, first we should practice and then preach. So it's wonderful for joining all of you here. I thank you wholeheartedly for all of you for sparing your valuable time. Ramji also unexpected. Actually, initially we planned a physical event. So actually, because of rains, now climate also changing drastically, all exams rescheduled. Many students are having their exams. So because of that one, we conducted online event. So instead of bringing all experts from in Hyderabad, especially, it takes 2.5 hours for traveling from one place to another. So thank you, each one of you, for sparing your valuable time. Over to Archana, ma'am. Hello, Archana, are you there?
Thank you, Dr. Padma, for putting a lot of effort.
Hello.
Archana.
Yes, ma'am. Thank you, ma'am. I just thank all members for giving great insights about this topic. And it was a really very fruitful discussion. And we could get so many aspects on machine learning and signal processing. I wholeheartedly thank once again all the members, Dr. Celia Shenaz ma'am, Dr. Anil Kumar Uppala, Dr. Lalita Vadlamani, Dr. Ramji Palela, Yal Satish sir, and Dr. Anita Shila ma'am. Thank you. Thank you, one and all.
Thank you.
Thank you.
Thank you very much.
Thank you.
Nice having you in the session.
Bye.
Yeah, I believe we can log out now.
Yes, ma'am.
Yeah.
Thank you.
Thank you.
Thank you, ma'am. Thank you.
See you.
Thank you, sir. Anil sir, thank you.
Thank you. Thank you.
Santosh sir, Ramji sir, thank you very much.
Ma'am, next session.
Ramnik came, Amma. Ramnik is joining physically in the auditorium.
Yes, ma'am. At what time we shall start?
You can start at 11:45. He will set up. Meanwhile, all of you have tea. Okay, exactly at 11:45 we are having session. Quickly you take a break for 5 minutes and join.
So please join for the next session at 11:45.
Yes.
You have VG or what? VG.
We can connect to the make link, so we can share yours.
Acha, directly.
Make link only.
And we will able to see here as well. Okay.
Now we'll on, we will only.
So which Wi-Fi?
VNRVJIET.
I was thinking that audience will be there physically. It's okay. So after lunch as well, people will have offline or online? Full. For that I need.
Password VNRVJIET is there. VNRVJIET password.
VNRVJIET. You only have 10 people. All people will join as well.
VNRVJIET Wi-Fi. VNRVJIET
Wi-Fi.
Password.
Capital V, capital V, VNRVJIET, VNRVJIET, Balaji.
Not longer, no?
Now you can it's completely.
Charger. Is it charging, sir?
Yeah.
Yeah, okay.
And then Wi-Fi.
Adjust it.
11:45.
Santosh, wait, check.
Password.
Password is not there.
Okay, not working. VNRVJIET
Capital,
small.
small. VNRVJIET.
@1. I just take the printout and then start this.
No.
మన VNR పాస్వర్డ్ ఏంటి ఇక్కడ ఆల్ స్మాల్ క్యాపిటల్ VNRVJIET వైఫ్ అదే కదా ఆల్ స్మాల్ VNRVJIET అవ్వట్లేదు అదే VNRVJIET వైఫ్ అయితే okay. Okay. It's connected.
Connected.
Oh, okay. Just send you the meet link.
meet.google.com/SSI. This same now?
Meet. You have the meet link.
I will type no.
I can send you.
Yeah.
Hey everyone.
Yeah, am I audible to the online audience? Yes or no?
Yes, 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 Ramnik.
Okay, perfect, Padma ma'am. Thank you.
Wait for 2 minutes.
Sure, sure. Chalo, we'll start in next 1 or 2 minutes. Thank you. Meanwhile, everyone, please feel free to come on camera. It's kind of virtual audience, so let's be more interactive through faces, if possible.
You have any, do you?
That's the interview that I am
You can on the camera. Everything ready. You introduce here. You have to introduce everything ready. Ready.
No. Just few points. Just 2 things.
No one gonna watch. I'm standing here.
You can keep the camera like that. We'll focus this camera here. You can roam here and there. You can operate it.
No, it's fine. I will be there on.
Okay, then
leave it. Yeah.
Okay. Register short.
Good morning, God. Hello. Okay. So, welcome you all for the session on the best practice of IEEE student branch planning and operations by Mr. Ramnik Karla. Mr. Ramnik is currently working as Hello. Mr. Ramnik is currently working as a project engineer at Wipro Limited India. He is the former chairperson of the IEEE HMR ITM student branch and currently holding the responsibilities including the program lead, mentee and mentor to the various IEEE contests. He is the most enthusiastic volunteer under IEEE non-IEEE organization through which he networked with eminent volunteers from various sections. Through these numerous connections, he had been invited to various grand opening of student branches including IEEE, Justin, Noida, etc. He has been continuously supporting various student branches and keen participant around the different sections, majorly IEEE Bangalore section, IEEE Delhi section, and UP section, and not limited to these for mentoring about event planning and operations at section level as well as branch level. Now I welcome Mr. Dominic sir to deliver his talk on the best practice.
Okay. Am I audible to the online audience? May I get yes or no? All good? Sure. Knock knock. Anyone there? Yeah. Please come on camera. That would be really nice for me to see your faces as well. Let me stop my sharing. Professor Shabarinath, Shweta ma'am, Vamsi, please join me on camera, please. See, it's virtual audience and we have very less participant right now, so it's better we can. Yeah, there we go. Thank you, Professor Vamsi. What about others? See, this is kind of, I would say this is the first time opportunity that Padma ma'am has given me to fly from Delhi directly to Hyderabad for giving this talk. So I would love to see the faces of Hyderabad people as well on the call and from different STEAM organizations. Perfect. So thank you so much to IEEE VNRJIET for inviting me out and giving me the space to interact with all of you on the topic of edge computing. That's what we're going to talk. Best practices of IEEE student branch going to be after lunch. The schedule will follow. Okay, let me share my screen and then we can proceed. Okay, perfect. I hope my screen is visible. Can I get yes or no in the chat window, please? Are you able to see the PPT? Okay, perfect. Nice. So I've been into edge computing for the last, I guess, in my second year or third year. Yeah, in my third year, 2017, I got to know about edge computing and I got interested into this research domain. Since then, I am writing papers and I'm doing patenting and all the stuff. Currently, I'm working as a cloud support associate at Amazon Web Services, Hyderabad, and virtually from my hometown, that is Sonipat, Haryana. In parallel to my job, I'm just trying to understand what are the different outskirts going on, different kind of advancements going on in edge computing. So what we will be covering today, not so much like long agenda, but it's kind of a very basic overview of cloud computing, edge computing, and different use cases, and how the telecommunication market is coming up, integrating with edge computing. So before proceeding ahead, I just want to understand from the comment box, are we aware about edge computing? Have you heard about this before? What do you know by it? Can I just go ahead and throw out some suggestions? Yeah, I'm checking the comment box from another system, so please feel free to share. Have you heard about edge computing before? Okay, no idea. Okay, what about others? See, this is gonna be a very interactive session. I don't want to make you sleep behind the cameras, so better to interact with me as much as possible. Okay, no idea. Ashwini, Professor Ashwini as well mentioned. Okay, what about others? It's fine. See, I am undergraduate pass out of 2019, so I really not love to give marks to the faculty members for not answering. So feel free to interact. It's fine. Okay, only 2 professors are live right now with us. What about others? Anyone aware about edge computing? Okay, no worries. What about cloud computing? What do you mean by cloud computing? Anyone? Anything. It can be very basic. It can be any advanced. Yes, aware about cloud computing. So, Professor Ashwini, what do you mean by cloud computing? Maybe you can unmute yourself and speak up.
Yeah, good afternoon. Hello.
Yes, you are
Yeah.
audible. Yeah, please.
We are just like means I'm aware about like how what is a cloud and how we can access the cloud for bigger space to get the more data or rather storage space for and how we can how the virtually things can happen using virtual machine that I'm aware about the cloud computing.
Okay, that's great. Thank you, Professor Ashwini. What about others? What do you mean by cloud computing? See, the main attention here is not to find out that we know about it or not aware about it. It's just like we are just discussing about this new thing which is coming up in the market, and being in industry for the last 3 years and in the undergrad school as well, I'm bit aware about what the things going on in different companies, different startups, and why people are moving towards edge computing. Yeah. Okay. Yeah. Do we have someone? Professor Sabrina, do you want to comment on cloud computing? Okay, no worries. Yeah, perfect. So let's move on. Let's try to understand what are the different aspects of a cloud computing. So, as Professor Ashwini correctly mentioned, it's all about virtual machines, putting the data somewhere in a centralized space, and basically like cloud computing is divided among kind of a different models, different services. Let's say public cloud, private cloud, hybrid cloud, and including services. It can be infrastructure as a service, platform as a service, software as a service, and now I guess like a lot of things are coming up. 5G as a service, a lot of other things coming up on the market. So coming to the public cloud, it's all about like sharing resources among a community of users. So can anyone give me an example of public cloud in the chat window, please? Anything. What do you think? Like we use cloud daily, but we are kind of unaware that it's actually on the behind of the curtains, cloud computing is playing the role. So any example of public cloud? Okay, Twitter. Okay, what else? ThinkSpeak. Okay, yeah, that's kind of a mix of cloud plus edge. Thanks for that, Ashwini. What about others? And keep it very simple. See, social media is one application. Okay, what else? I'm talking about public cloud. Public cloud means shared resources among a community of users. So it can be Facebook, it can be a Google Drive. So Google Drive, like we have access control to each and every folder, right? You can open the access to the people, so everyone across the internet can find that particular folder. They can view, they can add it according to the permissions. OneDrive is there and different kind of stuff as well. Storage services. Moving on to the private cloud service that is control exclusive to a user. So if I give an example like private drive folder, okay, that is only shared with you only, with your email ID and with your colleagues. So that's kind of a private cloud, okay. And hybrid is kind of a mix of both. So let's say VNR is having a website or a kind of a storage service for the faculty members of VNR only. So only the faculty members of VNR and the students will able to access that storage device, right? Storage space. That's where it actually meant by hybrid cloud. So what are the different pros and cons of cloud computing? Why we are talking about edge computing? Why we are talking about coming up to telecommunication and all the stuff, right? So different pros of cloud computing is basically like it's scalable. It's not so much expensive. You just need to pay something for what you want and you go. It's kind of a pay as you go service, right? And choice and agility. So it's up to you what you want and what you don't want. So if I want extra space in my Google Drive, I'll just pay some bucks extra to Google, and they will just give me an extra space. Next is encapsulated change management. Let's take an example. We have a website developed. Okay, Professor Ashwini and I am working on a website, and we are pushing it to the VNR data center. Okay, we are working to develop a library software. I don't know like if VNR has a software or not. So if they don't have, so Professor Ashwini and I am working on developing that website now. Okay, so if I'm going to put on a kind of a single drive or single data center or a server of VNR Institute, we're going to cut a kind of a ticket that we are changing something on the parent server of VNR College, right? So that's kind of a one-click function. If you want to change something, just change it and it's kind of a manageable and automated. And that's where one of the advantage of cloud computing comes into the role. The next one is next generation architectures. Obviously, if you know about it, everyone across the globe is shifting to cloud. even a small scale business, or even a individual person who is actually running a website from his or her home, right? Like let's say Facebook, right? There was an application, I forgot about it, Sarara application. So it's like when you send a message anonymously to someone, so that person who found it and put it into the Google Play Store, he was running a proper private data center from his home. So that's kind of stuff like is actually the power which we get from cloud computing. So what are the different disadvantages of cloud, right? So lock into the service, because you're gonna be locked to a particular service. You don't need have a tendency to change it. Security is kind of advantage as well as disadvantage, because let's take an example. It depends upon your firewall, or it depends upon your security roles which you have deployed on your structure, on your infrastructure, and that's how it becomes advantage and disadvantage. Lack of control and ownership, that's another thing. And reliability. So people think that cloud is not reliable. It's kind of under research work, and that's where it also counts under disadvantage. Okay, so anyone from the Google Meet online audience, Internet of Things, we have heard a lot about this for the last decade. Last decade to decades, I would say 20 years. Last 20 years, where we were all talking about Internet of Things, how we can speak to a smartwatch, how we can speak to a podium, how we can speak to a laptop, Siri, Google Assistant, Alexa, and all those kind of Google Assistant, personal assistant, voice services. These are all comes under, right, IoT. So what's this actually Internet of Thing, right? What's thing in that Internet of Things? So let's understand from a kind of a very high level view. So we have different parameters what we consider in Internet of Things. That is device connection. Obviously, you need some hardware device that you have to connect with, right? That's one thing. The second thing is data sensing. Now you have to capture the real-time data, and that's another thing in Internet of Things. I'm just defining that thing in Internet of Things. What are the different parameters we think about thing is kind of thing. So it's getting kind of rhyming, but it's all good that we are trying to understand the high level view, what actually Internet of Things cloud computing can come and get together and integrate into edge computing. So communication, that's the third parameter. That is like focus on access networks, cloud, edge, data transport, and other stuff. So we will talk about edge computing in the upcoming slides in more often. Data analytics. So obviously you are capturing real-time data, you have to analyze it. So what's the tool? That is big data. You have AI, you have cognitive analysis at the edge. We will talk about edge, so don't worry about it. We have data value, we have human value. So that's kind of different parameters and different high scale value of definition of thing in the Internet of Things. Okay, so let's take an example of edge computing. So what edge computing is all about. Okay, I hope I am visible as well. Yeah, okay, perfect. So you have two layers in cloud computing. Okay, on the top you have the cloud layer, and the bottom you have the application layer. So application layer is kind of Google Drive our users, right? And on the cloud layer you have the Google Drive kind of complete server sitting in Google data center. Now you are the user, you are interacting with Google Drive, and you can't interact with it without internet, right? Am I right? Yes or no? You can't use Google Drive without internet, right? May I get yes or no in the chat window? Yeah. Okay, that's nice. We have people who are not sleeping right now. Thank you so much for that cooperation. Okay, so edge computing is basically like introducing a third layer in the between of cloud layer and application layer. Okay, so edge computing is kind of a IT deployment designed to put application and data as close as possible to use to the users or the things that need them. It's a kind of a distributed model. Okay, so see, I'm wearing a smartwatch, so I have my smartphone as well. So this smartwatch can be connected to this smartwatch using, can I get the name of it? Any protocol? Yeah, Bluetooth is one. What next? Wi-Fi. What next? What do we call Bluetooth and Wi-Fi protocol? It's personal area network, right? PAN. So that's what edge computing introduced you to put all those things. Okay, yeah, smartwatch, yeah. How you communicate with them, right? This is edge layer. This is kind of a sensor. We are not using internet on this, right? It's kind of offline. We are just connecting it without internet through Bluetooth or Wi-Fi to my smartphone. And that's how the data is exchanging between. I'm not using cloud layer here right now. Cloud layer in edge computing is only used if you want to store historical data, right? And that's what edge computing is all about. So I was wondering, like when I did a research assistantship under one of my professor in third year, 2018, and she mentioned like, hey Ramnik, you are doing all these projects from the first year. So all those things what you are doing is actually edge computing, because that's the new term came up in the market at that particular time. Okay, so what are the difference between edge computing and why we need edge actually, right? Cloud computing was already there. Why we need edge? Can anyone please tell me? Let me go back. Yeah. Now, what are the different advantages of using edge computing on cloud? Am I clear with edge computing and cloud computing first? Yes or no in the chat window, please. Are we clear on what is edge computing and cloud computing?
So is it like before transmission, it is of edge, and once transmission started, it is of cloud?
Yeah. So let's take an example. Let me try to make you understand in this way. See, in my smartwatch, I have an option for calculating the steps. Okay. Now these steps will be synced up with my phone without using internet. I'm just analyzing the data without using internet. Now, if I want to analyze or put some machine learning algorithm on the historical data for the last month on the number of steps I took, then we will go to cloud, then we will understand. Cloud is kind of very less important in edge computing. We don't interact with the cloud anymore.
So if we don't use internet or cloud, then we call it as edge computing.
Edge computing, because we are playing on the sensor level only. This is sensor, right? We are not connecting internet with it. That's what. Okay. Professor Wamsi says yes. What about others? Are we clear on edge computing and cloud computing? Yes or no?
Sir, how it is different from an SOC or rather embedded system, edge computing?
No, come again. Sorry, I didn't catch you.
Like you said, the smartwatch without the access of internet.
Mm-hmm.
So how it is different from embedded system? Means I have not understood.
Yeah, no, that's right thing. See, embedded system is actually the crucial part of edge computing. We talked about cloud, we talked about IoT. In IoT, we talk all about Arduino, Raspberry Pi, embedded systems, and all the stuff, right? Not MCU. We are doing some manipulation there, but what's next? We are doing very simple mathematics and simple subtraction or something to get some outcome, right? At embedded system. But what's next? I want to do AI, I want to do big data, I want to do machine learning on the edge without using internet. That's where edge computing comes into the role. You do all the analysis and manipulation without using internet on the edge layer. One of the biggest example is Raspberry Pi. You have proper value, I would say 8 GB of RAM somehow we get now in Raspberry Pi 4 model, and you do all the stuff there. It depends upon your memory card size, what you're putting on the Raspberry Pi. Is that clarify your query, Professor Ashwini? Actually, embedded system. Yeah. Okay. Perfect. So let's understand why edge over cloud, right? So one of the biggest parameter why we introduce edge computing, that is latency. Right now, this smartwatch. Let's take an example. I don't have my smartphone. How I am going to sync up the number of the steps, my blood pressure, everything in my smartphone. Let's forget about edge computing now. Let's talk about cloud. This smartwatch will go back to the cloud server, will connect to internet. It will store the data there. It will analyze the data there, will come back to the user and will share the data. Latency is the biggest parameter why edge computing was introduced over cloud computing. Because internet is not there, right? You don't need to worry about any latency. And that's where actually it improved the efficiency and business performance for fueling the demand of the application. Basically, you have you don't need to require bandwidth, you don't need to require internet, nothing is there. It's just a reliable performance based solution, and that's where edge computing comes into the role from cloud. So now we will understand about basic understanding, like how the things happening on a kind of architecture point of view. Okay, yeah. So let me get the cursor as well. Okay, yeah. Okay, so if you see, this is a single data center. Okay, and let's take an example. This is VNR data center. Now, if someone is standing outside VNR, they need to connect to the VPN, virtual private network of VNR college, right? To connect with the college network. But in edge computing, what we can do, we can just take the chunks of required thing, right? Data center is the main centralized part of all the departments combined together into one single server, right? Now, I don't want internet. So how are we going to imply edge computing there? We have 5 departments. Let's take an example: computer science, electrical, electronics, IT, mechanical, or some different type of engineering domains. In each and every department, you're going to put something called as edge gateway server. Okay, so what it will do, it will take the chunks of the data from the centralized data center for that department only. Now, if any request comes from any faculty member from that department, he or she will not go back to send a request to the centralized data center. He or she will go back to edge gateway server of that department. Time consumption less. There's no bandwidth required, right? Because you are not connected with the main data center. You are connected to an offline edge device that is kind of a Raspberry Pi or a kind of a simple router, right? Router means simple router. I didn't mean by internet there. Okay, without internet. So these are the different kind of aspects where edge computing can help us out. The main part is obviously latency and the delivery of the intelligence, delivery of the machine learning, delivery of the analysis of the data right away on the edge. So what are the different use cases of edge computing? So before proceeding ahead, I just want to stop here just for any questions if we have someone from offline or online audience. Yes, ma'am.
Is it possible for prediction if we are not using any cloud?
Yeah, for sure, ma'am. Yeah, I worked on a project like under research assistantship in my 3rd year. What I did, I worked to predict my house electricity consumption before the electricity people comes to me to showcase my bill. So every month you get the electricity bill, right? How it could be if I can tell the consumer, hey, last week your AC consumed a lot. So next week I will be more intelligent to understand their data offline, right? So what you can do, you can deploy current sensors to each home employees. You will read the current data and you can just apply some mathematics and do a manipulation into a machine learning algorithm, and it will predict you the electricity bill for the next week.
So everything we do offline, storage
Yeah.
of information, algorithm, everything.
Yes. You only store the data which is required for the current analysis. For cloud layer, we will go only for historical data. For years of data you want to analyze, right? That's on the cloud, not edge. So on the edge layer, you will have only very limited storage, right? Raspberry Pi, let's say an example, you can have maximum of 8 GB, 32 GB. Up to that, you can put the data set. But after that, obviously, you have to go to cloud, right? To understand what's the data between for the years. Does it need more hardware? Okay. I'm gonna ask you as well itself, Professor Vamsi. Let's take an example. You have a centralized data center, right? You have a flat servers in the racks. You're gonna consume a lot of expenses on that to maintain it, rather than putting some hardware expenses on the edge layer. This is very cheap. Raspberry Pi costs around 4K or $2,500, 2,500 INR or something, right? So you just need to put sensors, and sensors are very cheap. Obviously, it will need more hardware because you are distributing the model. You are dividing the centralized data center to different kind of aspects, and that's where it actually needs more hardware. I won't say, like, it depends upon the application as well. So that's what. Anyone else? Any other questions?
I mean, will it work in every arena, like industrial or domestic?
Yeah, 100%. See, I went to a factory recently before, and what these guys were doing, they were deploying some sensors on each and every conveyor belt to understand number of the products which actually came out. Let's say it's a what should I say, biscuit manufacturing factory. So you will have flour, you will manufacture, you will do that, and the first belt is to understand number of the kg which is actually coming out, and then you will mold it out, you will cut it down, and then you will bake it up. Every belt has its own option, as its own functionality. Put a sensor to understand what's going on there. Industry, right? Domestic, as I told you, home electricity prediction kind of model. It's all about imagination where we can do that. I usually say this to my sessions on edge computing. I have a bag and you have a bag. So we both are in same class, and there's a mathematics class coming up. Now, I don't have a book of mathematics. I won't be knowing that because I forgot it. My bag will notify to Vamsi's bag. Sorry, Professor Vamsi, not this. There's Vamsi sitting in the offline audience as well. So Vamsi's bag will say to my bag, hey, Ramnik's bag, do you have the mathematics book? So my bag will notify no, kind of a no signal, right? So this kind of imagination, if you bring up, obviously it will help you out. I hope video playing is also applicable, right? We can play video. Yeah. Okay. We will show after the session kind of an example to the Google application. Okay. Perfect. Yeah. Okay. Yeah. Thank you. Okay. So moving on. I guess we have how much time? Till 1 o'clock, right?
Till 1 o'clock.
Half an hour we have. Okay. So what are the different use cases? Now it has been predicted by 2025. This data is actually taken by Statistica.com, and it has been predicted that we have a potential value of $175 billion to $215 billion in hardware to expand into edge computing. Why is it so? Can anyone please tell me the reason? Why we are taking a leap into edge computing? Why it is getting on a peak nowadays specifically? Anyone? Scalability. Okay. Don't use the cloud terminology, Professor Vamsi. I'm just asking why is it like why it is getting so much popular? What are the requirements from the users and consumers these days in the market?
Bandwidth constraints.
Bandwidth constraint, right? Because in the lot of villages in India specifically, we don't have even 2.5 GB, 2.5 G network. So, okay, yeah. So that's one aspect. Like we don't have access to internet more smoothly. What other countries have? 5G has already rolled out, but we are working on the full rollout in India as of now. So the thing is, if I want to Google, if I want to open google.com, I don't want to wait for even a millisecond. That's kind of a demand coming up from the consumers, right? And obviously, I also need, like, if I am stuck in a village and my parents are worried in sitting in home, hare baba, where my child is. So I just need an emergency device without internet, right? Because using internet, it will take time to send the signal to transport department, that transport department or police department. It will signal my parents, location sending, and all those stuff. Why we need such kind of a issue, right? Why we need so much complex structure? Let's have a edge kind of a device on my car itself. Wherever I am stuck, car will notify to my parents directly on the Android phone. Now this can happen according to different kind of aspect. We need to understand about the use cases as well. Now that's where I am coming up. Industry at the edge. People are talking about a lot in industry. I am part of one of the standard working group in Bangalore, Electronic City, when I was working for Wipro last year. So what we are doing there, we are working with IEEE Standard Association. It's a working group, so everyone, academicians and industrialists can join for free. I will share the link after the session in the chat window. So let's take an example, IEEE 802.xx series, right? Wi-Fi or internet protocol. Who are those who are creating this? Those are us, right? Volunteers, academicians, professors. So you can also become part of those working group for free. And just imagine, a protocol is coming up from 6G all across the globe, and IEEE is a kind of a standard organization. On the second page, you will have your name in the protocol contribution. That's kind of a recognition which you can get being in industry, right? So what we are doing there, we are analyzing the traffic using edge computing and 5G on Electronic City Bangalore. That's the biggest rushy area all across the globe. Bangalore is very famous for traffic. I don't know about Hyderabad because I didn't face so far. So that's kind of stuff. So that's where the edge is also playing a crucial role in industry. Retail at the edge. Now people are talking about for a city, for a street even, I can have an edge Raspberry Pi, and all the local small scale shops of that street can be centralized to somewhere, and it can be connected to other streets, and it can analyze a proper manipulation of the data, right? And we can obviously do prediction there. The third one, healthcare. I believe many of you have got this idea. A lot of projects were working on when COVID happened, March 2020 in India. A lot of people were deploying drones to transport the medicine. A lot of people were deploying robots to analyze the situation of the streets and all the stuff. How was that? Is what internet was there? No, not at all. It was completely local. Local sensors on the robots were analyzing the situation, what's happening there, right? You're connected with the Argue Setu app, right? From that, we are analyzing number of the Bluetooth people who are connected to that application who are COVID positive. And we are analyzing the data locally and we are putting to the government. Okay, this particular 5 streets are having such numbers of COVID positive. There was an application came out in the market where, not in the market, but there was some student community who were working in last, I guess, November or December, I remember 2020. What they did, they integrated Google Maps with the local data of the healthcare services. Now you have 5 hospitals in, let's take an example, I'm taking a very lay example, I'm not pointing to any city. You have 5 hospitals in Hyderabad in a single place. Now those hospitals, if I am in very rush, my family member is kind of getting rushy towards COVID thing, right? Is not able to breathe and all the stuff. Will I have time to visit each and every hospital to check if I have a COVID bed there or not? Not at all. And that's where the application came. You analyze the local data and put on the Google map. Okay, this hospital has number of this positive, COVID beds available, right? And that's kind of stuff happening. Coming to finance, yes, finance is also working a lot in edge computing. Education, today we are facing that. Today we are actually using edge computing here. We have a camera here, which is not using internet, but we are connecting the camera to the laptop. Laptop is not using internet, but we have a Google Meet to connect to the cloud layer. Now, people who are sitting maybe in the college itself, they can connect to the college network and they can join this meet for without internet, right? That can be a kind of a use case. So education at the edge, Li-Fi is there, Wi-Fi is there. A lot of new solutions are coming up, include with edge computing. So there's a kind of a issue going on in research world. People say, what's the difference between edge and fog? So let me tell you how the terminology came in the market. So let's forget about edge computing as of now. We know what fog is all about, right? Fog is actually on the top layer, like of the farms or something when winter comes, right? And cloud is kind of on cloud layer. So fog is actually near to the ground level. So that's where fog computing is basically sensors and applications near to the user. And edge computing is like, if you see the diagram, in the last we have smart end devices, that is millions of users like us. We have a fog layer. Fog layer is a kind of a combination of edge plus fog. Okay, so if I highlight here, so if you on the left hand side you will see tens of thousands of fog, right? And we have mist layer and we have cloud layer. So that's where kind of a difference comes up, like fog to fog link, fog to edge link, edge to fog link. So the difference is only differentiating the application, the sensors, and what kind of application you're deploying. If you are having a smartwatch, what are the different kind of distribution you can do? Smartwatch is a user, is with user, that is fog layer. Now into this, I have some sensors, I have some, I would say embedded system or some programming is going on. That is on the edge layer, not on the fog layer. Sorry, is there someone? Oh, okay, that's from the background. Okay, so Moving on to analyze the telecommunication now coming up. Okay, now we talked about AI, and through IEEE Computer Society, the top 12 technologies for 2022, Edge @ AI is kind of on the top 5. So why this? As I told, we have a lot of cameras in Delhi. I guess in Hyderabad also we have that. They capture the peak if you are overspeeding, and that's also offline. That will be stored in the offline kind of a pillar or something, some local data center nearby to the police department, traffic police department, and then they will compile it and they will put on the server. Okay, your car or your vehicle has been issued this particular challan. That is happening offline, and then coming to cloud, right, for distributing the information. AR/VR, safety monitor, location tracking, autonomous, all the mission control, I would say mission control application. Let's say you have to run an ambulance. If there's an emergency, how are you gonna call an ambulance? You're gonna call, right, to the emergency number. But I don't have that time. I just need to click one red button and that's all. My location and latitude, longitude and latitude will be shared with the local edge layer, and it will be triggered to the nearby healthcare services, and they will shoot out ambulance to my location. That's kind of stuff we can do without internet, right? Where the 5G came up. Now people are talking about 5G a lot for few years now. So, and 6G is also coming up to roll out completely soon. I can't promise for India, but maximum of the countries are testing it. So we can see where the future goes. So where 5G and edge computing comes into the role. So 5G will obviously act as a fuel to edge computing. Why so? Because edge computing don't need internet, but 5G bandwidth is kind of which is actually satisfactory, the latency and all those issues, right? You can have all the streaming and all the stuff which we were thinking that we can use internet for, that will be transferred to edge. And that's where 5G will act as a fuel for edge computing. If you see the diagram, we have public, private, edge cloud, macro cell site where we do roaming change, like SIM change from moving to one city to another city. We have vehicular connection, putting 5G onto that, putting AI onto vehicle. That's all kind of different use cases. Different researchers are exploring, and there are a lot of research papers and journals going on around that. So we talked about edge computing a lot. We talked about cloud, IoT. Now, how to get started? As a faculty, there are different kind of resources as well as an undergrad student or student. If you want to explore, we have different kind of IoT edge based solutions available in the market. Azure IoT Edge, Lambda, Dell Edge Gateways, VMware Pulse IoT. You can just take a screenshot of this slide so that you can research it on afterwards as well on your own after the session. We have Watson, Foghorn platform, Cisco, Edge routers, and list goes on, because a lot of people are exploring it, a lot of people are researching on it, and different kind of simulators. That's where I actually learned when I was learning edge computing in my third year. Cisco Packet Tracer, one of the wonderful tool for teaching students about networking, basics on networking, and all of the stuff. OpNet, that's another open source software. OMNet++, Melbourne Clouds Lab. So there's a professor from Australia who is working on this edge computing lab, and his students have set up this Melbourne Clouds Lab. So it's kind of a simulation on the edge, how to make edge server, what are the different communication algorithm you can deploy. So that's where that tool actually comes up in a very handy way. MATLAB is there. We all are maximum aware about it. NS3, network simulator, INET framework, and Simulate. So these are different simulators platforms which you can use for exploring edge computing. With that, I have 20 minutes now for any questions, for any discussion. I will stop my sharing and then we can move on to the video and we can discuss. Okay, thank you. Thank you, everyone. So looking forward to hear any remarks, any feedback, any questions. Please go ahead.
Yeah, will edge computing work for biomedical devices like pacemaker? Like, because it's an issue of hardware and power consumption. Will it work for the biomedical devices?
Yeah. So one of my friend Kritika, Aishwarya, and Bhagya, they are working on robotics and biomedical devices in National University of Singapore. So I had a chat with them regarding this same topic, and what they say, see, it depends upon body to body first thing, right? How you can deploy those biomedical devices, and obviously you can do that. Like we have mini robots which you can inject, right? Which you can swallow, and it will analyze all the data locally, what's happening in your body, and will inform to your application, and that application will be transferred to your doctor. That real-time analysis obviously can be done. So, but the question is how reliable that solution is. Are you ready to swallow a robot in your stomach? No, I am not. I won't ask that doctor. Okay, please. It's very risky. I don't want to swallow a robot tablet or something. So that's kind of where things actually comes on the brainstorming level, right? So I would say diplomatically, yes, it can work, but diplomatically it depends where you are deploying, who are your customers, what kind of disease you are trying to analyze, and all this stuff. Yeah. Thank you. Anyone else from online audience? Everyone can see the chat window in the offline audience as well, so feel free to ask any question. Yeah, thank you, Professor Vamsi. Don't go out. I guess we will have a capture as well, screenshot as well with all of you. We will play a video as well. Let me play that now. I hope, yeah, YouTube is working. Let's take an example of this. Let me find it. So have you heard about Google Smartbox? Anyone on the online audience? Yes or no? Google Smartbox. I'm not promoting. I would say I'm not giving a promotion to Google, but they actually roll out some kind of April Fool based videos, which actually make me understand about a lot of things, what's happening in the market and what they are bringing it out. Anyone? Google Smartbox? Yes or no? In the chat window, please. If not, it's fine. I'm going to play the video. Yeah. I already shared that. I will share the PPT as well with all of you in the chat window so that you can take the slide share. So as of now, let's go with the video and let me play that. Yeah. Sorry? I'm going to play here. Okay. Okay. So I can share the tab of YouTube here and to share the audio as well, right? Normal. Without unmuting, you can show. Without unmuting, it can do. No. Audio visible audio is coming here. Acha. Okay. So how are we gonna do? Shall I type YouTube here? Yes. And the first one. Okay, the professor is actually running the video, so let's wait for it.
The mail. It was the greatest of inventions that built a nation and brought us.
From here.
Entire screen is
First option.
The mail. It was the greatest of inventions that built a nation and brought us, all of us, together. And yet, as we've become more connected, the mail has stayed pretty much the same. It just sits there, in a box, all day. Well, we think it's time for a change. Introducing a new way to experience the mail you love. good old-fashioned kind that you touch with your hands and smell with your nose. Imagine a mailbox that saves you a trip when nothing is there, or notifies you the second it arrives. A mailbox that learns from your habits, that's never too hot or too cold. Mail for today, with all the things we love about the electronic kind, like smart folders that keep things organized, strong filters to weed out spam, and apps that do more. Imagine mail you can take with you, wherever you go. It's time. Time to free your mail.
So I hope you got the idea, like what I was talking about edge computing. So let's take another example of a recent launched Amazon Astro in September 2021, and it's kind of a personal assistant. I guess it's actually ordered on special request from Amazon. So let's take an example of that robot now. Are you all able to hear the audio and video as well? Like able to see properly, right? Online audience? Yeah, okay, perfect.
A robot. Yes. What are we going to do with a robot? Well, Astro, follow me.
I miss you too. Hey, you got the toy I said. Yeah, I love it. Astro, follow me. Cool. All right, miss you. Come on.
Told you I'd take it off.
And now I tell you to leave here. Ooh, thanks.
Message from Steve. Remember to do something green today, Dad.
Check.
Astro. Let's dance.
Thought we weren't home, huh? You thought wrong. Good try, though.
Thank you. All right. I'm in.
Yeah, so how many of you got the idea about edge computing now more completely? I hope you understood what I was trying to make to understand, like how edge computing can help us out to roll out new things. And these things are available online, so you can just Google them and you will be able to understand if you want to order your own personal assistant. So that's where. So let's move on to the any questions or something if you have. And please unmute yourself. It's fine now. We are open for questions, so directly we can talk. And please, if it's kind of, you can. Yeah, all good. So it's kind of like when I call students to come on camera, they come instantly, and now I'm calling professors. They are kind of behind the camera. So please feel free to join me on camera.
Maybe camera is not there, sir, for their system. That is the problem.
That can be one of the good excuse, ma'am, but it's fine.
No.
Meanwhile, let me share the presentation as well with you all in the chat window. So that's a kind of a mixed version which I'm going to share with you from a past talk which I did, but the content is same. So there you go. I just shared you on the chat window. Okay. No questions, no remarks.
But all edge computing finally should go to, should depend on cloud computing, finally.
I would say like that's the research work like going on. We should say that edge computing should be independent of cloud completely, but that cannot be done, right? Because you have to store your historical data somewhere, right? And your memory card of 8 GB can't hold all those things. So that's where, yeah, it's depending, yeah. It's kind of extending the cloud computing. Edge computing is kind of that way.
A small question. I mean, if 5G come into the picture as latency issues will be resolved, will edge computing will be there or it will be?
Yeah, that's a good question. But the thing is, 5G is gonna come here for transmission of data. See, 5G we talked about only high-speed bandwidth, right? There's other things as well, multimeter waves and all other stuff as well coming up into the role. So we can't say if 5G comes, edge computing will be out of the picture. Not at all. When Python came, Java is not out of the picture, right? So it's all about the basic needs what the consumer want. Edge computing is for edge layer. 5G is gonna be for cloud layer, right? That's where the difference will come. But both will come together when it's mission control kind of applications. We need more urgency. We need more reachability to the people more in a more effective way. That's where the combination will come. Okay. So are we good to take a group pic then? Yeah. Okay. So may I invite everyone on camera now, finally? Not for questions, just for a group pic. Yeah, there we go. Professor Vamsi is right away ready. I hope you enjoyed it, sir.
Yes, it was very nice talk, and I got to know some new things. Okay, actually, I've not studied in detail about these areas. Okay. Thank you so much. Thank you.
Thank you, sir, for joining. Other professors, please come on camera. I can take a selfie as well, even if screenshot of from laptop doesn't work. Ashwini ma'am, Vijay sir, Lakshmi ma'am. It's fine. Okay, they are coming up nearby. We need to call them. I'm not a professor, please. I don't know how to pronounce names as well. I don't have that habit like you to take roll calls in classes. So please come automatically on camera.
They do not have camera, some of them.
So they're sitting in the Okay. I just understand that you may be sitting on desktop, you don't have camera inbuilt, USB camera, so it's fine. So we have 3 people, like including me and my laptop. So all good. We can take a screenshot or some kind of selfie or something. Let me take it from my side. So on the count of 3, 2, and 1. You have to smile as well, Ashwini ma'am. Ashwini ma'am. Yeah. On the count of 3, 2, 1. Okay. I guess we are good here. And I send the pic to the organizer as well. Okay, perfect. So over to the moderator. Thank you so much for listening me. Thank you so much for having me offline. I will be covering a second session on best practices of IEEE student branch planning and operations after the lunch. That schedule will follow. 2 o'clock, yeah, 2 p.m. IST. We will be covering that after 2 hours. Yeah, over to you. Thank you, sir.
Yeah, thank you, Romney. It's a great thing. Yeah, hard. I mean, it's the first time I'm also having the occasion with Romney. I heard like from many students or many people and professors saying that the kind of presentation that you do is wonderful, and now it's witness. I witnessed the presentation. And moreover, I would like to share one thing here. People are more vulnerable to the YouTube videos, especially the advertisements. But ourselves, sometimes we restrict to keep searching for what you are looking. So that is the habit everyone is having, I feel like. So now with these 2 videos, I feel like so that vulnerability should increase to explore into more ideas. And moreover, coming to this presentation, the clearest to clear thing, it's kind of crystal clear what is the edge, what is cloud, and where you have to work it on, the insights of the public and marketing strategies and whatnot. So the communication, how he is working out the tile 2 head, right? Ramnik, it's really a great presentation. We are wonderful. It's being here, I myself feel very happy. So guys, that's it from our side for this morning session. So after lunch, we'll again meet with the same speaker, but the topic is best practices of IEEE student branch planning and operations. Right? Thank you guys. Thank you very much. We'll meet right away after lunch, 2 p.m. Thank you. Thank you.
మళ్ళీ స్టార్ట్ చేసుకున్న తర్వాత ఒక నిమిషం ఓకేనా కెమెరా
Shabri, are you ready?
Ready, ma'am.
Okay, where are you? Are you in auditorium or in your
ikkadone lab only, ma'am. In lab only.
Okay.
I'm ready with my kit, ma'am. Everything is ready.
Aya, please continue session from 1 to 2.
Yeah, okay, ma'am.
Okay, Ramnik will join at 2.
Yeah, okay, ma'am. Sure. Okay, ma'am. Good afternoon, ma'am. Is my screen visible, ma'am?
Yes, Shabri.
Okay, ma'am.
It's fine.
Okay, ma'am. So, good afternoon, everyone. Myself, Shabarinath, working as assistant professor in the EC department of VNRVJIET. So today I'm going to present about the issue of implementing the machine learning. So these are the topics. So first, I would like to introduce the aspect of implementing the machine learning. Then I would like to suggest few platforms. Then we would like to focus on the concept of hardware acceleration. So which is a primary topic of today's session. Also, I would like to demonstrate one of my recent works, traffic sign classification implementation in edge platforms. Okay, so coming to the machine learning. So machine learning is a field of study that gives computers the ability to learn without being explicitly programmed. So So generally, machine learning solves various problems like supervised learning, unsupervised learning, reinforcement learning. So mainly today's session, I'm going to concentrate on classification issue. So in case of machine learning, where we have a handcrafted features, so there will be two main phases of machine learning, where initially we perform training on large data sets and estimate the model with the parameters. So using this model, after estimating this model parameters, later we use there is a process called inference. Then we can estimate the using this model parameters. We can infer the new. For example, in case of image classification, we can give new images to infer the insights of the data present in the image. So this is what that machine learning is about, where we have a handcrafted features. In case of deep learning, uh, so deep learning is ability to extract high-level features from the raw sensory data after using a statistical learning over large amounts of data to obtain. So this is what the formal definition. Where we have the main difference is here the features also extracted by itself, by the network itself. So based on the different applications, we can choose different deep neural network architecture, like simple regression or classification. We can go for fully connected network. For example, object detection, we can go for convolution neural network. Speech recognition, we can go for recurrent neural network. Self-driving cars, we can go for some hybrid network. So here also in deep neural network, we have two phases. One is a training phase and inference phase. So in training phase, where in case of a supervised learning scenario, where we give an input and output to train a model. So once the model is trained with its parameters, we can deploy for predicting the outcome of the novel inputs. So this is what the brief introduction to machine learning and deep neural network, deep neural networks in the context of implementation point of view. So where we have two phases, a training phase and inference phase. So coming to the today's aspect of implementing the machine learning. So machine learning, so a lot of research has happened in machine learning, like machine learning and deep learning. They're inventing new networks, new kind of applications are coming on. But for every application, there needs to be a proper implementation, proper custom specific implementation must be there. So recently, many researchers have been working on improving the machine learning algorithms using high performance hardware. So the recent success of machine learning is not only due to more effective algorithms, but also to most effective systems and implementations. So this is also one of the research area where we have an algorithm, machine learning algorithms needs to have a implementations, proper implementations. So these are the different platforms which are used. So coming from software only implementations to custom hardwares like DSPs to hardware acceleration. So today, main focus is on implementing machine learning algorithm using the concept of this hardware acceleration. So using hardware acceleration, we can obtain high accuracy as well as high speed. So this is what the today's topic. So I'll give hands-on demonstration of this. So why we implementing if you consider implementing machine learning, so generally machine learning two phases, training and inference phase. So generally training is performed in the high-end platforms, like if you take Google Colab, like that, we go for cloud based training where we have a massive scale compute power. So and once the model training is done, we can deploy either in cloud platforms. So but there is if we deploy the models in cloud platforms, there are few limitations, like we obtain a high, even though cloud has a massive scale massive compute power. So in many real-time applications, cloud-based inference is giving a high latency, low energy efficiency. Also, if any sensitive data needs to be sent over the internet, may leads to security issues. Also, it is high cost. So there is an alternative option where we can deploy the machine learning models in the edge computing platforms. So edge computing platforms offers where the data, as sir told, data is kept local in edge platforms. So there is no security issues. Also, it provides a low latency, which is suitable for real-time performance. Also, it offers high energy efficiency, low power, low cost solutions are there. So rather than sending data to the cloud for inference, so we can infer in the edge platform itself. In the on-the-fly machine learning inference is possible. So today we are going to demonstrate one of the project. Before one of the project, for example, we have taken example of traffic sign classification. So before that, okay, see this. So these are the different platforms where we can edge platforms available, edge solutions available. So only CPU solution, and CPU with GPU solution, CPUs with FPGA solution, CPU with ASIC solution. So different solutions are possible with this. For example, if you take embedded GPUs, so there are different boards available in the market like Jetson Nano boards, Jetson TX1, Jetson family boards. So which can be used as an edge device in order to deploy the machine learning model. These devices are available. So there are also one more important solution called embedded FPGA. So these embedded FPGAs are reconfigurable devices. So we can reconfigure. So there are many architectures are available in order to deploy machine learning models like Xilinx Zinc 7000, Xilinx UltraScale MPS4C, like that. Okay, Kyra system on modules, like that. Many devices are available. Similarly, we can have a embedded ASIC solutions like you might have heard about Neural Compute Stick, Google Coral. So these are the different ASIC application-specific integrated circuit solutions. So today, the main focus is on concentrating on implementing using one of the platforms called embedded FPGA platform based on the Xilinx Zinc 7000 architecture. So how to develop such a concept of hardware accelerator? So what is hardware accelerator? So hardware accelerator in which we have both CPU and hardware accelerator. So here the hardware accelerator is based on FPGA. So FPGA is a massive parallel structure. So which is the architecture of FPGA comprises of lookup tables, DRAMs, so all those stuff. So which is a massive parallel compute structure, so which can compute in a parallel fashion. So what we do is we have a CPU in such architectures. We have a CPU which is executing sequentially. So hardware accelerator, which is FPGA based, which can execute a parallel fashion. So CPU is a main controller. So CPU can coordinate with hardware accelerator. So that coordination we need to, as a designer, we need to establish using different protocols. Now CPU can, for example, in our algorithm, for example, in a CNN, for example, if you take a convolutional neural network where the convolution operations are very compute intensive tasks. So in order to perform convolution neural network convolution operations, what we can do is, so since they are compute intensive, that convolution neural network operations we can implement as a FPGA. We can run them parallelly. We can implement them parallelly. We can extract the parallelism from that computation, and that compute intensive tasks we can implement as a hardware accelerator in FPGA. Now what we can do is we can send the data. So whenever that compute intensive task comes, CPU will coordinate and send the data to the hardware accelerator. So hardware accelerator will compute that whatever the compute intensive tasks we need to offload. So that part will be computed in a massive parallel way, so that after computation it can again transmit the data, so that CPU can continue its process. Like that, CPU can execute sequentially, hardware accelerator can execute parallel fashion. So like that, we can have a number of advantages. One is we can speed up the execution, we can control the power, so we can improve the performance. Like that, many advantages are there for such a hardware accelerator. So this is one of the prominent research area which is happening in today's scenario. So implementing machine learning. So in order to establish that a hardware accelerator, there are number of tools. So every company has their own tools. So today I want to focus on this board, pink we have a one board called pink board. So let me show that. So we have a pink board with me. So this is one of the edge embedded edge device, embedded FPGA based edge device, which can be used for implementing the machine learning algorithms. So in order to use this board, in order to utilize this board, we need to use certain tools. So this is based on Xilinx board. This is a pink Z2 board. So first of all, I would like to demonstrate this how to develop a hardware accelerator, utilizing this board. So then I'll demonstrate the work we did, that is traffic sign classification. So before that, so let me give brief introduction about that board. So this board is nothing but a heterogeneous system on chip, so which has both PS and PL. So PS is nothing but the processing system. So processing system boots first. So processing system is nothing but the processor. Here I'm talking about the CPU. So this is a processing system. So this is the terminology. So this is the processing system. So it has this has a dual core ARM Cortex A9 processors. Two dual core processors are there in this processing system, in this pink Z2 board. So it has a fixed processor. Okay, all these memory controllers. So everything is there in this. So also we have a PL. So this PL is nothing but a FPGA. So PL is nothing but the programmable logic. So this board has a PL, which is based on Arctic 7 FPGA family. So it has a different resources. So like DSP blocks, block RAMs, serial blocks, so PCI. So these are the different resources, lookup tables. All these resources are available in this PL blocks. So also it has interconnects, AXA based interconnects. So these are the different PSPL. So now what we need to do, our agenda is to map an algorithm to PS and PL in an effective manner. So this is also called hardware software co-designing. So where we have a sequential software and parallel hardware. So this sequential software and parallel hardware coordinating with each other to run an algorithm in an efficient way to achieve low power, to achieve high performance, to achieve high speed up. So this is the main objective of mapping in such a structures. Okay. So today agenda is actually we are using this pink framework. So this board which I'm talking about, just now I shown this pink Z2 board. So this supports the main advantage of this board. In a general scenario, generally we need to use certain things, but the main advantage of this board is we can use a Python. So we can use Python language in order to develop acceleration, in order to develop a hardware accelerator, in order to develop application for hardware accelerator, so that we can use the all readily available Python libraries. Like we can use scikit-learn, we can use NumPy. So all such libraries we can use. So that is the advantage of this pink architecture. So this is the pink framework which I already downloaded in this. So this pink framework, what it can do is we can write an application using a Python in a Jupyter Notepad. I'll demonstrate how to do that in a Jupyter Notepad, which is supported by Ubuntu Linux. So using this Python APIs, using this Python language and Python APIs, we can access the FPGA also. We can even access the FPGA. So that is the main advantage of this pink framework. How to do that, we'll see. So there is a concept called overlay. So whatever the logic we are writing in this PL, this is called an overlay. So there is a pink community is there. So in this pink community, you can find a number of overlays. So the advantage of using this overlays is we can use for different applications like machine learning, image processing, RISC-V, Kalman filter, like that. Many overlays are already available in this community. We can readily use them. So today I'm going to demonstrate one of the how to develop such a overlay, how to use such a pink framework. Everything I'll demonstrate with a simple example. So after that, I'll demonstrate our work for traffic sign classification. So let us start this. So this is what the architecture. So in this architecture, we have a PS processing system, so which is supported by so this is a processing system, A9 processors, which is supported by L2 cache. So this is the AXI network, and this is the PS system, which is this is a DDR external memory is there. So memory controller is there. Now this this processing system can communicate with PL using this. So this is the communication. So one thing is bit stream. I'll tell what is bit stream. So bit stream is what the logic which we need to dump in, which we need to execute in the FPGA. So also this PSPL can communicate with different entities, like you can communicate with GPIOs, you can communicate with interrupts, we can communicate with master AXI, slave AXI interfaces. So these are the different interfaces we can establish between PS and PL in order to establish the communication between these two. So this is what the tools we are going to use. So whatever the logic, the compute intensive part of the algorithm that we need to describe in the C language, then we can use this Vivado HLS tool in order to develop this is a Vivado HLS is nothing but a high-level synthesis tool. So using this high-level synthesis tool, we can convert this C language or C++ language code into the Verilog code directly. So the main advantage, this is what the achieves the higher productivity. So since many software developers don't know about this HDL language, so they can directly write the C description and they can use this Vivado HLS tool to convert to HDL. Then we can integrate this IP in the Vivado tool. So this process, let me demonstrate with a simple example. So this is a Vivado HLS tool. So today this is what I'm going to demonstrate this example. So this is the example which is available in the Python Pink website. So this overlay we are going to design now. So this is what we are going to design. So later I'll demonstrate the work we did. So that is under publication. So this thing will I'll try to explain how to design such a overlay, and how to, this is what PS, and this is what the IP which we are going to design. So this IP we are going to design for simple addition and multiplication. So let me start designing this. So you can create a new project in this. So we can specify a folder for this. We can specify some name for this project. So here you can skip this. You can choose a part name. So here you can choose that respective part name for the board. Here the okay. Here this part name is XC7Z. Okay. So okay, you can choose this. Later I will. Okay. So once you choose this, you can add a source file. You can create a source file. For example, admul.cpp. So after adding this code, you can add this code. I have the code with me. So this is a simple code. So this is the code. Actually, what I'm trying to do is, so here I'm describing a C++ code. So C++ code which can able to perform addition and multiplication. So for simple example, I'm showing. Later I will show for that machine learning code. So this is what the code which I want to implement in the FPGA. So this code. So after this code, what I can do is, after writing this code, so the main advantage of this tool is you can provide so what this code will do. So this function, this is add mul function. It is taking two inputs A and B, and it is providing two outputs C and M. So these two are the outputs. So this is the computation it is performing. So this is the thing. So now these are called pragmas. So the main advantage of this is called pragmas. So what are pragmas means? These are nothing but the optimization. We can give different optimizations for this logic using this pragmas concept. So if I want to, so this is a simple example, but if you have any complex logic like machine learning, you can give different optimization techniques. See here, for example, if I want to give optimization, like I can insert these directives. So if I like that, I can, using this tool, I can give different optimizations. Like I can give different optimizations like pipelining, like different parallelization techniques I can apply for this. So you can see here. So these are the different optimization, interface optimizations, resource optimizations. So like stream optimizations, like that I can give different optimizations. Available. So based on for this logic, I can obtain. So the main intention is I can extract the parallelism. So directly, if you want to write if you want to extract parallelism, that's very difficult. Using this tool, what we can do is whatever the computation logic here we are writing. So in this logic, for this logic, we can extract the parallelism by using these directives. That's what I want to say. So after that, we can synthesize this. If we can synthesize this. So if we synthesize this to, so I think we need to, sorry, here. Here I need to mention the top function. This is the top function. Okay. So after that, I can perform synthesis. So it will take a few minutes time. So So once we perform synthesis, we can export that as an IP. It is finishing. Yeah, you can see here synthesis has been completed. So what we did is we have just written a C++ code and we have given some optimization technique, optimization things. Like here I have given interface optimizations for this ports. So here I have given a interface optimizations, like here I have given AXA Lite. Here I am using AXA Lite protocol. So using this, so that's what I'm mentioning. So there is a protocol between there is a proper interface between PS and PL. So this is the interface, AXA Lite interface. Now I get I perform synthesis using this tool. This tool performs synthesis and it has converted to Verilog code. So this is what the synthesis report. So in this report, it is giving a latency of 2. Also, it is giving this utilization summary. So since it's a very simple logic, it's taking few resources. Now the thing is, this all, if you can observe here, solution. You can observe the solution here, implementation. Okay, you can go for this drivers. Okay, so here you can see here in this file. So here you can see here for that for this values A, B, C, we have an address allocated. For example, A address will be 0x10, B address will be like that. We'll get this memory mapped address for each of these ports which we have used. So after that, what we can do is we can export this as an RTL. So we can export this as an RTL. We can export this as an RTL. So here we have some problem. So we can export this as an RTL. So what we get is we get an IP. So now we get this IP, which we can integrate using a Vivado tool. Okay, I'll show this. So once this will be packaged into IP, so let me show in this. So now this is another tool. So here we get an IP. So which is okay. So this is done. It will be packaged into IP. So now after that, this is a Vivado integrator tool. So this tool, again, we can create a project here. So now we can utilize that IP to form an overlay design, to form a block design using this tool. So for that, yeah, this has been completed. Okay, finished exporting RTL. So now let me create here the project. So Vivado project. Okay, so RTL project. So later we can add sources. So here I'm choosing this, actually I'm choosing this board. Actually ping board, yeah, ping Z2. So this is what I'm talking about, ping Z2 board. So finish. So once we create a project, we can form such a design. So now what we did is, so we have created this IP. So this HLS IP we have designed. Now in this using a HLS tool, so we also added interfaces, AXLite interface. Yeah. Now this project is created. So this is what the board I'm interfacing. I want to implement. So here I can create a block design. Here I can create a block design. So now what I can do is, whichever the IP I have created, I can integrate. I can form an SOC design using this tool. This is a Vivado tool. This is actually this is a Xilinx based design. So for Intel, there will be different tools are there. So if you take different companies, there are different tools are there. But my research, I'm working on Xilinx tools. So what I need to do is, so before I need to go for settings, I need to get that IP whichever I have designed now. So that IP I need to get. So for that, I need to specify the repository of that IP. So just now I created that project. So in that project, so this is a project HLS project solution. So here, if I get this, so this is the IP. This is the IP which I have designed, which I have created. Now I can add that IP, add an IP. Okay. So this is what the IP which I have designed now from the HLS tool. So I'll get that IP. So this is the IP. Now I can add the Zinc system, processing system. Can add the processing system. So once I get a processing system, I can write I can directly use this connection automation. Then I can perform this block automation. So, but this is in this situation, it's very simple. But if you want to design a complex circuit, complex situation, you need to add more IPs and all. So see, this is a simple SOC. This is a simple SOC which we have designed now. So here we have designed this IP using a Vivado HLS tool. This is a processing system. So what this processing system can do, this processing system will send the data to this IP using this AXLite protocol. So then what it can do, it can perform that operation. So here we have designed addition and multiplication operation. So after that, we can perform this VLSI flow, like VLSI flow, like we can generate a bit stream. So whatever the bit stream, so we can generate a bit stream. So it takes a lot of time. So I already did this. I'll use them. So we can directly generate a bit stream. Then it will perform a synthesis process. Then it will run implementation, and finally it will generate a bit file. So that's what the thing it will do. So now the thing is, after generating a bit file, we'll get after doing, it's just a matter of clicking. So it will do that process, and it will generate a bit file. It will take some time. So since a lot of things are there. So after generating a bit file, so this is what I did yesterday. I did this project. So these are the files which we need to have. So one is bit file, one is a hardware handoff file, and one is a tickle file. So these three files we need to have outcome of this project. So these three files we need to store, we need to save. So these three files have we need to rename to the same name. So once we do that renaming, these are the three files. Now what we need to do is, so this board has so this PingZ2 board, has a this PingZ2 board has a SD card. So in this SD card, like a Raspberry Pi kind of system, we need to use this pink image we have used a pink image. So in this pink image, we need to copy in this pink image. So here we have a SD card in this. So in this SD card, we need to copy all the files which we have used that files. So that files, in order to copy that files, we can use a software. So this is a software, WinSCP software. So in this software, so in this folder, I'm copying these 3 files which we have created just now using this Vivado project. So design1.bit, design1.hardware handoff file, and tekil file. These 3 files we need to copy here. So that is done. Now what we need to do, now we have copied that. Now we can run the application. So in order to run the application, we need to connect this board to the internet as well as our laptop to the internet using a LAN cable. So once that is done, we need to use this pink address, pink -9090. If we use this address, then that just a minute, some problem is there. So 1 minute. So meanwhile, it is booting, that system is booting. So meanwhile, I'll continue with this presentation. So, so far we have seen this procedure. Yeah, it started booting. Yeah, now it is opening. If you give this address, a Jupyter Notepad will open. So as I told already that this Pink framework is supported by Linux. In that Linux, this Jupyter Notebook is there. So in order to write application, you can use a notebook. So see here. So this is a simple application. So now, first of all, this bit file. So this Pink framework will give all the necessary classes and objects, classes required to use this write the application. So previously, without Pink framework, what we need to do is we used to have a SDK tool, software development kit. So but now with the Pink framework, the advantage is we can use the readily available Python packages in order to use for different applications like machine learning, image processing. So that is a main advantage. The first thing we need to do is we need to use this overlay object in order to this overlay class in order to dump the in order to put this bit file into the FPGA. So this is what first thing we need to do. So this is what the bit file we created. So this bit file we need to put into the FPGA. So if you run this so this is just a shift. If you use shift enter, so this will run. So this is what the overlay. So you can see here, this is what this add mul block and the processing system block which we created. So these two are there in this. This is just I'm giving the help overlay what is object it has. So these are the two IP blocks which we have in this. So after that, okay, then now we need to, if you want to perform certain operation, like here in this case, so this is just a interface, MIMO interface. So this is the register map. So add IP that register map. You can see here initially A, B, C, M. So A, B value are 0. Now in order to give the certain values, like if I can give like this, add IP dot register map dot A. So A value I'm giving, for example, if I give 30, if I give B value as 40, so what it will do, once I run this, execute this cell, A data will be sent to the PL, B data will be sent to the PL. So C is nothing but A plus B. So M is nothing but A into B. That result we can observe. So that's what we can observe. So you can see here 30 into 40, 1200, that result is there in M. Similarly, you can see here. So this is what, now the A is 30, B is 40, C is 70. So we can have M is 1200 and C is 70, 30 plus 40, 70, 30 into 40 is 1200. So this is what this pink framework, the advantage of this pink framework. Now I would like to demonstrate this is what the simple thing, simple tool flow which we want to give hands on, like in this. After that, let me demonstrate the application, the advantage of this kind of framework. So using an application. So see here, this is one of the application which we recently worked on, driving assistance module. So in this driving assistance module, there are many issues out there. So one of the issue is traffic sign classification. So generally traffic sign, in order to have a traffic sign classification in case of a self-driving cars, you can take an example of self-driving cars or a driving assistance in the context of autonomous vehicle. So semi-autonomous vehicle, you can take a driver assistance module. So where this traffic, after capturing the image and localizing the traffic sign, so this traffic sign image would be sent to a cloud platform. So in the cloud platform, this deep neural network will infer, so whether that traffic sign, what is the traffic sign. So that is latency in a real-time performance. In a real-time situation, it's not, it offers more latency. So edge-based solution we can have. So where we can deploy this deep neural network rather than in the cloud, we can deploy in the car itself. So in the driving assistance module itself, we can have a deep such edge device we can use, and we can deploy that deep neural network. So in such a scenario, in such a scenario we are developing how to do that. We'll see that. So this is what the thing, traffic sign training. So traffic sign, this is a symbols like different labels, and these are images. So we can we have initially trained using a convolutional neural network. So then so this is just a process, like we know that, right? What we do in training, in a scenario, we have a cost function. So this cost function we optimize. This cost function we optimize using optimization algorithm like Adam gradient descent, like that. So that's what this image is depicted. So this is what the after training, what we get a parameters like convolutional neural network weights. So all bias, all those parameters will get filter coefficients. So all those parameters we use, and this is what the thing. So once we have an input image, we extract this image and we do pre-processing, certain pre-processing. Then we can do the CNN layer, CNN model, where we can it will, using the CNN layers, it will extract the features by itself and it will perform classification. Then it will infer the result. So here it is showing 60 km/h. This is what the traffic sign inference. So this is what the architecture we have implemented. We have used this architecture, like we have a 32 by 33 image. Like we can have a convolution layer with 28 by 22, like 6 filters, and we have a polling layer. Then we have a convolution layer, and we have a polling layer. Then we have a fully connected layers, and finally we have a softmax classification. This is what the architecture we implemented. So this is what the data set we have used, like German traffic sign detection benchmarking data set. So in this data set has a 51,839 images with 43 classes. So this is what just a pre-processing we did. Rather than giving directly, we perform this color images to grayscale and histogram localization, then normalization. See, these normalized images we have given to a training process. So this is a training. So this is what the training, we have import package, load data, data visualization, pre-processing, design CNN architecture, compile CNN model, fit the CNN model, evaluate. So this one everyone knows. So this is not our main thing. These are the packages we used for training. Just we did in Google Colab. So this is what the data importing. This was the visualization. This is the training samples, testing samples, validation. So this is what the data visualization, pre-processing, So this was the architecture which I'm talking about, which we have created. So using this TensorFlow and Keras. So once we train this model using Adam, then we testing. So now, so this is the training validation to prove our generalization ability of our model. So this is a confusion matrix. So once, so this is what the predicted was true things. So this is what we did in Google Colab. So the outcome of this is the weights and filter coefficients and bias. So this is the outcome of this weights. After training, we get this outcome. Now what we do is, so now we need to implement this. So we perform training. After performing training, we got the output as these weights. We found the weights of the neural network, fully connected network. Then we find the weights of the filter weights and bias. All these coefficients we have found. So after this thing, we need to implement this thing in this model in the Pink Z2 platform. So for that, what we do is, this is what the hardware software code is in. As we told that this is the processing system and this is the FPGA. So in this FPGA, we have implemented the CNN, whatever the CNN is there. The image pre-processing, whatever the pre-processing, we get a capture image. After that, we do pre-processing in the processor. The pre-processed image we send to the FPGA, where in the FPGA we have that CNN running. So this is what the hardware software co-design we did. So this is what the design. So as I told that in a addition scenario, it's a very easy. So first let me demonstrate that code, application code. So these are traffic sign code. So these are the weights. These are the weights. So all these weights we need to store in the form of NPY files. So these are the encoded data. So these are the different. So you can see here convolution bias, convolution 1 layer weights, convolution 2 layer bias, convolution 2 layer weights. These are fully connected layer bias, fully connected layer weights, fully connected to bias, fully connect. So these are the different parameters we need to save as NPY files. So after that, similarly we need to. So this is what the overlay design I shown. So this design we get a bit file as I told. So that bit file we have. So once we do that, so this is what the application code. So you can see here. So this is the difference between software implementation and this implementation is, in software implementation, everything runs in the software. In this implementation, the image pre-processing runs in the software and the convolution neural network runs in the hardware. So how to do that? See here. So the main advantages of Ping framework is we can use the readily available Ping Python packages. So these are the different Python packages already available. We can use them. So this is what the bit file. So this is what actually we are using a LeanET5 based CNN. So that's what I named as LeanET5. So this is one of the popular CNN architecture used for traffic sign classification, which we found in papers. So LeanET5.bit file. So this is what the bit file we get. So we can download that bit file in the FPGA. So after that, so these are the different. So actually, this is one of. So first, let me demonstrate this. Later, I will explain what is this code. So then we need to load the weights. This is the code. Then we need to allocate the memory. So I'll explain this code in the form of slides. So after that, this is the data. So this is actually the validation data. Since this is a trained model, I'm using this test data. So see here. So this is what pre-processing. So this pre-processing. So now see here. So this is what the inference which is happening in the FPGA. So here I'm giving 100 images. You can see here. So it is showing the time. So here we are calculating the time. So finally you can see the speed up. Like 100 images, it is taking only 2.82 seconds. In order to classify this 100 images, it is just taking 2.82 seconds. So since it's implemented in a parallel fashion, so this is what the advantage of this is what we get a high performance, high speed up, low power implementation. Now let me explain about this. So So once we get a once we decide, so first we need to decide which part of the algorithm which we need to accelerate. So then after that, whatever the accelerator which we need which we did, so that part we need to design. So I told how to design using HLS. We need to design. Then we need to have proper interfaces. Here I am using here the main thing is we need to in this design we need to store the weights, we need to store the bias, we need to store the filter coefficients. So that so I'm using some technique called BRAMs. So here I'm using BRAMs for storing the data. So that's what here I'm using. So this IP is performing that computation. So that's what this Zinc. This is a PS system. So this PS system is responsible for controlling all this FPGA hardware. So this is what the IP. So the main issue is, so in order to do such a designs, so one thing is we need to take care what logic we need to implement as a FPGA on FPGA. Generally, we choose a compute intensive tasks, so which requires a parallel execution. Since here the convolution has we can extract massive parallelism from convolution operation. So since the convolution operation is performed on the similar pixels like different parts of the image, it is performing the same operation. Since we can parallelize that, so such parallelized operation we can extract and we can implement on the FPGA IP. So later we need to decide so how this PL-PS needs to communicate. So generally what problem will come is, so in order to establish a communication between PS and PL, so memory, even though FPGA is having a massive parallel structure, so giving data from PS to PL is very tough. So we need to have a proper design, like we need to have a proper interface and proper design in order to do this, and later we can design such a structure. So after that we can write an application. So this is what the Python packages we are using for this. Mainly here we are using this class Xlink class. So this Xlink class, what it will do, it is trying to reserve memory for PL to access. So this is the class which is provided by the Pink framework. So then we need to load. For loading, I already told that overlay object we need to do. We need to use this overlay object. Then we need to load the weights in allocated memory. So this is the weight we need to load in this data. After that, we need to transfer that from PS to PL. So in PL we have this BRAMs. So for that we need to transfer this data. For that we have written this for loops. So after that, so I already told that once we have that memory map address, so we need to give that address. So then using this we can load that data, input data. So these are the weights. So here we are loading that model weights, everything we are loading. Then we need to give that input images. So after giving the input images, image is given from PS to PL. So PL will perform that convolution operations, fully connected operations, everything, and it will give that respective result. So like that, we can achieve high performance, high speed up, as well as low power in such a platforms. So these are the references which I am using in order to demonstrate this. So let me fully tell in 5 minutes what I told. So in this, the main thing is I'm focusing on implementing the machine learning. Many researchers are working on improvising the algorithms. Okay, that's fine. So improvising the ML algorithms and DL algorithms and finding different applications. But so proper implementations also must be there for this machine learning algorithms. So in order to implement this machine learning algorithms, there are various platforms out there. First thing is I focused on the difference between machine learning and deep learning. So whatever it may be, it has two phases: training phase and inference phase. So then I focused on implementing various platforms for implementing the machine learning models. So then we focused on the importance of edge platforms for real-time applications like traffic and classification for self-driving cars. So these are the different heterogeneous platforms available in order to perform implementation. So we focused on all these platforms run with the concept of hardware acceleration. So we have used we have demonstrated one FPGA based implementation of this hardware accelerators. So where we have used this PINC framework. So PINC architecture. The main advantage of using PINC architecture is we can readily use the Python libraries. We can implement this hardware acceleration, FPGA programming also we can do using Python. So that is a main advantage. Also, this PINC community has a lot of overlays. Many overlays are there, which you can readily use for implementing machine learning, image processing, like many applications. So then I have explained this PSPL architecture. Then we have used the tools. So these tools we have used this HLS tool for designing that FPGA part. So in order to design FPGA part, we can also design in Verilog or VHDL. So but that is time-taking process. So many software engineers don't know about Verilog and VHDL knowledge. So what we can do is they can directly use this C++, C, C++ or System C code. One thing is we can describe that logic. The another thing is, the another advantage of this tool is, so we can explore the parallelism. So we can extract the parallelism from the whatever the computation logic we can have. We can extract that parallelism, and by extracting that parallelism, we can also set up proper interfaces for this IP, and also we can convert that to directly to Verilog from C++ to. So all these things will be done this HLS high-level synthesis tool. So once we get that IP, we can use this Vivado to integrate that IP to the PS part, and we can also use different IPs based on the design, based on our design requirements. After that, we can use this VLSI, this tool flow, like we can perform synthesis, implementation, routing, all the stuff, and finally we can generate a bit stream. Once we have a bit stream, we can use this Jupyter Notepad, we can use this Jupyter Notebook to readily code. So the main advantage is, apart from this, whatever the thing, we can readily use the Python libraries. So Python libraries as well as FPGA part. Also, we can write, access that FPGA part also with this Python code. So that is the main thing, so that we can rapidly prototype whatever the idea we have. We can rapidly prototype. So recently, many papers also being published in this area, hardware acceleration. So this is what my lecture. Thank you very much.
Thank you, Shabarinath.
Thank you, sir. If any participants or anyone have any doubts, you can raise. Actually,
to direct, no problem.
Okay, sir.
Hello, sir.
Yes, ma'am.
Thank you for the session was very good. Like, means I have understood the entire flow.
Okay,
And
ma'am.
sir, I just want to ask that for CNN model, how much accuracy you have received on that data set?
Okay, ma'am.
Means you have created a model, na?
Yeah,
So
yeah, yes,
for
ma'am.
that, what was the classification accuracy? Means, is there any like
Yeah.
whenever we deploy it from hardware? So
Yes, ma'am.
there
Yeah,
should
yes,
be
ma'am.
some.
What are you asking? I understood, ma'am, that question.
Yes.
Actually, software accuracy, once we get a software accuracy, so that software accuracy is about good, ma'am, 98% we got. Later, once we deploy that in hardware, we'll get a reduction in accuracy, ma'am.
Okay.
Like that is tolerable, ma'am. So because of this parallelism, some 0.5%, some 0.6% reduction in accuracy, that tolerance will be there. That's a good question, ma'am. Tolerance in accuracy. We need to have that tolerance. Also, ma'am, what we do is generally, I'll tell that some few points I did not tell. So what we do in case of software implementation, we go for floating point, no, ma'am. Yeah, we generally use that floating point implementation. So, but what we have in case of FPGA, if you want to implement in FPGA, we need to convert that floating point data to fixed point data, ma'am.
Okay.
Yeah, floating point to fixed point conversion is there. Also, what we can do is we can have a precision analysis, like how much bits we can use. Exact precision analysis we can do, like 16-bit, 15-bit, 13-bit, like that. We can have exact precision analysis. So in such process, we'll have some accuracy reduction will be there, ma'am.
Okay, sir. Like if the way you did it implemented on FPGA board, and I'm just asking a question. Like, means if we deploy the model on Raspberry Pi, means have you tried it, sir? Have you tried? And like,
actually, Raspberry Pi, it's just like whatever the model we get, that same model we are implementing, ma'am, software model.
Yes.
Yeah.
Have you noticed any difference in the accuracy or execution related?
Yeah, definitely, ma'am. Execution will be very slow.
Yes,
So,
speed.
first of all, the first thing is execution in Raspberry Pi, such platforms. It's a multi-core platform, no, ma'am. It's a multi-core processor in that Raspberry Pi. So implementation, once you deploy that model, implementation is very low, very slow, ma'am. That execution, it will take time. So almost it will take long time for inference. If you give this FPGA, if you parallelize that part, CNN part, if you parallelize that structure and implement that, then that execution time will be more, ma'am. You can speed up that execution.
Okay. Fine. Thank you, sir.
Yes, ma'am. Okay. Any more questions? So, So let me demonstrate a few of the codes. So so let me demonstrate this code. So this is another HLS implementation of FIR filter. So
Yeah, hello participants. Good afternoon. Welcome back to the last session and evening session of this IEEE SPS Student Branch Chapter Initiative on latest trends in machine learning for signal processing application. Now we are continuing with the same speaker, Ramnik Karla, and the session is initiated for best practice of IEEE Student Branch planning and operations. I welcome Mr. Ramnik Karla to take over.
Do we have more people going to join or not?
Yeah.
Only 9. Huh?
No, they're going.
Achha, they are.
Perfect. So good afternoon, everyone joining on the online audience as well as offline. I can see few members are here as well. So let's get started. So let me share my screen. Just a note, if you are having webcam with you, so you can open up and you need a pen and paper as well. So have that as well with you. And let me just go ahead and share the screen. Okay, and there we go. Are you all able to see the presentation, online audience?
Yes.
Can I have yes, no in the chat window? I just want to see if you are active enough on the call or not. Members online on Google Meet, are you able to see the presentation? Can I get a verification, please? Okay, it seems they haven't returned from lunch break or what? Okay, so let's move on. Let's discuss about best practices of IEEE student branch planning and operation. So we will be discussing about IEEE in a general way, and we will be discussing about what are the different event management skills and technical skills along with which you get in IEEE membership. I hope you all are well aware what is the membership fees for student member, that is $27 divided by 2, 50%, and for professional it's around $75 or $85. Now, in today's presentation, I will try to cover my IEEE journey, and I will try to cover what kind of benefits you can also get from being an IEEE member. A little bit about me. I am the current editor of IEEE India Council Vani, that is the India Council newsletter rolled out every month, 2022 to 23 this year. I am an IEEE Impact Creator, that's a position by IEEE Public Visibility Committee from United States headquarters. I'm a mentor of change and Atal Innovation Mission. I hope maximum of you are aware. That's an initiative by Niti Aayog Government of India. I am a board member in IEEE Women Engineering Global Team and Pre-University Education Coordination Committee under EAB. And obviously, I am a stage lover and researcher. Due to the restrictions of having a hybrid version, I am standing on the podium, but it's kind of very difficult for me to stand on one single place when I'm on stage. Okay, so ground rules, you can take screenshots, you can take pics for the offline audience if you want to take for the slides whenever required, and please don't stop asking questions and interact with me because I have a kind of a good habit to sleep on stage if people don't interact with me. So feel free to interact. Okay, so what we're gonna cover today, we will discuss what comes in your mind when you hear IEEE, my IEEE journey and different benefits which I am exploring since my second year, resources for an IEEE student branch like VNR or any other student branch across the globe. What are the different resources? What are the different tools you can use? What are the different phases in conducting an event successfully? And what are the important aspects that a student branch volunteers need to take care? And in the last, we will have an open floor for any questions and answers. A roll call again on the online audience. Do we have everyone on the call? Yes or no? Can I know yes or no if you are available on Google Meet? I guess they can send the message as well, right? Yeah, let everyone send messages. It's okay. Fine, I guess like students will join soon and then maybe they can take care from that slide. Okay, so what comes to your mind when you hear IEEE, other than the options which I have mentioned already on the slide deck? Anyone in the comment box and anyone from the offline audience? What comes in your mind when you hear IEEE? I already listed down many of the options. Conference, research paper, that's the primary thing. First, people join IEEE because they want to download the papers, which is not possible with your standard membership because it's at $45. I believe so. That was the last price which I saw. And scholarship, yes, I guess you are well aware about IEEE provides you scholarship. Volunteering activities, you can do volunteering in IEEE. And misconception that people say, hey, it's very expensive. $27 how I can spend, $85 how can I spend, and what I'm going to get in the ROI, return on investment, right? So that's kind of misconception that we will cover today to understand what actually IEEE can give you. And then people say IEEE is only for tech guys. No, that's not the thing. Non-tech guys can also volunteer a lot in IEEE. Awards, it's only for electrical electronics engineers, which is also another myth. Free trips, I will be talking about it. Today is one of those. I'm coming here from Delhi to Hyderabad. That's also under IEEE. Networking opportunity, to, obviously, we many of the students who are joining us online and who are offline. Offline people will have good chance and I would say good reachability to the guest speakers and to all the volunteers, to all the network, which is in the audience to network together. Then people say IEEE is only for technology advancement. And obviously, everyone is well aware about Wi-Fi and Internet Protocol, IEEE 802.xx series. Website competition, I believe few members are well aware about it, that there's a website competition at Asia and Pacific level, R10, and some of the website competition happens on the MGA level, that is global platform. So, question back to the online audience and offline audience. I guess students are joining now. Okay. Welcome to the new members. So I have a question for all of you. What comes to your mind when you hear IEEE? Other than that, what I have already mentioned in the slide deck. Yeah. Anyone from the offline audience can also participate. Anything. Like first time you heard IEEE. What was the first thing which came to your mind other than what I have already mentioned? Obviously, I have covered maximum of the things, but think about something which actually is not there on the slide. Standards. Yeah, it's already there. It's already there. Anything else? Benchmark. Okay. That's under IPR, right? Patenting and all the stuff what you're talking about. Okay, that's nice. Anything else from online audience as well? Please feel free to interact. What comes to your mind when you hear IEEE for the first time? Sorry? It's already written if you are talking about research paper. We have, I will wait for 1 or 2 minutes more. How many of you are IEEE member? May I know? In the offline audience? How many of you are IEEE member? 1, 2. That's all. And 3 including me. And in the online audience, how many of you are IEEE member? Okay. Suhas says, Suhas, right? Suhas says set of rules and regulation designed for technology. Okay. I guess indirectly it means standards. It's already there. So how many of you are an IEEE member in the online audience? Can I get the yes? Don't raise the hand, just mention in the chat window. If you are an IEEE member, yes. If you are not, no. If you are, obviously you will. Okay, yes. Suhas says yes. Okay. What about others? Come on, guys. I already told you, be interactive with me. It's not a presentation, oral presentation on some technology or something I'm talking about. It's IEEE. It's for all of us to understand what are the different things going on. And I've traveled long way from Delhi to Hyderabad to give you something. So I believe you will take full advantage of it. How many of you are an IEEE member and not? Yes or no? Faculty members, please feel free to join in the interactivity. Only one person is active on Google Meet. Come on, let's see. I hope you are not taking your lunch in parallel to the meeting. Okay, so why I asked that? Because in the upcoming slide, I'm going to talk something about what should be well aware from my IEEE member, and I will be asking if you are well aware about it or not. So let's move on. So this is my IEEE journey. As I mentioned, you can feel free to take pics, screenshots whenever required. So I joined IEEE in my second year undergrad, 2016. There was an announcement from a faculty came up in our second year class, and I was the first computer science student to join my IEEE student branch, HMR ITM New Delhi. Then being a CS student, I got an opportunity to volunteer for maintaining the website for my student branch for 2 years. And then in my final year, I got an opportunity to become the chair of the branch. So when I became the chair, it was my 8th semester and I was only having 4 months in hand. So I want to conduct something, I want to revamp and renovate my student branch. How could I do that? I conducted 2 events per month. So let's say first week I conducted 1 event, and third week not kind of a webinar. Before COVID, there was not kind of a thing which we called as webinar. So that was a kind of a collaborative college events. We were having 4 to 5 colleges collaborated together, and we would used to do events together. Through that, through impactful outcome, IEEE Delhi section, that was my previous section when I was there in undergrad school. They gave me Dr. J.K. Pal Award, and then I became IEEE after graduating and joined Wipro in Bangalore. So I became the part of IEEE Bangalore section from my professional reflection. Now, from an IEEE to an IEEE Impact Creator, there was a, I guess, Feb 2020, 1 month before the lockdown happened, there was a call from IEEE Public Visibility Program. And that guy mentioned, hey, Ramnik, I'm calling from IEEE PVC committee. And I want to know, like, are you interested to become an IEEE Impact Creator? So I was like, that thing I am hearing for the first time. What's that actually? So he mentioned me like all the requests which comes from newspapers, media magazines, and technical newspapers that comes to IEEE, and IEEE routes to all different IEEE Impact Creators across the globe. So you're gonna write blogs, you're gonna write articles, you're gonna give quotations about technology and share prediction about the upcoming technologies in IEEE official platform, global platform. So I was like, okay, let's give it a shot. And then I got selected, and being in the capacity of being an IEEE young professional, I roam around, not roam around, I visit a lot of student branches. Like today I'm visiting in Hyderabad. So I guide them, I advise them what kind of other stuff students and faculty members, student branches can do. So being an IEEE, I kind of advise a lot of student branches to understand what kind of aspects they can explore. And that's what we're going to discuss in the next slide. Then from an IEEE Impact Creator to the youngest board member. So that was kind of an achievement which I recently got in the starting of this year. I got a mail from IEEE Education Activities Board, and they mailed me in such way, hey Ramnik, it seems that our team decide you look fit for the position in Pre-University Education Coordination Committee under EAB, global team. I was like, wow, would you be interested? So that's what they asked. And I was like, is that a question to ask? Obviously, there's a complete yes from me. So I shared this notification to my manager in my current organization and senior manager. They were so happy to hear this. 24 years old age person from India, standing being a youngest board member in the IEEE EAB global team. And then they got to know me. So that was a sense, right? That's what we have to do. And they invited me for a talk. There was a meeting of EAP in a mini series in April first week, 2021. And I was invited there to join offline. I told to my manager and senior, they were like, wow, you are the youngest board member and they are taking care about your visa, funding and all the stuff completely. And I was like, yeah, that's what IEEE actually helps us out to explore the world. And that's where I got an opportunity to become the board member. Along with that, I wrote one, obviously the lockdown happened. We were doing cooking, we were doing dancing, learning some new skills while sitting at home when the lockdown happened in India. I was thinking to write a book. So IEEE USA eBooks is a platform. It's a portal like IEEE India Council we have. So IEEE USA, they have a lot of ebooks and podcasts and everything there. So I read one book of Paul Kostick, one of my good friend now from IEEE global team. So I mailed him right away. Hey Paul, I got interested to learn about your book and quotations and anecdotes you have mentioned. I would like to write my own book. How could I proceed? And he was like, okay. In the reply, he added the editor-in-chief of IEEE USA book. Right away, she shared me the steps to write a book. Within 15 days, I submitted my book of 25 pages. That was the kind of a maximum format. And within 6 months, it got published on IEEE USA portal. And the fun part is, whenever I attend the IEEE USA webinar, when I ask a question, moderator don't say Ramnik is asking this question. They will say one of the authors of IEEE USA is asking this question. So that kind of a proud kind of recognition which you get on the global platform in front of a lot of great professors from different universities in US and different across the different parts of the world. That's the impression which you create. That's the impression you actually come unique out of your crowd. See, at the undergrad school, I know I have also completed my BTech in computer science in 2019. You don't need to stick to your syllabus. Simple fact, full stop. Just explore what's happening outside. See, you will be, how many of on the online call, how many of you will be interested to get an internship and a hackathon right now in your undergrad school? How many of you are interested to opt for internship and a hackathon? Yes or no? In the online audience? And maybe offline we have students sitting, so maybe you can also let me know. Do you think internship and a hackathon is kind of a good stuff? Okay, 1, 2, yes, okay. Professor also says yes, okay.
Eagerly looking for this kind of opportunity.
Okay, okay.
Where we get the funding? Funding is a very important part.
So from my point of view, my professors in my third year pressurized me to do an internship. I simply said a big no. Why so? Because see, there are lakhs of students sitting in the auditorium for a placement which came to your campus. Everyone is running behind internship and hackathon. Everyone has that parameter. What's the X factor in your resume? You're not standing unique from your crowd, right? So what to do? See, that's the factor. In IEEE and other professional societies, you get an opportunity to network with the professor. Now I'm currently doing MBA. Now I will pursue my PhD in the few years next. If I want to do a PhD from a top university in US, who's the first person I'm going to connect? One of the professor from IEEE who is connected to me directly, right? Not to the admission inquiry, fill up that form, and then they will come back for 1 week or somehow. That's the benefit of networking. And that's what I actually say in IEEE, PVN model of IEEE. If you Google this, that's my LinkedIn article will pop up on the top. Participation, volunteering, and networking. These three are the prime benefits of IEEE. So you have to understand, today you are participating in this session, right? I guess there are around 12 members, including me and my laptop. So 12 members and the offline audience. Today you are participating, you get to know me. You're going to network with me. You're going to network with other members who are sitting aside you. Plus, you will get a volunteering opportunity. Let's say today, some flowering decoration happening on the stage, some poster making, some banner making. These kind of things you have to step up to ask your student branch counselor. Hey, ma'am, hey, sir, I'm interested in designing. I know how to build a website as well. Can I volunteer for next event? That's how you're going to create your own opportunity. No one going to come to you, knock, knock. Hey, there's an opportunity. No one going to come to you. No one is aware, okay, there's a Vamsi sitting in that class, there's a some Ramnik is sitting in that class. No one is going to get awareness about it. Professors don't know you. You have to show your own talent in front of them. Then only you will get your resume unit. So it actually gave me wings to the global committees where I got engaged, and I got a lot of mails for 2023 participation now. A lot of committees from global team, they're asking me to become part of their teams. And that's kind of opportunity you have to create your own level, right? The last part, the very interesting and my favorite part, getting a free tip invitations for different IEEE activities across the globe. So there's one activity I'm going to do soon, and I will be moving to Latin America for executing one event in October. How come? All the funding is done by IEEE. All the support is given by them. There's no single penny from my pocket. I just need to take a 1 week leave from my office. That's all. Today I came to Hyderabad. I took a leave, and that's all. I just need to contribute my knowledge, my experience, what I am having, and with all of you on the online and offline audience. So try to understand what's the importance of you being here today and listening me. And these are the glimpses, different kind of talks which I recently finished, some kind of events which I organized. On the top left side, you can see a W, that is Women Engineering, IEEE Women Engineering. And there's a pre-university student event activity which I have been doing from April 2021. And IEEE Women Engineering Project-Based Learning School Camp. So what we do, we actually call for registration from 8th class to 12th class students all across the globe. And we are being supported by a global team of V. So what we do, we actually have a 1 week program, and we tell them that this is what we're going to learn about project-based learning. We will divide them randomly into teams, and we will give them problem statement. They can work on it with a proper mentor support. This is a kind of a 1 week program. And that's what we recently finished, the 3rd edition at Manavraj University, Faridabad, Haryana. On the top right, that's kind of a full house, full auditorium, I would say, because students were standing in the behind as well. There was around 800 plus students in Marwadi University, Rajkot. I got an opportunity to visit there 8th October 2021 last year. And you can't even imagine, they were like first year students who just recently joined university within their 1 week. And in that audience, I was able to find 40 plus country diverse students sitting in the audience. That's one of the biggest, I would say, crowd I have faced. And that was really great and enthusiastic audience, which I actually explored. And that was also for free. So on the top, bottom left, IEEE TV. So IEEE TV is a YouTube for IEEE members. So you can explore all the lectures. Today, this SPS summer school is happening. All the recordings can also be uploaded there. So we'll be discussing about that too. So IEEE TV invited me to give a live streaming, global live streaming on 28 September 2021. And on my book, Idea to Product, a research pathway for students, where I shared my all research paper writing story and all the stuff. When I was sitting for my Wipro interview in final year, 7th semester, January 2019, and the HR interviewer was like, how come you have written 19 research paper till your 7th semester? They were shocked enough about that fact. I was like, I learn something, I implement a project, and I write a paper and I publish it. Simple fact. These kind of things are actually missing in maximum of the undergrad schools all across the globe. Why are we not understanding that internship and hackathon is just a waste of money because you are traveling to a company to visit them? Waste of time and brain because obviously you are getting industry experience, that's a different thing. But you are working on someone else's idea. You're not working on your own idea. And they actually do a NDA, non-disclosure agreement, before joining internship. You can't share whatever you're doing inside the company. What's the benefit of it, right? So that's why I encourage students to come on IPR, intellectual property rights, and all of the stuff, patenting and research paper writing. Bottom right, IEEE Quarter Tech Talk Table series, which we do every quarter under India Council, and we do a panel discussion on emerging technology. This is what we are going to host in Chile, Latin America, where I'm going in October. So moving ahead, let's play a game. So I invite online audience let me unshare my screen. Okay, so I invite online audience to have a pen and paper with you. Offline audience, if you have, please feel free to. Pen and paper, please. You can take from here, rough papers are here, yeah. Or if you have, please. It's an interesting game. I believe like you won't regret it. So join me. Online audience, let me know once you are done with your pen and paper. Come on. Are we ready with pen and paper from online audience? Yes or no in the chat window, please. Extra pen, yeah. Yeah. Can I know, like online audience is kind of cold today, why so? You haven't done completed your lunch so far, huh? Come on, please. Yeah, thank you, sir. Please join. Yeah, please have pen and paper with you. Sir, pen and paper. Pen and paper as well, yeah. One paper, it's enough. We just need 10 rows, that's all. Okay, are we good? Shall we begin? The first instruction. Write down the names of 10 friends across galaxy of us. Aliens, you can write their names if you know them. So 10 friends whom you frequently talk. Okay, it can be anyone. No restriction, no country restriction, and no restriction basically. It's like who you talk frequently. I was doing this in Marward University, and there was one girl stood up in the starting. Sir, do you mean best friend or friend? I'm like, no, I don't have a differentiation between best friend and friend. It's just 10 friends' names whom you talk frequently. Online audience, if you're back, please let me know because I can't see you.
No.
Okay, are we done? Okay, we'll take one more minute, and please don't fight with each other or don't WhatsApp your friends. Hey, I'm gonna write your name. You gonna write or not? So don't fight with each other. Let's write 10 friends' names, and that's all. Hold on. That's kind of a lot of brainstorming today. Swas, you were there. Are you available now? Okay, are we done? Offline? All done? Okay, let's wait. One or two members are still wondering who is my friend or not. Okay. Done? Four members are left. Okay, yes, no? Done? Okay. Done? Okay. So the second instruction, there's a kind of thing, if you want to laugh, you can, okay? The second instruction, strike through the names who belong to the same gender as yours. Strike through the names of the friends who belong to the same gender as yours. If you're female, remove female friends. If you're male, remove male friends. We have new audience. Please, do we have students, right? Come forward. Those are students, right? No? Oh, we have members sitting there, but they are sitting on the behind. Guys, please come forward. I am not alien. I am human. So don't be afraid about it. Come on, come in the front row. It's kind of okay. You guys have your pen and paper ready, right? Yeah, settle down. Taking the benefit of the dark, right? Sitting in the behind so that no one can watch you. Nice. Sir, right. Only one person I can see pen and paper. What about others? You have written 10 friends' name? Sorry? What about those two guys? Writing up? Okay, we will wait for you then. For others who have strike through the names, who belong to same gender. Okay. Don't tell me the score, I will ask you. Who's gonna win it? We will take a proper pick. I will ask to take a proper pick of that winner with a proper pause. Yeah, let's wait for these students to come with their names. Not best friends, only friends, guys. Only friends, not best friends. Fighting, huh? You're writing each other's names.
Okay. Oh, it's fine. More HD voice. Okay, 7. You are still wondering who is my friend or not. Okay. Done? Strike through? Okay. Come on. Complete though, na? 2, 3 members are left. Complete them. You don't have, like, maybe not friends, maybe people whom you talk frequently. What about you? Done? Strike through the names who belong to same gender.
Okay, third instruction. Again, if you want to laugh, you can. Strike through the names who belong to your own country. Strike through the names of the friends who belong to your own country. We all are from India, right? Sitting here in the offline. Remove the friends who belong to India, basically. Done? Everyone? Done there? Okay. The next instruction, yeah, I guess that's good enough now. So the number of the friends which are left unstriked, multiply that number by 20 and tell us the score. That's all. 0. Okay, how many of you get 0? Everyone. Non-zero? Non-zero we have. Okay, please stand up. Let's give them a separate respect. The people who have non-zero score, or everyone is having 0. As 0, huh? All 0. Okay, so this score which you calibrated just now, right? This score is actually called as diversity constant. We all have heard about IQ, DQ, IQ, EQ. This is DQ. So due to lockdown, let me share my screen back. So due to lockdown, due to pandemic all across the planet, this thing we learned in industry, diversity constant. So the game we just played is the score of your, that is actually your DQ. So why we played this? Because diversity is your reality. In which year you guys are? First year. First year, which stream? You had your lunch, right? Speak loud, no? Arey, which stream? Electronics. Okay, perfect. So the thing is, I was talking about in industry now after pandemic or during the pandemic as well. It was people are looking for diverse audience. Just switch it off. People are looking for diverse candidates. In how many countries you have your connection? Let's take an example. You want to sell your own company product in Australia. If you have a perfect connection in Australia, who is the first person your company CEO will refer? You, right? Simple fact. So DQ is actually your reality. And that's what IEEE gives you. IEEE is all across 160 plus countries, and all the planet we have 190 plus countries. That's all. 30 countries are just left. We are working on it to cover them as well. So that's the aspect that we have to take care. And IEEE gives you that platform properly to network with diverse audience, right? Don't be kind of afraid about this slide now. So these are kind of 5% of resources which you actually get from IEEE for an IEEE student branch. Now let's talk about IEEE student branch. Are you guys IEEE member? No? Okay. Do you know about IEEE? What is IEEE? Mike, you have the mic in your hand.
It's another observation.
Sorry?
It's a student chapter.
Okay. I mentioned, like, what do you mean by IEEE? Those guys are waiting. Yeah. Anything? Array, it's fine. I'm not giving marks to your semester.
As you just said, it gives connections.
Okay. Nice copycat. What next? Some students were sitting. You are students, right? Guys, from there back. You are students, right? Please come forward. You are student? Professor? Student, come forward. We're going to take a selfie here. How it will show like empty chairs are sitting there. So you guys are IEEE members? Yes, sir. Okay. What about those two guys? No? First year? Okay. So basically, let me go back and make you understand about this. Okay. This is good enough. Okay, so let's take a look on the planet right now. Okay, so our world, our planet is actually divided in 10 regions. Region 1 to region 10 under IEEE. Okay, and we belong to region 10, Asia and Pacific region. Now, if you zoom in a little bit on region, you get countries, right? In IEEE, countries are called as councils, depending upon the number of total IEEE members they have. Like IEEE India Council, IEEE Japan Council, and different kind of councils. Okay. Now, if you zoom in a little bit on countries, what do you get? States. And depending upon the number of the members they have in a state, they are called as section or subsection. Okay. Let's say IEEE Delhi section, IEEE Hyderabad section. Now, Hyderabad is not a state; it's a city, but we have large number of members. That's why we are a section, right? Similarly, it depends upon. Now we will zoom in a little bit more. Now you will zoom on state. What you will get? Colleges. Those colleges are called as IEEE student branches. Okay, got it? Don't make notes. I will share you the slide tag as well. Okay, so moving back. Okay, so what I was talking about, student branch, right? IEEE VNR college is a student branch. Now, in those we have volunteers, we have faculty members, we have advisors, and all other stuff going on. What are the different resources that IEEE can provide you to become more active, to become more aware, right? Let me go by one, okay? IEEE members, who are those? You are, okay? Rama, okay? Padma, okay? Okay. Now we will go one by one, okay? I will keep the eye on online audience as well. So the first one is IEEE brand experience. How many of you are aware about it? 1, 2, only 2. Okay. Moving on to the next. I will tell you, IEEE brand experience is a portal where you can actually get the guidelines how to make your IEEE student branch logo. how to make your IEEE student branch website. What are the different headers? What are the different logos? What kind of font you have to use in the posters of the event? Yeah. What kind of fonts you're gonna use in your event, in your poster, right? What kind of PPT templates you want to use? IEEE official one. That's all there on IEEE brand experience. Okay, so you can take a peek, whatever if required, if you want to explore it afterwards. Second one, I already talked about it, IEEE.tv. So that's a portal where you can upload your events recording. That is happening today as well. So you can upload all the SPS summer school recordings onto IEEE TV, so that everyone across the globe, 4,400,000 plus members across the globe, they can access your summer school, what happened in August, right? And you can explore different lectures going on across the globe in IEEE, different sections and different regions. IEEE MC, anyone who is aware? IEEE MCE. Okay. What's your name? What's your good name? Huh? Srijan. Okay. So you are aware about IEEE MC? Okay. What about other site? Remember? MC? MC, you know? Okay. So IEEE MC is a committee in global team, that is meetings, conferences, and events. Whatever event you want to organize, whatever conferences you want to organize under your student branch, they're going to help you out with the guidelines and the procedures to apply for sponsorship, apply for a proper Explore library attachment, right? All those kind of guidelines. Even if you are organizing like today, let's take an example. This event is happening during COVID-19 time, during lockdown time. What are the different strict guidelines you have to follow from IEEE? MCE can help you out. MCE can help you out to even find a location for you to host outside India or within India. They can help you out with every single thing in event management. Okay. Next, IEEE Day. Aware or not? Yes or no? Yes. Okay. No. When IEEE Day gonna celebrate it in 2022? Do you know the date? August 6th. October 6th. Okay. Any other choices? It's 4th October, ma'am. 4th October 2022. We're going to celebrate IEEE Day. But kind of an enthusiasm and excitement comes from the global team. So we celebrate IEEE Day activities in all October month. Okay. And what IEEE Day can provide you, that team, global team, they can help you out with goodies like online goodies, digital formatting, and all the stuff. You can post your event on their IEEE Day portal so that global members can join you virtually, right? IEEE Center for Leadership Excellence. Srijan, you are an officer, you are a position somewhere in VNR?
No, sir. Actually, I just joined.
When?
In January itself.
January itself, okay. So IEEE CLE portal, anyone? Okay, one person. Okay, 2%. So when you become an officer in your student branch, section, region, or somewhere, IEEE CLE is the first portal that you should explore. Why so? Because you get the responsibilities and roles and responsibility of your position in a kind of a training format on that portal. Okay, so that's one of the good portal you can explore being in IEEE student branch. IEEE volunteering. Okay, 1, 2, 3. Okay, so IEEE volunteering is a global platform, volunteer.ieee.org, where you can get volunteering opportunity from global teams. Let's say there's one conference happening, Rising Stars Conference, Rising Star Conference happening in US. One of my good friend from Meta, she's working there for this conference. So they need designers, they need website coordinators. They're gonna post on IEEE volunteering. You're gonna apply it directly. Simple fact. And no one can say if you get a free trip to US after being a volunteer there, right? So these are the kind of opportunity that you should explore on your own. No professor will come to your door, hey, knock, knock, there's an opportunity in US, you want to visit or not? No, no one gonna come, right? You have to become selfish to yourself. You have to create opportunity for yourself, right? IEEE V2s, 1, 2, 3, 4, okay. Okay, So IEEE Tools is a portal where volunteers actually report their events. That is what we called earlier as L31 reporting. Then we have website. You can put your website address there. You can send out e-notice across your college members, across your section members upon requesting them. You can have survey forms. You can have WebEx request from there. You can have a website hosting request for your student branch. All those stuff, volunteer tools are available on IEEE Tools. That's a global team under MGA, Member Geographic Area Committee. Okay. IEEE web hosting, that's what I talked about. I didn't go through the VNR IEEE website so far. So if there's one, edu.ieee.org/the college allies is the official domain name that every student branch across the globe should have. Okay. And it's on the WordPress. If you know WordPress, you have the counselor sitting aside you. So you can contact her and you can ask her, ma'am, I am interested in WordPress development. So can you please help me out how to volunteer? Right? Being a volunteer, being an IEEE member. IEEE students portal. Anyone? No one? Students.ieee.org. There's domain. On that domain, you can explore all the opportunity being an undergrad student, postgrad student, research scholar. You will get the opportunities, you will get the benefits listed out there. You will get connection to different things, funding, scholarships, everything. Okay. Let me revert back to that slide. This slide. So what comes to your mind when you hear IEEE? So these are the plenty of things, misconception and myths, what people think. And some of the kind of thing which they think that IEEE, acha, okay, we will have conference and all those stuff IEEE do, and standards that all we do. But there are other things as well what IEEE provides you, right? Yeah. Talking about IEEE Extreme. Okay, one person. IEEE Extreme is a 24 hours programming contest conducted by a global team. You become a pilot. Let's say VNR is kind of one of the pilot where they are going to host this 24-hour extreme programming, and they will, like when this will happen in October, right? And you can just take a lab, and you can make it. Non-IEEE members can also not join. No, they can't join. Yeah, only IEEE, right? They have to join IEEE membership, and then they will be. It's kind of a competitive program contest, 24 hours, globally among all the IEEE members. It gives you more courage to solve those issues, right? You get more brainstorming on Google, Microsoft, and different kind of problem statement what they said. IEEE Foundation. Anyone? So IEEE Foundation, as you know, IEEE is a non-profit organization, and it's the world's largest technical professional society, professional organization, sorry. So IEEE Foundation is the centralized hub where we actually give the funds, membership, and all those things roll out there. And through that only fundings, grants, scholarships, and all the stuff actually come back to the members. That's where your whole benefit of being a $27 of membership, which is actually now $13.50 due to lockdown, due to COVID. And these are the things are already there on the table, but people don't know about it, right? So you should explore these things on your free time, because that was my favorite habit when I joined IEEE in my second year. I want to explore everything about it. Every day I used to consume 20 minutes, 30 minutes on IEEE.org just to see what's coming up, what's not. And you don't know, within 3 years, I was featured on the main page of the IEEE for my book and for my webinars and all the stuff. See, that's kind of chances you have to get for yourself. Virtual speakers. It's a virtual speakers bureau that IEEE student branches can use. You can request a speaker globally from anywhere on a specific topic. They will map, IEEE VSB team will connect you with that speaker, and they will help you out to connect with the branch, and then you can host it on Google Meet, WebEx, offline, or whatever you think. So that's a good resource to find speakers, professional speakers from globe. IEEE Humanitarian Activity Committee. So IEEE Humanitarian Activities. Now you will be thinking, Are Baba, theek hai, chalo, I have taken $13.50 membership. What to do now for society? Even if nearby village, right, you have a group of students, government student, government school students, who doesn't have that capability to have tablets, systems, and all the stuff. They don't know about computer science. You can actually request for funding from IEEE under Humanitarian Activity Committee. They can give you funds for buying those material, guide them, teach them for a particular project. Obviously, you have to report back to them what you are doing with their money, right? Because IEEE on the baseline, right? The base objective and the mission is benefit of the society, benefit using of technology for the benefit of humanity, and that's what we work for. Whether it is government school, whether anything. I have been a reviewer in IEEE Smart Village. That's also kind of under funding opportunity for making villages smart. If you want to get projects and you want to submit some proposal for funding, and I reviewed one project. There was one project from South Africa, if I am not wrong. It's listed on their website as well, on IEEE Hack as well. You will see that they are doing some solar panel roof topping in the villages for free. And where the fund comes? From IEEE. So those are the unique projects which will highlight in your resume, right? When you are in final year. And company will say, oh, wow, that's great. You have got that industrial experience. You have got that real world experience on that aspect, right? So this is where IEEE actually helps you out a lot. IEEE potentials? Anyone? IEEE potentials? So if you're an undergrad student and you have an article, technical article you want to publish, or non-technical article, go ahead, publish it for free. IEEE Potential is actually undergrad magazine, which comes, I guess, quarterly, if I am not wrong. So there you can publish your own article, being an IEEE member. And it will be shooted out to all the 400,000 plus members across the globe. Just imagine a professor sitting in Harvard University. He's well known to you now because from your article, and he somehow approaches you from your email. Kind of a good impression, right? You are making a good, diverse, you are making your DQ score high. IEEE Learning Network? Anyone? So IEEE Learning Network, iln.ieee.org. That's a platform you have, you are aware about Udemy, Udacity, and all the stuff, right? In IEEE, being an IEEE member, want to get a legit IEEE certificate from universities or companies for certification or for technology, IEEE ILN is your platform. We have certified courses, we have certified trainings, we have certified boot camps, which you can take part of after becoming a member. Okay. IEEE USA, I already told about. We have ebooks, we have podcasts, which you can read, which you can learn from, right? You will get to know about industry experience, you will get to know about different aspects where you can use your knowledge and where you can use reflection. And that's how I got connected for writing my own book. I was reading someone else and I just mailed him and he just guided me. That's how you create your own opportunity. The last but not the least, IEEE Tri-Engineering. That's where I am a board member in the Pre-University Education Coordination Committee, US. What do? We actually educate school students from 8th to 12th, even if it can be 6th to 12th as well. And we connect with them, we organize events on that, and simple. You list down your program there. Someone from other part of the world can get motivated from your program in VNR, and they can execute in their section or in their region. They can contact you, right? This is what IEEE resources are for an IEEE student branch. I hope it will surely help a lot of student branches who are online, as well as for VNR as well. Moving ahead, different phases of conducting an event. So this is a LinkedIn article which I wrote in my profile. I will share my LinkedIn handle as well in the last. Let's go one by one, okay? I have hand mic.
Yeah, it's better. Okay. Can you close this? My voice will be audible, right? Okay. Oh, is that good? Oh, it was very heavy. Okay, no worries. So different phases in conducting an event. So let's go by first one. Define your objective, missions, or event. So I have divided in two parts. That is pre-event and post-event. During the event, obviously, we are executing the event, so we don't have such things we have to follow. So the first step is define your objective, missions, and proper vision. What do you want from that event? What you are targeting? What are the different problem statements you are focusing on? That SPS summer school we are organizing this time, right? What we are focusing on? Putting signal processing related technology in front of kind of a summer school, right? Kind of a 2 to 3 days event. That's what our objective is. And we want to share the knowledge back. What's the second part? Design, team, and divide responsibility. That's very much important. Now, let's take an example. Vamsi knows about website development. I know about designing. And I am becoming a volunteer in that event. What I will ask, okay, ma'am, I am interested in website designing. I am interested in designing team. And let's divide the team. Being a leader, being an organizing chair of an event, divide your team, divide your volunteers in a proper team. Designing committee, publicity committee, different aspects what we have during the event execution, and being a part of it, right? This is kind of a part we should learn. The third part, document everything into a shareable space. That's very much important during COVID lockdown time. Not even lockdown, after lockdown as well. This is very much important because you keep your track, everything. If I want to make a poster for an event, do you have a to-do list? For this particular deadline, you have to make this poster. I want to execute event on 10th August. I want a poster before 1 week. Do we have that deadline or not? Make a drive folder, make a OneDrive folder or something, whatever seems simple to you as an organizing chair. Put it together. Now, if someone asks you after the event, what are the different responsibilities this person actually took? You have all record from the starting. No one gonna question you, right? The next point is brainstorm together on every decision of event. Every member is equal to honor. This is kind of a limitation which I have seen from different student branches across the globe. Being an organizing chair will think, Are Baba, I am the owner, I am the lead, I will do everything. No. Brainstorming and discussing things with each other actually brings new innovative solution. Maybe it happened to hybrid event on all the stuff that we are doing today. Setting up this camera, setting up this laptop. We had a discussion with faculty member who was sitting here to help us out, right? Organizing chair would have talked with him. Not every time organizing chair will do a photocopy of him or her and she will be roaming around everywhere, right? So we should have a proper team coordination. We should have a proper discussion from everyone. If you are going to take a decision, ask with everyone on a team meeting, right? Okay, I am thinking that this poster will look like this way. Ask the team. One brain is kind of less enough efficient if you have multiple brains, right? Multiple brains will help you out to know more innovative solution. Next point, evaluate and survey for quality development. So this is very much important. Once you do everything, right? Once you have all the plan ready, do a survey, before survey, with the participants. So once you have the registration, right? Registration is open for SPS Summer School. Let's take an example. Now you will make a survey form, pre-event feedback form. What kind of topics our audience is actually interested to know more? Make a survey form, shoot it out. Now, if IEEE VNR has thought about SPS Summer School, they would have got any feedback from the student, right? They need signal processing related technology awareness. That's why they conducted this. There was no sense, and any kind of empty hole. She came up and she was like, okay, chalo, let's do this. Arey Baba, it's not the way, right? You have to understand what your audience wants. And that happens before the event. Analyze and beta survey within network for better suggestion. So once you have the survey results from the audience, from your student branch participants or student branch members, analyze it inside or your core team. Do you think like we have 5 topics suggested and we got such kind of voting? Do you think it's more efficient? So in that way, you should internally discuss as an organizing team. Reevaluate and modify and applicable, if applicable. So basically, like if you want to think that okay, this topic doesn't sound good. Let's say SPS Summer School, we were thinking, and the student members are saying, let's do something on stock and trading. Doesn't relate anything, right? So you have to reevaluate and modify the audience aspects as well. Point of view, you have to think about it. reanalyze and roll out for final execution. So once everything is done, poster ready, brochure ready, the team is ready, execution is ready, how to do, social media handles are ready, speakers are confirmed, roll out, simple. Ask them to become, let's execute the event, and execute and spread the word. Once you execute the event, do the publicity as much as possible. Now in Hyderabad, many of the members from Hyderabad section would be aware about that SPS Summer School is happening. What are the different channels of communication you can use so that SPS Summer School will be reflected to global team or global leaders? They should be well aware, right? This is happening in Hyderabad. Then what's the benefit of doing it? And not even leaders, all the participants outside Hyderabad should know about it so that they can join virtually, right? Coming to the post-planning, recognize every contributor without fail. That's very much important that I have learned recently. Each and every volunteer, even if they are setting up the flowers on the stage, even if they are setting the camera for hybrid version, every single volunteer counts. Because volunteers are not being paid because they are worthless, because they are priceless. So you have to actually acknowledge every single contribution from every single volunteer, right? If sir was not there for setting up the camera and my laptop, this session would not have happened, right? So every single contribution counts, right? The second one is work on designing event report. That's very much important. Even if you get a funding opportunity from any society of IEEE or any committee from global team or within section or within student branch, wherever, you should document everything what's happening in your event. And that should happen right away after the event is finished. Within 1 week, just bring a document, your own formatted one. This was the first day, these were the picks, these were the introduction, these were the speakers, these were the number of audience who came. Kind of a document everything. That's all. Submit it to all the, capture each moment into report, we summarize view, put impacted facts and figures into report, submit the final copy to each collaborator and publish in newsletter and portal wherever applicable. Again, it's a post-event publicity. Once the event is executed in August, next year we will do it again, right? You want new partners, new sponsors for the event, right? So how it's going to happen? You're going to publicize in a newsletter, right? That's how it happens. Create event family group for having participant interest for next edition. This is what I actually follow since my final year. Not final year, I guess, when I started doing activities in my third or second year result. What we do, now, this event is going to finish today. What about next day? All the participants are moving back to their home, they are exiting the WhatsApp group, whatever is being created. No, ask them to be there. Network with the people, network with the speakers, so that they can learn from them along the process of next August 2023, right? The last is repeat for next edition and don't forget, contribute without thinking of getting back. That's very much important. In my student branch, there was a student I was saying, hey, we are conducting this event. Would you like to make a poster? And you were like, how many bucks you gonna give me? I was like, hey bro, IEEE is a non-profit organization and I don't want to give funds to my own volunteers. So where I'm gonna use it for different purposes, right? So that aspect you have to keep in your mind. Volunteering is basically a seva bhav. You are doing something good for your society. You are not thinking of getting back at all. Okay? Next. Done. Okay, that's the last. Yeah. With that, thank you very much for listening me and for inviting me out from Haryana to Hyderabad. That was really nice experience for being flying here. Second time I came for my office work few months back, and great to see many familiar faces which were on video when we had meetings during lockdowns, and meeting them in person. It's kind of an exceptional vibes and exceptional experience. With that, you can connect me on LinkedIn, you can connect me on Instagram, and that's my email ID. You can take a screenshot, you can Google me. You Google my full name, you will get LinkedIn on the top. And floor is open for any questions and answers. Online audience, I really don't see anyone active here. Feel free to come up.
if you have any questions.
Rotate the camera. It's fine, yeah. Let it be on the center. You will give the mic to the audience.
Good afternoon, sir. Sir, actually you told that you pursued CSC and now you actually wrote a book on edge computing, right, sir?
Yeah, sorry, I didn't catch. Can you come again?
You actually told that you pursued CSC in BTech and you actually wrote a book on edge computing, right, sir?
No, not on edge computing. That was idea to risk, idea to product.
Oh, okay, sir. So, what's your job based on, sir? Yeah.
Occupation. My occupation?
Yeah.
You can check my LinkedIn. What's your question basically?
It's like, how do you manage both things?
That's a kind of a popular question which I always get. How do I manage my work and volunteering together and my personal life as well? See, the main thing is, I believe in this aspect. People say that you have to align your priorities, right? I don't think so. Team management is just a mere word, nothing more than that. You have to manage your energy. See, I took 3 days off from my office now. They know that I'm volunteering for IEEE and I'm doing all this stuff for society. But why they have granted me the leave? Because they believe in me. They believe, okay, he is impacting some lives, right? So the thing is, you just try to understand what is important for you. If you have that clear, see, once you enter into industry, you will find those people who are just roaming around that company, roaming around a single profile. Someone will pick them and put into another project of unknown profile. So they don't have control on their own life, right? Their managers are their control, right? So that's the thing. Be very much clear. What do you want in your career? What do you want in your professional life? What do you want in your personal life? Then you will be very clear about it, how to manage it. Till 5 o'clock, my office gets off. At exact 5 o'clock, I shut down my laptop and I work on volunteering and all of that stuff. So that's how I guess it may answer you.
So it's like you won't compromise on what you're doing.
I see, that's a different thing, right? Compromising is a different word. It's not like forcing myself to come here, doing all these activities. I love it. Do what you love, right? That's all. Simple fact. You don't need to complex a lot of things because a lot of seniors say, "You are Baba, do this internship, do this hackathon. Government people are coming up." Don't think about them. Think about your own resume. I will show my resume as well. If it is not recording, we will stop the recording and then we will show my resume. So you will understand what kind of aspects you have to take care while you are writing your resume. The thing is, you should not speak about yourself in the interview. Your resume should speak. In my technical interview, only one question was asked: what is the difference between bubble shot and insertion shot? That was done. Nothing more than that. Everyone was on my IEEE. Technical interviews were highlighting, underlying my resume, hard copy. What is this IEEE? What is this brand ambassador? What is this? Because Indian companies are not much aware about this. Being a unique personality, you have to show them, okay, this is what I am doing. This is what actually is important. This is how I am approaching to 160 plus countries. That's how, I guess, that's how I manage here. Okay, any other questions? I would really encourage if any faculty member would have any question, because I guess faculty members are the ones who actually get involved in organizing events and all of this stuff. Yeah. Yes, ma'am.
Hello, Ravi.
Yeah.
I know you that summer school camp because my son is joined that.
Oh, the PPL camp? Oh, that's great.
So I'm asking you that summer school camp only that time duration or school can join that IEEE after 11th or after 10th. Continuously, IEEE member for the school students is there or only this for the college?
That's one of the biggest challenges that IEEE Global Team is working on, and we had a project in IEEE Volunteer Leadership Training who actually got the first prize last year. Padma was the part of that Vault team last year. So having IEEE membership for pre-university students is kind of a question to the parents. They're already consuming a lot of fees to their schools, and they are struggling to get the phones out of their pockets, right? So we have to understand what kind of expenses we're going to take care. It's a non-profit organization. That's why we have a free pre-university activities under IEEE Tri-Engineering and IEEE Women Engineering Star Initiative. So that's why I think like membership is not for school students. I'm working strongly on this aspect, but think like it will be very expensive for Indian students specifically, because country to country the currency change, and we are dealing with USD. So that's how the things may go. Thank you very much. Okay, online audience.
Ramnik, at present we are organizing conference with the support from financial support from
only from our college.
Okay.
How can we get the grants from global societies to organize at this stage? Already we are in the phase of calling almost end of the submission of the paper. So, is there any chance supported by the global societies?
So I strongly I have been a part of a lot of conferences which are actually directly sponsored by communication societies and computer society. So the first thing is approach MCE team. Ask MCE team, hey, we are looking for funding from IEEE societies, and these are our call for papers and the themes we are focusing on. They will guide you accordingly where to approach to that particular society. We have 39 technical societies. We can approach to anyone, directly meaning the committee members, to ask them what is the procedure, what are the guidelines. I don't think so there's a barrier, but right now it's August going on. Financial kind of distribution, all those things are being done by everyone. It's better we can start early, around November, December, for the next edition. That will really help us out in that aspect. Yeah.
And about DL, organizing DL programs.
Distinguished lectures?
Yeah.
Okay, yeah, that's a very important aspect where I became the part, IEEE Computer Society Distinguished Visitor Program. So I have been the committee member. I have been the chair of History and Research Subcommittee. That's under DVP. So what we do there, you have a website there. You have to go there. You have to just search out the theme. You have to search the people. You have to just mail Computer Society. Hey, we are interested to execute this DVP, this distinguished visitor, DV professor in our university. They will take care of all the expenses. You have to just ask Computer Society that this is the person we are interested to invite, and they will help you out. That's very simple rule, ma'am. You just visit website, you approach Computer Society, and they will help you out. And this happens, I guess, in Power Energy Society as well. They also have a DL program, and other societies as well. Yeah, they do have their own. Just approach society. That's what, I have been my habit being from childhood, 8th, 6th class. My principal used to say, Ramnik, whenever you have a doubt, ask question. Because if you don't ask question, you close the door for that question. You don't get answer for it. And my science teacher in my 10th class, I was not able to understand some concept which she was teaching. And she asked me, if you don't ask question, you will be idiot for your whole life. If you ask question, you will be idiot for that minute, because people will laugh if it is not relatable. But you will get the answer to it. So that's what I actually believe in. That's why I mailed Paul Kostick for ebook publication. That's why I mailed to other committee members to understand what are the procedure. Because being in India, being in a kind of a network where we are only limited to our student branch activities or section activities or region 10 activities, we should actually come out that comfort zone. Try to explore new people. They are sitting. I explored IEEE Spectrum, like Potentials. IEEE Spectrum is a monthly magazine which comes out to all the members. And I was thinking I'm going to step out from these two events, PBL camp, project-based learning school camp, which I have been doing, and Pada Tech Talk. So I was thinking, let's get it stopped because it's more edition now I have done. I'm fully satisfied with those things and outcomes are already done. Let's move on to the distributed model. Then I was guided by a mentor from IEEE Within, one of my professors from Tamil Nadu. She guided me, Ramni, whenever you are doing something, right? Again, document somewhere. I wrote an article. I wrote a proper, I would say, kind of a summary what I did in my IEEE for the last lockdown period, and I sent it to IEEE Spectrum team, editor-in-chief of Spectrum. She mailed me back, Ramnik, it doesn't seem that we can publish your article directly. It would be better if I can interview you. And I was like, Global Magazine, IEEE Spectrum monthly published, they're going to interview me. What's going to be better than that? Within 1 week, we got a place on a Google Meet and we got interviewed. And that the lady, editor-in-chief Kathy, she actually interviewed Chandrasekhar, who is the new chairman of Air India, if I'm not wrong, from Tata Group. After that, after him, I was the one. He is also IEEE member. See, Steve Woj, every great ISRO chairman, right? Everyone is kind of an IEEE fellow and IEEE senior member. Why are not we connecting with them? We talk a lot about things like let's connect to ISRO, let's connect to DRDO, Are Baba, where to find the connection? IEEE is the platform. IEEE fellows are there, right? Connect with them, ask questions. That's all, right? So I mailed her, and within 1 week, she was like, okay, let's set up a Google Meet. We went through, she wrote a proper draft of it. We finalized it together. Within 1 month, it was published on Google News. My friends were used to chat with me, like sending message me on the WhatsApp. Hey, Ramnik, you are on Google. And I'm like, yeah, that IEEE Spectrum is a global magazine. So I will be on Google because it's a global magazine and people will be getting recognized about it. So that's the image you have to build for yourself. No one gonna stop after it. No one gonna stop you after that, right? You have to create your own platform. Then only you will be able to understand what's actually gonna happen in your 4 years of undergrad school. You are wasting your time if you are only tied up with assignment syllabus. I'm not saying it's wrong. It's the part of the curriculum. But after that, what you are doing, that's what companies are looking for. And people don't understand that. Students don't understand. That's not limited to India. All across the globe, people don't understand that. Why 10, 12 students are getting internship in Google in US? Because we are not so much innovative and approachable to those companies during our early age. Since from 6th class, the parents are tied up, JEE mains exams, we have to prepare, NEET exams and all those things. Why is it so? We have to change our point of view, right? Digital India is coming up, new government is helping us out a lot in new education policy. Try to connect the dots. Try to say where you can get the help from, right? I guess today, yesterday, there's one Region 10 SYWLC, if I'm pronouncing it right. And there's a congress going on of Asian Pacific IEEE Region 10 we talked about in South Korea, Jeju Island. It's going on today as well. Yesterday it got inaugurated. Today, tomorrow, I guess for 3 to 4 days it is going to happen. Members from different sections all across Region 10 have been there in that, going there, funded by sections, funded by all IEEE OUs. Why so? Because they want to network with great leaders all across Region 10, right? So that's the chances that we should give to our undergrad student. That's the chances that students should create for themselves, right? That's all. Thank you, ma'am. Anyone else? So, ma'am, can you give mic to them? Yeah. So, what you learned from today's session? Don't see them. It's not interview going on. I'm just asking you informally. I'm just 2019 graduate, so be informal. Go ahead.
About IEEE.
Wow, nice question. Nice answer in a very short form. Elaborate. No, what you learned. What you new learnings you got. I know you do. You were not aware about IEEE before. So, do you think that it is actually relatable to your undergrad degree, which is going on? You can do a lot of stuff there. Do you think it's a lot of hard work that I need to put in to understand about these things, or it's easy?
I felt it's easy, but I felt that first year I need to take membership in this.
Oh, obviously that's the first step. That's it? Okay, perfect.
Sir, actually, we want to learn about we want to know about the different services offered by IEEE producers.
Come again?
We actually got to know about different services offered by IEEE. So,
different opportunities and benefits.
Like the certification courses you should do, like the IEEE Spectrum you should do.
Yeah.
And many other things.
Yeah.
Chaitanya's IEEE brand experience and see.
I will share the slide deck with the organizer and they can shoot it out in the departments. It's totally fine. So that's what, right? What about second guy? Yeah.
I just got a new contact.
Huh?
I just got a new contact.
Me?
Yes.
Okay. So you should make friends sitting in the audience as well, right? Yes. See, don't be afraid about faculty members. You are paying them, right? You are paying your degree. No, there was a first year my orientation happening. That was first week, and my director came in the auditorium, knock knock, and he was like, "How many of rupees you are taking from your parents' pocket to give to your BTech?" 88,000. That was my annual fees, and then he calculated right away on the table. If you calculate fees for one class, it's around 120 or 140 rupees. It depends upon you. How you're going to take that 140 fully consumed from the faculties, right? You should talk with them. They are the source. They are the experienced people. They have already done whatever you are doing right now, right? That's why the difference comes. Experience really counts, right? Okay. Now this is post-event feedback session is going on. Yeah, go ahead.
The different services offered by
Don't copy paste. Don't copy paste. Something else. See, a person is taking a pic. Do you think that this loser-based pics, you have to speak, right? You have to take a good pic. Huh? Sorry? Samisa. Okay.
different opportunities we can get to the membership.
Nice kind of a privacy you came up with that. Something else? No, that's all. What do you think? Like, you are in BTech electronics. Now, what are the different opportunities you can explore in IEEE?
Like we can meet different electronic engineers who are like experts in as
Now, obviously, I am not asking you to mail him directly right away. You have to explore the ways how to reach him. What are the different members along the way? What are the different insights you can get? Don't limit yourself. That's again I'm saying, right? DQ matters. Don't limit to yourself to India. A lot of stuff are happening. See, the fluent English I am speaking today, it's not because of that I have trained or so I have been doing some courses English speaking. No, not at all. It's all about the environment that you connect with. I never came to South India. That was a kind of a bucket list for me. Right now, East India is pending, so I will cover that soon. So I don't have any South Indian friends, but now I have South Indian friends, West, North, Center. East is pending, as I told. So connect, explore, and try to explore their mindset and culture. Today, I had learned this before in the first talk at Andhra Pradesh when I was in Bangalore. South Indians don't have spoon; they eat rice with their hands, right? So North Indian don't have that habit. So we are very hygienic. Like, not obviously you are also hygienic. I am not kind of ignoring that fact, but I have a habit of eating by spoon, right? So these kind of new culture you understand, right? How they eat, how they speak, how they interact, what kind of different languages and kind of barrier they have, how they drive on roads, all the stuff, right? So these comes when you explore different countries, different cities, and all the stuff, right? Then go through different people. Yeah, this is my kind of a habit. Whenever I fly alone in an airplane, I always make a friend sitting side of me. So it's good habit to make new friends, connect on LinkedIn, explore their profile, try to make an opportunity. You don't know who's sitting next to you in airplane. You don't know who's sitting next to you. Obviously now you know because you are sitting in a group. So, but you have to understand, right, this fact. Any other students? What about these guys, 2 students? You are in PUBG, you are playing PUBG or what? Nothing, okay. Mike. This is my habit. When I start a session, I ask all the students, where's your phone? They will show like this. And I'm saying, put silent and put in a pocket. That's all. Yeah. Did you had you lunch? Did you had your lunch? Yes. Speak loudly, no.
new platform to explore.
New platforms to explore. Okay. You are in first year electronics.
Yes, sir. So this is actually very new. So
I've never seen, listened to any of the site or anything, so it's kind of confusing.
Okay. So have my membership ID, and when you apply for membership, do a referral. I'm gonna get a discount in the next membership as well. Kidding. Okay. So that's good, right? You can connect with Padma ma'am and organizer of SPS Summer School as well, so that you can get to know how to join IEEE. It's a simple fact, IEEE.org. Sign up using Gmail ID, do the membership. That's all. Every year you have to pay. Okay. But again, $13.50 doesn't matter if you are getting globally recognized, globally connected with great people, right? That's how ROI comes here. Anyone else? All good? Yeah. Yes, ma'am. Mike. Yeah, sorry, ma'am. Mic is not working, sorry, I can't hear you. Now it's working.
No. We have to increase our DQ level. That is the important.
Yeah, that's very important, ma'am, because companies are looking for it. There was a story, like, if I would like to recite. We have time, right, Padma ma'am? 3:44, right? 4 o'clock till we have. 3:45. Okay, 1 minute I have. So let me quickly recite this story. There was a salesman, two salesmen in a shoe factory. Both of them are shooted out to South Africa in a different location. Their company sent them. One person was so negative. He was saying, "Are they don't wear shoes? They don't wear, like." I'm just saying, no, I'm not discriminating them. Obviously, they wear shoes and slippers and all the stuff. It's kind of a story and learning from it. So they don't wear shoes. They don't have habit to wearing shoes. How are we gonna sell the product there? So he was frustrated. And the second guy thought of, wow, that's a global opportunity. We can expand our circle of company to South Africa, where they didn't even know what a shoe is like, right? The when they were asked to submit a report, obviously you know the person who gonna get on a higher position and who gonna be the lead for that country, the second person, right? So that's where I think the diversity really matters, and companies are looking for students who are more diverse. People, students are like companies are strongly actually working on these aspects after lockdown, after pandemic, that they should get those people who have the reachability to different countries, reachability to different people. When my company got to know that I'm going for Chile for doing an IEEE activity, they were so happy. And they were like, wow, that you have connections in Chile as well. And my manager pinged me personally, hey, Ramnik, how to join this IEEE? Yeah? So that's how we can actually motivate and other people as well around the circle, to make them aware that it's very important for us to understand what are the things that are going around in the market. Don't please limit yourself to your syllabus and curriculum. That's very dangerous, John. Come out of it, right? And that's where we can make it done. Yeah, thank you. Perfect. Then I guess time is already up. Now I would hand over the stage to the moderator, and I will stop my presentation.
Thank you. He works as a volunteer. He don't stop his work. So always, whenever we need any doubt regarding anything, so ma'am, I will work. This is my office time. So I will clear whatever doubts you are having after my office hours. And he won't sleep until his task is completed. He won't see time. That is his commitment. Okay, that is very, very important. Whatever job we are taking up, whether it may be small or big, commitment is more important. So even though I am having a lot of experience, 25 years, more than 25 years, I have learned many things from Ramnik. I can proudly say that. Okay, actually it is good when we are organizing few events in collaboration with the India level, sometimes global level. So his commitment and bringing all the members into one platform is tremendous. So still here I am facing problem, Rami. So I am unable to pool my even in our college. That is your great positive point. You are able to pool across the country all the members for doing multiple roles. How can I do that?
I would say see, this is one of the facts that I actually heard from PhD scholars as well. They say that no, we are busy in PhD, we can't do MGA committee volunteering, India Council of Art and volunteering. Again, the same thing comes. You have to adjust your energy, not time. So obviously, I sleep. I do sleep. Like people think that I don't sleep, but it depends. Like whenever you are stick to one single responsibility, being an organizing chair or something, you have to understand the importance of it. Like in Srimad Bhagavad Gita, we say this that don't think about don't think about the results. Think about the process and enjoy it. And that's what we should do. Don't think about the outcome, what's going to happen. Just enjoy the process and execute. It's up to the audience how they're going to take it, right? And being faculty members who are here, like if they want to volunteer in IEEE global teams and IEEE India Council or Art, and simple fact, keep your eyes, ears open so that you are well aware what's happening. My first task when I joined in IEEE second year was to follow all the IEEE related Facebook pages, LinkedIn, join the group of different countries so that I am well aware what kind of activities they are doing. So I won't repeat in my student run. That's what I did in my second year. So as a chair, we should know about that aspect and slowly connect with the people. And this was another fact that misconception I was having. Dr. Ramlata ma'am cleared me this out that I'm kind of shy enough to ask some favor from someone. And we always do this, right? We say, Are Baba, we are like becoming selfish. Why should we ask for admission from that professor for his university? But no, you have contributed, you have impacted something along with them, you have volunteered with them. It's okay to ask. Maximum time they won't be filing a FIR against you, put him in jail, why he asked an admission in my university. They will say a simple no, right? So it's fine, right? Just ask question. That's what I would say. That's one of my base line which I always focus on. Ask question whenever in doubt. People will reject you. People will say no to you. Just move on. Just that's a fact. I would say. Yeah. That's so much.
Thank you, Rami. Now, Pratibha will take up validity session.
Yeah. Thank you very much, Ramnik. Thank you very much for your journey is very impressive, and your enlightenment towards all IEEE products and services really make our students much use of it and get through it. Right. With this, we are concluding all session talks, and we are handovering the floor for validatory session. Thank you, guys. Thank you very much.
అదే సార్ ఉన్నారని చూడయ్యా
డైరెక్టర్ సార్ కూడా అక్కడికి వెళ్ళారు లేదో తెలియదు ప్రిన్సిపల్ సార్ అయితే లేరండి
ఒకసారి ఆన్ చేయండి వీడియో
స్క్రీన్ పైకి స్క్రీన్ పైకనండి
అవసరం లేదు లేదండి
సరే ఇది ఎంత మేము చూసుకో కూర్చొని పంపించండి.
I'm unable to hear. Dr. Padma, actually, I cannot hear anything what is said from the podium. The output is not coming out of.
Hello, ma'am. Celia, ma'am. Hello, ma'am. Is it audible now?
It's fine now, a little bit louder.
Yeah, thank you, ma'am. Thank you. We're glad that 110 participants have attended this event where the participants got immense knowledge and exposure in the field of machine learning. We have invited eminent experts and researchers from various institutes like IIT Delhi, IIT Indore, IIT Guwahati, IIIT Hyderabad, and NIT Patna. And we also invited the resource persons from industries like Amazon, AMD, CCMB, etc. 10 lecture sessions have been organized during these 3 days. The sessions were targeted mainly on areas of machine learning with signal processing applications. In addition to the lecture sessions, hands-on session on Python programming and implementation of machine learning algorithms were also conducted. Also, one panel discussion is held with the experts from industry and academia, where many challenges and opportunities in the field of machine learning were addressed. Poster presentation session is also held where 30 posters were presented by the participants from various organizations. So with this brief report, I would like to thank the management of VNRVJIET, Principal Sir, Director Sir, Head of the Departments, IEEE Hyderabad section, and organizing team, and also participants for your support in successful conduction of this event. Thank you all.
Thank you, sir. May I now request Dr. Y. Padmasai Garu, General Chair, SPS, to address the gathering.
Good evening to one and all. Thank you, Celia ma'am, for joining us. So really, SPS is giving a lot of opportunity for all of us. I already addressed the same thing in the inaugural session. Even though now everyone is talking about AI and machine learning and deep learning and only focusing on CSC, I don't accept that. Actually, all AI and machine learning, all those things are within our curriculum. So we have to learn fundamentals thoroughly, including maths, so that we can adapt technology quickly. So we should not worry whatever technology it is coming across. We have to update. Such platforms are available by using IEEE. So I thank all the members who are supporting this event directly or indirectly. So even though we have planned this event in the month of, I think, April, whoever is committed to give talk, even though each one is very busy with their academic schedules, not even a single member, they didn't obey their slot. That is the commitment. So even though we are having n number of works, we have to prioritize accordingly. So as the technology is changing, it is not possible to learn from books. Already Desai sir also mentioned,
even though all the students, even though they are sitting in the class, only 30% learning happens from the class. Remaining 70% from outside the class. So for even faculty members also, when you are interacting with outside members, we can learn quickly whatever the things that are happening globally. So don't miss the opportunity. Already Ramnik mentioned you should question. When you are unable to follow anything, we should ask. Even though I born and brought up in the village, I never compromise. I used to sit in the first bench. If I am not following, I will simply stand up and ask. Okay, so we should have that habit. And whenever we want to do any activity, you should not worry about that one. Take it positive way and start implementing that one. Automatically, you will get success. Okay, so now you have to be part of any professional society. Actually, I am active volunteer in 6 to 7 professional societies. Okay, so generally, most of the time, many members, even though I joined assistant professor at VNR, I take my CL to attend some programs outside. Okay, I don't see whether it is Sunday or Monday. Okay, we should have such thing in our resume. Okay, why? Because I already mentioned now when we studied, all these technologies are not there. But we have to update as per the needs. So before telling to the students, first we should practice. Already because of digital transformation, everything is available online. Okay, make use of that platform, try to learn as many as possible. So now because of cell phones, students are also always watching cell phones instead of having book reading. Okay, so please read a number of books when you are young. Okay, try to attend more events so that you can learn from eminent speakers. Within no time, you can learn many things. I thank all the members for supporting me. Whenever we are organizing any event, all the time principal sir and director sir will give 100% freedom to me to organize and plan, invite, and all. I will take care of all those things with the support from both of them. And our management also already mentioned during inaugural, it is not for profit organization. And so whatever activity we want to do at the institute, we should give representation so that they don't say no. Now this is funding is supported from IEEE. Even for non-IEEE events also they will support 100%. So I thank management members, our president, Suresh Babu Garu, General Secretary Sashkir Rao Garu, because of some personal commitment, they are unable to join this event in the evening, and Vice President Sri Durga Prasad Garu, and all my colleagues. Without their support, it is not possible to organize this event, both streaming online, and that is done by Srinivas, Santosh, Balaji, and Pradeep sometime. Okay, and Kishore. Actually, all my colleagues are very supportive. Because of them, I am able to do all the events in the institute. I thank all the members of the Department of ECE and other members who are supporting it directly or indirectly. Thank you, one and all.
Thank you, ma'am. May I now request Mr. Ramnik to address the gathering.
Okay, so I guess like this is the first experience I'm going to give a valedictory kind of speech. Okay, so I won't take much time. So first of all, thank you so much, Padma ma'am, and whole IEEE VNR as well as VNR management for inviting me out and getting flew from Haryana to Hyderabad. That's the second chance I'm going to get here. So coming to the topic, latest trends in machine learning, signal processing application. I have been like closely working in machine learning and AI and integrating into with signal processing. It's kind of a unique aspect that we should bring on the table
to brainstorm and discuss with the undergrad students, and that's what we did through these 3 days of summer school. And I really acknowledge every single contributor, volunteer on the backstage who have been working on poster, agenda, Excel making, and everything, whatever is actually on the backstage. It's a wonderful job being done. As ma'am mentioned, one person can't do anything if there's no support from the management, not even a support from the IEEE entities support. So kudos to everyone. Congratulations for finishing out successfully the first edition. Coming up next year, I'm hoping maybe in winters or next year we can execute the second edition of this, because it's a very important aspect that we should focus on. That's all. Thank you.
Thank you, Mr. Ramnik. Now I take the privilege of inviting Dr. Salia Shahnaz, Professor, Department of EEE, BUET, Bangladesh, to address the gathering.
Thank you very much for the invitation. Hope you were able to listen to me. Am I audible?
Yes, madam.
Hello, am I audible to all of you?
Yes, madam.
Thank you very much for your effort. Let me share my screen very quickly. I will be quick enough to share a few things on behalf of Global Signal Processing Society. Hope you are able to see my screen. Are you able to see my screen? Hello?
Yes, madam.
Okay. So give me 1 minute, few seconds. Let's see. Thank you, Dr. Padma, for taking such a wonderful initiatives with your team. It's a teamwork. So I would like to take this platform to express my sincere gratitude to everyone who directly or indirectly supported my successful election as 2022 IEEE Women in Engineering Committee Chair-elect. I will be chairing Global Women in Engineering from 2021 and 2022. It's a great opportunity to serve all of you. And I like to thank IEEE WIE for their immense support in spreading this congratulatory message to all members of IEEE Women in Engineering in the whole world through their email burst, through their newsletter, through their Facebook and a website and other social media. It's a very good practice and we should follow that. Just for your kind information, IEEE Women in Engineering magazine is an award-winning magazine. In their June issue, they have published the interview of myself as the historical phenomena as the 2022 first Women in Engineering Committee Chair-elect, because since 1993, this is for the first time Women in Engineering Committee Chair has been elected by the global WM membership. You know, I will share many of you may already have it, but if you don't have it, I will share with Dr. Padma so that Dr. Padma can share it with other members so that other members can reach out to me to let me know how I can help you. It's not just about me and my accomplishment. It's about a story of commitment and hard work, okay? And it is really important to reach out and to listen from all of you so that I can dedicate my more time and talent for all of you. I humbly request you to visit my Google Scholar citations, because it is very important to know that despite all limitations, how along with my students I have been publishing in impactful journals and conferences and reached to citation more than 1940, having 8 index 2022 is another journey in the research and innovation. uh, at this moment, I'm chairing Global Signal Processing, Women in Signal Processing. And in that capacity, I would like to share some resources so that you can get benefit. Apart from it, I serve an IEEE History Committee and working with IEEE Milestone and also IEEE Educational Activity Board in Faculty Resource Committee, in IEEE New Initiative Committee. I was founder of Women Insight Working Group for the whole world, and also served in Global Site in the steering committee twice. And most important, I served as a member of IEEE Women in Engineering Senior Member Elevation Drive. I was the first female chair of IEEE Bangladesh section. Of course, I was the founder of IEEE W Affinity Group and site group in Bangladesh. I have been in academia in research innovation for more than 21 years. I'm the founder of 4 technical society chapters in Bangladesh, like Signal Processing Society, Robotics and Automation Society, Society on Social Implications and Technology Society, Industrial Applications Society. Apart from it, if you visit my Google Scholar citation, you can know that my work is related to engineering, medicine, biology, power and energy, and also and so many other fields like computer society and computational intelligence society. This is very important to create an appeal among students and young professionals so that they can be part of at least one technical society of their interest. However, as Signal Processing Society is my parent society, I will appeal to the graduate students to be part of it, because Signal Processing membership is only $1. This is actually what I have presented to Signal Processing Membership Board as a board member. These are our respected committee members. We have Monica from IIT Delhi and other committee members who are from diversified IEEE regions with diversified IEEE, I should say, expertise. I'm proud of them. You know, previously, Signal Processing Society Women is focused on the flagship event only. As a in ICAS, which is the flagship and major conference, and then ICIP, okay? But as a chair of Women in Signal Process, I suggested the board to spread the event all over the world. This is just an example in Malaysia, IEEE ICCPA 2021, where we have ran a Women in Signal Processing track and also women in and also young professional track. It's just an example. Similarly, I will request that if you have any signal processing event, please keep a woman in signal processing track to be more inclusive. And because diversity and inclusion is one of the major agenda of IEEE as a whole. In 2021, actually, in the ICIP, we did some visionary, I should say, panels connecting industry and different related sister societies. Like we invited Chief Technical Penguin from IBM Z, and also we wanted to know from Dalma Novak, who is past past president of Photonic Society and Division 10 director. We wanted to know the best practices for advancing diversity and inclusion in IEEE technical activities, because she was serving as a chair of diversity and inclusion in CAB. And Caroline is one of my best friends from Canada, Region 7. She actually showed how the technical activities and innovation and betterment for the society can be done in engineering and medicine biology society for supporting diversity and inclusion. And finally, I have invited Kathleen Kramer, who is now running as a president-elect candidate and sharing good practices across her society, which is an aerospace and engineering society, and she is also part of signal processing society. So actually, we wanted to know the good practices from other society chapters. So this is my suggestion, that whenever you do any event from signal processing society, invite speakers from other related society to know from them, to have a sister bonding, to have a collaborative relationship. And we've again started to celebrate IEEE Day. And in that celebration, we again focused on collaboration with other related society, and we invited Maiti, who was chair of IEEE ComSAC, Women in Communication Engineering. She's from University of Virginia. It was a good learning experience from her. And from 2021, we started celebrating International Women's Day. This year we did with Dr. Nelly Prasad, who is IEEE Vehicular Technology Society Vice President for Membership Development. Her talk was pretty interesting, unlocking the potential of smart applications using AI and robotics. This is disciplinary research. And the biggest event was ICASP, with I said, this is the largest conference, flagship conference, where we again remain focused with connecting with others and increasing the visibility of signal processing society beyond signal processing. That's why we have invited our keynote speaker, Barna Deite, who was the past president of IEEE Computational Intelligence Society, a great promoter of diversity and inclusion, and also Leila from University of Maryland, IEEE Division 8 Director-elect, past president of IEEE Computer Society. We also wanted to inspire our women in signal processing and other signal processing members to know what are the pathways from academia to industry and entrepreneurship, and what are the potentials for WISP members. And it was really interesting to listen from Joanne, who is chair IEEE Entrepreneurship Committee, Vincent Jupuri, our very own friend. She is now Region 8 Director. FK from Hawaii, she's a VP there. And Ravi Kiran Annaswamy, who served Region 10 with me. She was Region 10 Secretary when I was Region 10 Women in Engineering Chair in 2016. He is my very good friend, and it is a great honor that he has been elected as the president of IEEE Technology and Engineering Management Society. That gives us a scope how the business people and entrepreneurs can train us to be future entrepreneurs. So to spread signal processing WISC work to more people, so we have divided we have formed and invited our subcommittees with special themes. Like for the first theme is diversity and inclusion, benefits, service, and opportunities. Dr. Padma Sai is working in that committee. We have another focus, industry, academia, engagement, education, and new initiatives. Oslam from Facebook is working, and SPS chapter chair of Hyderabad, Lalita, is in that committee. And it is really important to focus on grade elevation nomination awards. Alexandra from IBM is chairing that committee. And also, it is really important to ensure our empowerment through technical activities, awareness, and communications to enhance the visibility. Marianne, my very good, talented friend from Region 9, is chairing that committee. So it's a great honor that many people, from 5 people as a committee member, now we are spreading around the world and giving more opportunity to more people. And it is their potential, they are our future leaders. And this is a good mentor and mentee program. Actually, this is the major activities which can be also scaled in the local chapters, like International Women's Day. Please encourage participation in ICAS, WISP International Women in Engineering Day. That is on 23rd June 2022. WISP IEEE Day event we are planning. ICIP event we have already planned. It is in the month of October in France, and it is also important to talk about socially relevant topics like breast cancer awareness campaign. So this is just an ideas that we have planned from the committee, and we have a lot of plans for the subcommittees like academia and industry representative in chapters. This is under our subcommittee 1, and new initiatives like we wanted to spread signal processing knowledge, and we found that if we do webinars in local languages, I will be talking with Dr. Lalita and Dr. Padma that how we can organize webinars in local language in Andhra Pradesh and other parts of India and other parts of the world who has language barriers, so that we can have a better outreach. And in our industry subcommittee, we are planning an industry academia conclave, and we are in a campaign to identify women, men industry representative from each chapter. And also we are collaborating with industries for scholarship like IBMZ, Hawaii. For our subcommittee 3 for grade elevation, we are really want to run the senior member and fellow elevation drive, and we want to nominate identify and nominate the accomplished women and men for awards and recognition. So as for visibility, as when I was communication chair of IEEE Global side, I have introduced the humans of IEEE side, where I have interviewed many root level volunteers like Amarnath Raja, who was the founder of Humanitarian Activity Committee as an ad hoc from Kerala, and many other accomplished volunteers. So similarly, we want to launch Humans of WISP. I will request that short interviews from the chapter chairs to help me identifying those. And it is important that SPS is coming with 75th anniversary. So I have taken the oral history training, how to capture oral history from the IEEE Life Fellows. So we are identifying WISP Life Fellows for their interviews through oral history in collaboration with IEEE History Committee. So if you know any Life IEEE Fellow in signal processing, who is a contributor in chapter, but yet to get another recognition after many years, please connect him or her with me. Another important achievement is, since I am working in women in engineering for many years, so it has been around more than 19 years I'm working with women in engineering. So last year I have proposed this women in engineering pledge to signal processing precedent, and they embraced it and approved in the board a very wide diversity statement, like to include diversity, equity, and inclusion in all its operations. I like to see the women in signal processing women to be general chair, editor-in-chief, associate editors, program chairs, members, panelists, distinguished lecturers, chapter chairs, officers, and like that. It is really important to ensure your technical competence to the rest of the world to be a leader. You'll feel good and you can serve the community. We started International Women in Engineering Day with Karen Panetta, who was IEEE chair, and she was our inaugural speaker, and she is also chair IEEE SPS Boston chapter in Region 9. Her topic was artificial intelligence solution benefit humanity. It was amazing to start this from Signal Processing Society for the first time through Dr. Karen. And in ICAS 2021, it's amazing to have Susan Cathy Land, our IEEE president of 21, to invite to Signal Processing Society. And also Leah Jamieson, who was IEEE president in 2007. And she was also president of IEEE Signal Processing Society. And in between, we have invited Dr. Vandi Verma from NASA, who was working on robotics. She has shown us the reason and motivation to work between signal processing and robotics. And we wanted to know what our SPS and women in engineering leaders have vision for promoting diversity inclusion in technical activity. We could listen to Ahmed Tawfiq, who was president signal processing that time, Athena, now the president, and Jennifer, who is chair of IEEE Women in Engineering now, and Thule, who is the vice president of technical direction of IEEE Signal Processing. This for the first time, chair and chair-elect came. And also our very own Professor Hari was the vice president membership IEEE Signal Processing Society. It was an amazing gathering and life learning experience. So if you want to join Women in Signal Processing, go to our website and add your information to the Women in Signal Processing directory and learn more from signalprocessingsociety.org. And let me tell, I was the founder of Signal Processing Society chapter in Bangladesh, as I said. It was a very young chapter in 2018, just founded in 2000. And immediately we applied for fund, a membership-driven fund, Winter School 2019 on multimodal signal processing. We have 70 participants face-to-face, 11 instructors from industry and academia in there are 5 different country speakers from Malaysia, India, USA, Uruguay, and Bangladesh. This is the picture. You can see Professor Hari, and we have a good record of winning signal processing cup competition every year from our university in Bangladesh. Also, video and image processing cup competitions. It is a great honor that I have been serving as a supervisor of signal processing cup competitors since 2015. And from Signal Processing chapter, we have launched our own conference, IEEE SpeaksCon. I have a vision to collaborate with Hyderabad and other chapters for next vision. Also, it's a biennial conference, and we also did it in 2021, and we plan to do it in 2023. I expect and giving a call invitation to Hyderabad SPS chapter and other collaborators, student-run chapters, to have a collaboration, because IEEE WICON ECE, Women in Engineering Conference in the area of electrical and computer engineering, for the first time in the world, was held in Dhaka. I was the founder, and from next year we started doing between Bangladesh and Pune section, Bangladesh Uttar Pradesh section, Bangladesh Bangalore section, Bangladesh Bhubaneswar section, Bangladesh Thailand section. This year we are going to do it Bangladesh and Madhya Pradesh section. Hope. Similarly, this SpeaksCon we can also do between 2 organizational units. And as a result, our signal processing chapter got the chapter certification in very early stage because of the huge number of quality, even like Winter School, SpeaksCon, many distinguished lecture program, industry event, and also our related chapter, EMBS, Engineering, Medicine, Biology, became 2022 IEEE EMBS Regional Outstanding Chapter Award winner. Only 2 chapters got it. Region 9 and Bangladesh. In this way, staying in Bangladesh, doing impactful activity, we could raise the visibility not only for Bangladesh, of the whole region 10 to the rest of the world. So if we can do it, I think the Signal Processing Society student run chapters and the professional chapters, if we can work together, share the resources together, we can do together and we can really lead this smart world. I like to thank this organizer to do this really 3 days timely topic, recent trends of machine learning in signal processing application, which is one of my favorite research area. If you visit my Google Scholar citation, you will find that majority of my papers and my transactions papers are related to signal processing, machine learning, and deep learning applications. It's a great honor to be part of the panel discussion in the morning, and it's a great opportunity that I could share, and it's a great thing that I could share the opportunities from Global Signal Processing Society to you. Hope it will benefit you. And I have offered the collaboration opportunities that we have already started. Thank you, Padma Sai, and all the talented team members. And I want to tell you, no matter what, if you have a merit, if you have a passion, if you have hard work, if you do hard work, your actions will be spoken, and we want this. And to do this, what we need to do, we just need collaboration and fiercely support each other so that we don't break into pieces. That's very important for technical achievements, staying in this subcontinent and making other people to hear our voice. And this is a technical voice, technical skill enhancement, and sure we can do it. Thank you very much. You have already done it. Take care and stay blessed. I'm unable to hear.
Hello, ma'am. Can you hear us?
Yeah, loud and clear.
Thank you, ma'am, for sharing your insights about pathway plans to connect industry and academia, spread signal processing to maximum people, benefit from it, and explore the opportunities, empower our technical abilities in communications and signal processing. We look forward to spread our wings through this network.
Again, not coming. Sound is again not coming.
Hello, ma'am. Am I audible?
Fine.
Yeah. Good evening, one and all. On behalf of IEEE Students Branch of VNRVJIET and IIIT Hyderabad, I take this opportunity to propose the vote of thanks. Firstly, I would like to thank IEEE Signal Processing Society for giving us the opportunity to host this wonderful event. I would like to thank our guest, Dr. Sadia Shabarinath ma'am, Professor, Department of IEEE, BUET from Bangladesh, for enlightening us today. Thank you very much, ma'am, for spending your valuable time with us today. I thank our speaker, Ramnik sir, for his presence and encouragement to all of us. Thank you very much, sir. I extend my heartfelt thanks to the management, principal, sir, director, sir, for their timely help in conducting this event. Today, I am short of words to express the gratitude to Dr. Y. Padmasai Garu, Dean Students Progression, and Dr. S. Rajendra Prasad Garu, Head of the Department, ACE, for their constant help, support, motivation, and guidance that radiated a source energy within us. This event could not have been so successful without your guidance. Thank you very much, ma'am. I thank all the speakers for coming forward to enlighten the young minds in the field of machine learning and signal processing. I would like to thank all the faculties, teaching and non-teaching staff who have helped us either directly or indirectly for the smooth conduction of this event. Finally, I would like to thank all the participants and delegates for your interest in attending this event. Thank you, one and all.
I request everyone to stand up for the national anthem.
जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड़ उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मागे गाहे तव जय गाथा जन गण मंगल दायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे
Thank you. Please join. Ma'am.